and I hope you'll be enjoying that. So, Munal,
Hello,
Hey,
hello. Can you hear me?
not
Tejas?
yet. We
yes,
were able to see
yes,
your picture, but not extra.
I can
No.
hear you.
Okay.
No, I.
Good. Hello, everyone. Welcome to Azure Conf 2021. Uh, we'll start off the session with a session by Tejas. Tejas, I'll start sharing your screen.
Yep.
Okay. Okay. Thanks, everyone. Tejas, the stage is all yours. You can
Okay.
start.
Thank you. Um, Hi, everyone. My name is Tejas Chopra, and today I'll be talking about compression, deduplication, and encryption conundrums in cloud. I'm very proud to be part of the conference today, and thank you all for joining me. The agenda for the talk is as follows. I'll go over a brief introduction about myself. We'll go over some of the basic features of cloud storage, especially. Then we'll get into specifics of compression, deduplication, and encryption and what they mean, the right order of applying them, and finally some takeaways. So, I'm a senior software engineer at Netflix. I work with the data storage platform group, and my job is to architect storage infrastructure and solutions on cloud and on premise to support the exabyte scale data and billions of assets that are created, managed, and stored by Netflix studios and streaming platforms. I'm also an international keynote speaker, and I talk on distributed systems, cloud, and blockchain. Prior to Netflix, I was a senior software engineer at Box, where I was again working on architecting infrastructure solutions to support petabytes of data and millions of customers. I have experience working in companies such as Apple, Samsung, Cadence, and Datrium. A lot of organizations today are moving to the cloud, and the footprint of data in the cloud is exponentially growing. And the reason that the organizations choose to move to cloud is because of ease of manageability, scalability, and pay per use. Because organizations and enterprise want to focus on their business goals, they let the infrastructure be managed by cloud. You may think that this solves all the problems for the organization, but that is not the case. There are a lot of complications trying to model the costs that are associated with cloud. If you just take the example of storing a file on cloud, you actually pay a request cost for putting the data in the cloud. You pay the cost to store the data in the cloud itself. And finally, you also pay when you want to read the data out of cloud. Now imagine if you are Box that has hundreds of petabytes of data or Netflix that has exabytes of data. If you just read the files from cloud, that itself will run into billions of dollars over the course of 5 years for these organizations. Traditionally, for a regular cloud user, the way to reduce the cloud bill has been either right sizing, that is, picking the right size of the instance, or having reserved instances, or trying to optimize storage. These are the only three means in which maximum benefits can be yielded for reducing the cloud bill. Traditionally, on-premise file systems have used techniques such as compression and deduplication to reduce file footprint. Can we use the same technology and techniques to reduce the footprint of data on cloud, just like we do with on-premise systems? That is what we'll look at in this session. So compression is the ability to reduce the size of the stored object by compressing the object during the writes and reading back the, uh, the actual decompressed object during reads. There are several techniques of compressing data, such as LZ4, LZIP, and GZIP. Some of them are lossy techniques and some of them are lossless techniques. One thing to note is that not all data is compressible. For example, media files are not compressible, images are not compressible, but text files give great compression ratios. Overhead for compression is generally less than 2%, and this is overhead in terms of memory because you need to store the streamed bits first in order to compress them, and also overhead in terms of latency because compression takes some time to be performed. This is very acceptable for file storage use cases, but it is not acceptable for cases when you want to stream videos. I have seen compression ratios of more than 5x at Box for text files. The second one is deduplication. In deduplication, you store one copy of the file and hand out references to users and applications. So the idea is that you may have duplicates of the same file in cloud, and you just want to keep a single copy and not have many duplicates lying around. Uh, but this makes handling deletes and other operations tricky because files are not deleted from the backend unless all the users and applications delete the file. You may wonder, how do you check for duplicates before storing a file? Now, there are two ways to do that. One of them is online deduplication and the other is offline deduplication. With online deduplication, you actually do not even send the file to cloud. So you somehow, and we'll get into how you do that, recognize that the same file exists on cloud and your client will not even stream the bits to cloud. With offline deduplication, you end up sending the file to cloud, but you have a daemon that runs in the cloud that will periodically compare all the files in the cloud and delete the duplicates. So far, I've been talking about duplicates in terms of file granularities, but you can actually have duplicates at even smaller granularities as well. For example, at Netflix, the deduplication happens at chunk level. So what are the advantages of such an approach? Let's say that you have huge files, that is the case with media files, and you've only modified 1 pixel of the file. Now, if you store the file as is, then the file will not get deduplicated because it's a new version. But if you've chunked the file, 99% of the chunks will remain the same. Only the chunk of the file or the part of the file that has that modified pixel will be different. So that way you can actually get better deduplication ratios if you have finer granularities of or units of data. The other important point to note is that deduplication boundaries are often dictated by security. For example, at Box, even though you were able to deduplicate files within the entire Box corpus, but you would often only deduplicate within an organization or within an enterprise. And this was dictated due to security reasons. So this here shows a very good way of imagining deduplication. The hash values are generated from each piece of data that is stored in your data store, and then you identify the duplicates. So hashes are nothing but digital signatures of the file. And even if a single pixel or a single character of a file changes, it will have a completely different hash. And finally, your duplicates are replaced by pointers to save on storage space. Coming to the last part of it, encryption. Encryption implies obfuscating the data to avoid unauthorized access on the wire or at rest. Encryption over the wire is solved by SSL endpoints and TLS. There are two strategies used by enterprises to encrypt content that is stored on cloud. The first one is client-side encryption and the other is server-side encryption. In client-side encryption, the client, which is the machine that is uploading the file to cloud, will encrypt the file before it sends it over the wire to cloud. In server-side encryption, the machine will send clear text bytes, but because it is sending the bytes to SSL endpoints in cloud, it will actually have encryption over the wire. And the server will actually encrypt the content before storing it locally. I have seen that at both Box and Netflix, client-side encryption is generally preferred. Because server-side encryption was added later on, and these enterprises and organizations had already developed software that runs on servers and on top of cloud. So they started with a client-side encryption and they have stuck with it. At Netflix, file sizes are often greater than the max size supported by the cloud provider. So we have a layer on top of the cloud provider, S3. We use AWS at Netflix. So we have a layer on top of S3, which chunks a file into smaller pieces and uploads them. This is the same layer that chunks and deduplicates the file. Each chunk is separately encrypted with a different encryption key. So one thing to note is that encryption implies that once the data has been encrypted, it is not compressible and it is very rarely dedupable. So given that we have learned about these three techniques, what is the right order of applying them is something that we'll come to next. So just to recap, in terms of AWS, you have encryption techniques for both in-flight and at rest. The in-flight techniques use SSL endpoints, and your at-rest techniques are either client-side or server-side. On the client side, you encrypt your data before sending to S3. On the server side, you use S3 in multiple ways for data to be encrypted, and the key management system could be managed by S3 or it could be managed by the client. So when it comes to ordering, you would like to order in a way that your data is encrypted last. Because once the data is encrypted, you cannot compress or deduplicate the data. If client-side encryption is used, which is the case in both Netflix and Box, it means that you have to employ online deduplication and compression on the client side. Design can get very complicated in such scenarios. I have discussed that at Netflix, every chunk is encrypted with a separate encryption key. We are exploring ways in which we can maintain a single encryption key, not just per object, but per pool of objects. What that means is that if there are two objects that belong, or two chunks that get encrypted with the same key, even after encryption, there is a possibility to deduplicate them. So you can leverage offline deduplication techniques if you encrypt using the same key for a pool of objects. This does have implications on security though. The second rule is deduplicate first. So you would want to employ online deduplication techniques. And the way you want to deduplicate first is when the data is being streamed. At that point, you maintain a global pool of fingerprints, which are nothing but hashes of data. And you compare the current object or chunk's fingerprint with all the fingerprints in the pool. This global pool contains fingerprints of all the content that has ever been uploaded to cloud. And if the data is already present, or if the fingerprint is already present in that pool, there is no need to stream that data to cloud. Increase the reference count of the fingerprint and return the reference to the object that is stored in cloud. The reason you want to deduplicate first and not compress first is because compression algorithms can change. By deduplicating first, you're protecting against any change in the algorithms in the future. So given that we have such a system, if you have to design a flow for uploading a file to cloud, what you would want to do is firstly, you want to employ an on-premise system along with a cloud system. The reason you want an on-premise system is so that you can use techniques such as compression, deduplication, and encryption on this on-premise system before the file makes it to cloud. The other reason is because cloud costs explode when you're trying to read the data out of cloud, your on-premise system can cache the hot data so that the read request can be served by your on-premise system and only the cold misses or capacity misses make it to cloud. So when writing the data, you would first try to generate a fingerprint of the data, and you will check if the fingerprint exists in a global pool. Let's say this is the first time you are adding a file, so the fingerprint does not exist in the pool. In that case, you will compress the data and then write it locally. So your compressed bits that are stored locally are then encrypted and uploaded to the cloud. Once the bits have made it to the cloud, you will update your fingerprint table with the hash of the data and the location in the cloud. Now, if we want to read the file, you will first check the location of the file in the fingerprint table. Let us say that this is the first time the file is being read from cloud and there is no copy or no compressed bits on the local storage. In that case, your fingerprint table will contain the location of the file in cloud, and you will actually go and fetch the data from cloud. You will download the encrypted and compressed object. Note that this is different than downloading the entire object, because in this case, your object is compressed. You will actually pay less egress cost when downloading from the cloud. Now you will apply all the software techniques in the reverse order. That is, you will first decrypt the data and store it in your local storage. Now this means that your local storage has compressed bits, but not encrypted bits. They are decrypted bits. Finally, you will decompress the bits and update your fingerprint table, and you'll mark the read as successful. Subsequent reads for the same file will actually be served by the on-premise system and does not have to go to the cloud to have the egress. Some of the takeaways and learnings from this process. Firstly, not all data is compressible. Compression adds latency, so you can remove the step of compression. Many organizations first store the data on-premise and then upload it to cloud. And this, like I said, is to save egress cost. The other reason is that if you imagine a company such as Netflix, where artists work on data, uh, artists typically work on multiple iteration of an asset, and only the last iteration is considered to be worthy of putting in a movie or the final cut. 99.9% of the data never makes it to the movies. So if you now do not have an on-premise system and you put all of this data on cloud directly, your cloud costs will explode. By having on-premise system, you can then store temporary files there that can be deleted and that are short-lived. And that is another advantage of having a hybrid architecture. Encryption is applied at the point of uploads to cloud and not before that. And finally, online deduplication is tough because it requires a lot of state management, reference counting, and concurrent accesses that need locking. So companies typically start off with offline deduplication to get some benefits. That's my time. Thank you so much for joining me today. Please feel free to reach out to me on LinkedIn, email, or Twitter. If you have any questions regarding Netflix, regarding the opportunities at Netflix, please reach out to me for that as well. Thank you.
Thanks for a wonderful session, Tejas. Let's wait
Thank
for a
you.
few minutes for questions.
Yeah. Does anyone have any questions?
If there are any questions, please post them on YouTube or LinkedIn. Okay. Thanks for a great session, Tejas.
Thank you. Yeah.
Thank you. Thanks. Hi, hi, Jen. Can you hear me?
I can hear you.
Hi, everyone. Thanks for joining. The next session is going to be by Jan. It's on the topic is next level security for your Azure applications. Please follow it closely and please post all your questions in the chat window. Let's have a wonderful session. Thank Jan. The stage is all yours. Take it all. Thank you.
Oh, thank you. And thank you for having me at this amazing conference. Good morning, all. Um, well, at the Azure Community Conference 2021, a big thanks to the sponsors, obviously, because without them, we wouldn't be here. I'm Jan de Vries. I'm an Azure software architect at a small consulting firm here in the Netherlands, where it's 7:30 at the moment a.m. I'm doing a lot of stuff within Azure projects, migrating stuff from on-premises to the cloud, expanding the cloud footprint of our customers, mostly Azure, and seeing a lot of stuff which can be improved and should be improved at those customers, at those projects, especially with new services coming out every now and then. So quite an entertaining job, and today I'm talking about the securing your Azure environment, because there are lots of Azure services available to you, some new, some a bit older, and using them will make your Azure environment a bit more secure and a bit easier to maintain in case of attacks and something like stuff like this. I have to confess though, there there are times like a couple of months ago I was still deploying my app services and functions to the public internet, and well, customers were invoking those endpoints I exposed to them, and I thought, well, that's good enough, because Azure will make sure it will be secure-ish, and I have some default basic security. Such a architecture looks a bit like this, having a couple of app services running, some repositories in the backend, maybe some functions with HTTP endpoints, or just having them as workers, website invoking the app services for the APIs, maybe even exposing some APIs via the app services to the partners or customers who want to work with APIs instead of the website. Well, a fairly straightforward design of a common Azure architecture, or at least the stuff I see. And this is, well, good enough for a lot of cases, especially if you're just starting. But the customers I'm working with nowadays are well, getting bigger and bigger, have a bigger footprint, doing a lot of stuff within Azure. And now we have infrastructure people, or people who have specialized in infrastructure. And they were like, hey, Jan, do you know everything you've deployed to Azure, to the public cloud, is in a public cloud, so it's public, hence the public word. So he's like, yeah, that's kind of a security risk. And I was like, yeah, but doesn't Azure make sure it's safe-ish, or better as on premises? And he's like, yeah, no, not really. Well, it does a bit, but this is the public footprint we're working with. So everything is exposed, and even if Azure, well, it does protect a bit, but it's exposed. Every endpoint is exposed to the public internet, and sure, there's some default protection of DDoS attacks, and the people at the Azure infrastructure, or people who work within Azure, do keep some monitoring in place for checking for attacks on global scale, but not specific for my APIs, not specific for my functions. So that's a bit of stuff you have to be aware of. And I wasn't aware of this. Well, I knew this, but it wasn't on top of mind. So this is our public footprint. So I'll show you a function I created just to show you. So I've got this nice solution in Visual Studio with a couple of apps I'll cover later on. So an enterprise function, a starter away from the web, which I'll show you in a bit, and a default Azure function we all probably know and love, with an HTTP trigger, some Swagger attributes which aren't mandatory, but it's an HTTP endpoint with a get and a post, and it will this is just the next finished project. So this when invoking, it's a bit like the local host. Hello, Jan. I'm exposed. I even got it over here. Hello, Jan. I'm exposed, or at least this is a public function. So something we probably have been creating for quite a while. I can even show you this within Azure. So this is the default function we just invoked. So there's one invocation. I did it a test run before starting the session. So this is the one or two invocations I did before. And this is a regular function, nothing special. Just right-click, publish, and be done with it. As you can see, nothing fancy. It's not protected from anything. And that's, good enough in a couple of cases, or if you're just starting, like I mentioned. But it has some vulnerabilities, especially when doing real solutions, which I'll show you later on. Because in real solutions, you probably have some data repositories, like a database, like storage accounts, lots of backend services which only your administrators should be able to invoke, or maybe some functional people. Not stuff you want to have exposed for the public world, for everyone to see. And this is true. This is the public footprint for all environments. So the development, testing, acceptance, quality assurance, production. So all environments are exposed via different CNAMEs, of course, different domains, but it's exposed. And that's might be a problem to you. At least it's a problem for us, because at some point our testing environment came up first in the Google hits before the production environment. So that was kind of something we didn't like very much. So this is something you need to solve, or at least the customers I'm working with need this solved. So and especially the data repositories like SQL storage accounts, but also Cosmos DB, your Redis cache, your whatever you have which stores data should be away from the internet, or at least no one should be able to allowed access to it, aside from a couple of whitelisted services which need access to it. And if you have worked with Azure and with specific SQL Azure, you probably know this check mark, or this toggle, and the client IP addresses you can whitelist. And this is a nice starting point for SQL Azure. It's just I started at a project where we were using this client IP addresses to allow developers to connect to the SQL server, and the list was like this long. And I was there just a week, and noticed at least 5 IP addresses of people who weren't working at this customer anymore. So this is, if you don't maintain this list of IP addresses, it's kind of a security risk. But the same goes for this toggle, the allow Azure services and resources to access this server. at first, before I dove into this toggle, I thought, well, this is scoped to my subscription or maybe even my tenant, but that's not true. Everyone within Azure or every service within Azure is now whitelisted to connect to your SQL server. And as you can see, this is a production server. So that, well, that's quite bad because now everyone in the whole wide world can spin up a VM somewhere in Azure and connect to your production server. Sure, you still need to log in with some credentials, but at least the connection is wide open. So that's quite bad, or at least I think this is quite bad, especially if you're not aware of this. And the thing I struggled with, or I didn't get right from the start, is the DDoS protection. I assumed it was there for every service within Azure, and it kind of is, but we all have the DDoS protection basic in all our services, and as you can see, this doesn't cover a lot. There's some detection and automatic attack mitigations. I'm not sure what this actually means, but it's not much. It's more to protect the Azure platform, or at least that's what I understand from it, and not specifically for your services. So you can upgrade this to DDoS protection standard for your. This is a service which covers your complete tenant. It's like $3,000 per month, if I remember correctly. And it does some, protection of your services. So especially the cost protection is nice when you're using serverless technologies like functions, like Cosmos DB, like, stuff like this. Cost can, rise pretty quickly if you have a DDoS attack, for example. So your service will still be up. It's just your bill will be a bit higher at the end of the month. So this is a nice protection. It comes with, the $3,000 price tag per month. So you have to decide for yourself if that's worth it. Sure, the metrics are nice, and you have some reports, and it's a nice service to have. It's just, a lot of money, but if you're big enough, if you have a big enough footprint, it definitely makes sense. So what the cheapest solution is to protect, or at least what I think the cheapest solution is to protect your data repositories, is by adding a small VNet around them. So having a SQL Server inside a VNet, having your storage accounts, your Cosmos DB, all placed inside a VNet, and only allowed services are allowed to connect to the VNet and to the services inside it. You can even take this a step further with the private link for which is available for some services, which makes sure it's only available to the private link endpoint, which is a nice addition. But this is the basic starting point I try to implement at all customers nowadays, because this makes sure your data, your customer data, is protected from the outside world. Still, your APIs and your logic is exposed to the outside world, but at least your data is safe, or at least safer compared to it being exposed to the outside world. And to get this set up, obviously you need a virtual network within Azure with the subnets for your data repositories, and you need to make sure your app services or functions are allowed to connect to this VNet. How to set this up? Well, they have this VNet integration for your service plan for your app services, which you can state, connect it to integrate it with this specific VNet and on a specific subnet. and be done with it. And now your application is integrated with it and can connect to the data repositories. So that's a nice starting point to be at, because now your data is protected. You still need to do something else though, because you're still exposed, or your workers, your logic is still exposed, which has some vulnerabilities also, or potentially can have some vulnerabilities, especially when people are trying to DDoS your service or trying to do SQL injection or stuff like this. If you have bad actors, they can still bring you down now. So what's next? Well, API management. API management is an API management or an API gateway, depending on which cloud you're in. But it's some kind of, you can see it as a proxy for your backend services. So you're placing this in front of your own APIs, your internal APIs, and making sure all traffic is being routed via API management to the backend. So as you can see in this diagram, I now have the website. The public internet is now all making requests to API management. API management is integrated or placed in within this VNet. So one leg of API management is publicly exposed. One leg of it is placed inside the VNet, so it can communicate with everything in here. And this is my favorite setup, or at least this is a setup I like very much. For this to work, you need, as I mentioned, state to API management to be external, and have a start by adding an extra restriction to your app services, stating only the subnet API management. The subnet where API management instance is placed in is allowed to connect to your service plan. So that's all there is to it. There's one big downside of this setup though. It's the price, because in order to use API management with VNet integration, or with this with the connection to a specific VNet, you need the premium plan. And I'm not sure if you're aware of this, but the premium plan costs about $2,400 per month, which is a lot of money. I can't decide for you if it's expensive. But it's still a lot of money for a proxy. If you're not using it for anything else and just as a proxy for requests, it's a lot. So I love using it, but I'm aware of the price tag. So you have to decide for yourself if this is an option. You can also go for the cheaper route by using API management standard, and start by using service tags, the service tag API management. And this means only API management services are allowed to connect to your service plans, to your web applications. The downside of this, though, is your web applications and your functions are still exposed to the public internet. They just have an extra restriction: only API management instances can connect to this. And just like the toggle on SQL Server, this means every API management instance within Azure is now allowed to connect to your web applications. Same problem for the SQL Server. So if you're gonna use this with the API management basic or standard plan, do make sure you have some kind of middleware or some kind of logic within your applications to check if the request coming from API management is your instance. So maybe via some request header and checking if the GUID is correct or something like this. make sure you're verifying the incoming requests. So that's the service tag option, which saves you a lot of money per month. It's just you have to do some additional logic for yourself. So now we have this, or at least I have this in my demo subscription, and let me just show you how this works and is set up. So back to the dashboard. So I have this API management starter instance, an application network where a function is also placed in. I'm going to show you. So this starter app away from web is now in. It has the VNet integration, so it should be able to connect to the SQL services, the storage account, etc. Not that this function does anything with it. It's just I'll show you. This is the same function, starter away from web. It's just doing the same next finish project function app, and it returns a message. It responds to a message from hello within our VNet. So this one is deployed to Azure. And I've added the access restriction, which I've shown you in the slides. Only VNet API management is allowed, the subnet API management is allowed to this specific instance. So back to the dashboard. So this is the default virtual network. Nothing fancy over here. Subnet for API management, a subnet for my function, and the default subnet. So in an actual environment, you might want to use different IP ranges. I just chose one which is the default. And here's the API management starter instance I'm using. So I have this function imported using the Swagger or using the add new function, and it'll add it. So as you can see, the function, it has a post and a get, which is the default within a new function app. And over here, right at the bottom, I have this virtual network set up to external and placed this API management instance inside the API management subnet. So now let's show Postman. So, and this is the private function. This is the endpoint to the function with with the access restriction. So it's a starter app away from web. .azure websites. So you're probably familiar with this domain. And as you can see, I'm getting a web app unavailable because it has the access restrictions set up to only allow traffic from within our VNet from the API management subnet. So now invoking it via API management. So this is the API management starter .azure.api.net, and then my API send. And as you can see, hello from within our VNet, the same as I've shown you in Visual Studio. So this works, or at least this works, and this is quite nice. And now we have the setup, which I've shown you in the slides. So this is a really nice starting point, at least to me. And you can do this VNet integration with the premium, or when you're using a subscription where only developers are at, you can use the developer tier, which is like $40. So that's not breaking the bank. So you can even do this in your own personal subscription if you want. And that's a really nice starting point. So back to the slides. I see a comment. Maybe using WAF also makes sense. Exactly. So that's a great comment in the chat. So the web application firewall like an application gateway has it integrated, is a very, very nice option to put in front of your API management instance. So now you have API management, which makes sure your whole backend is only exposed via one domain, and you can do some routing rules, add some policies, add a lot of stuff in API management to make sure your APIs are very secure-ish, or at least not exposed, and exposed in a way you want them via API management. But API management doesn't do a lot of protection. Sure, you can set up subscriptions which can do some throttling, but it doesn't do actual protection like an app gateway is doing, because an app gateway is doing actual DDoS protection, and it has the ability to add some rules to your environment. So if your service is only meant for a Dutch or Indian or US or Australian customers, you can even do a geolocation check if requests coming in from not the country, not the area you're expecting it from, they're not allowed to connect. And that's not very foolproof, obviously, because IPs, the geolocation of IP addresses isn't very specific, but it's a nice starting point. But also the DDoS protection is very nice, and a lot of other nice firewall rules you can add to an app gateway. This is meant specifically for web, so HTTP and HTTPS requests. If you have some firewall or if you have some FTP server or something else which isn't HTTP or HTTPS traffic, you need to use an Azure firewall for this, not an app gateway, because this is only for web requests. But making sure, this is now the single point traffic is coming from, and you can be sure about it, or you should be sure about it. All traffic going through this line is safe, is throttled, is being inspected. So the app gateway is doing some OWASP top 10 checks, like SQL injection. Well, I mentioned the DDoS protection, stuff like this. It inspects the actual traffic coming in, and if it sees it's malicious, it will stop the request and send back a response to the invoking party. So this is very nice, and this is the app gateway, where you can add specific rules to. You might be asking, why aren't you using Front Door? Because Front Door has awesome capabilities, and it's newer, and it has a lot of similar capabilities compared to the app gateway, and some more, like I don't know if you know it, but Azure Front Door has the new preview plans, the standard and premium plans. And the standard plan has a lot of performance capabilities. It's not that expensive also. And the premium plan, which costs a bit more money, but I don't think it's very expensive, also has a lot of security features inside, like the integrated WAF, the DDoS protection, bot protection even. And I didn't know what dynamic app acceleration is or was, but apparently you can make sure your dynamic content is being loaded faster to the endpoints, to the edge, which is a nice term nowadays. So that's nice. Front Door is also deployed globally, which is great if you're have a service which has customers based in at least more as one geographic area. But it has one major downside compared to an app gateway. It can't connect to a VNet. I think this is because of the global nature of Front Door, because it doesn't make a lot of sense, or at least in my head, to have a global service still needing to connect to a single VNet, a single environment in a specific area. So a VNet is deployed in an area. Mine is in Western Europe. So if a customer from Australia is hitting my front door in Australia, it would still have to make contact to Western Europe. So that doesn't make a lot of sense. So I think that's why it can't connect to the VNet, but I'm not sure on the internals. A way to circumvent this is by still using front door for its awesome capabilities and having it connect to your app gateway, like we had in the diagram, the earlier diagram. So instead of the websites and the users connecting to your app gateway directly, now having them connect to front door. And this isn't a bad setup, of course, but you're still dependent on one geolocation. So the Australian customers still have to connect to the Western Europe environment. So that's not, well, that's not very performant. But if you're in one area, this setup might make sense, because now you have the CDN in place. Now you have some additional security features in place compared to the app gateway. Yeah, it's nice. You just have some double features, like for the security part in front door and in app gateway. It doesn't hurt to have them both in place, but it does add a bit to the bill. So a cheaper option would be to have front door connect to API management and have such kind of a setup. It saves you about $300 per month, depending on the traffic you have, because an app gateway is about $300, and per compute unit, that is. So if you have a lot of customers hitting your app gateway, you might end up with multiple compute units. But that's solved by using this kind of a setup. Front door premium is also about $300 per month. Still in preview though, so it's, yeah, you have to be aware of this. But this is also a nice solution. But as I mentioned, you can't use VNet integration with front door. So to solve this, you still have API management set up as external. So one part public, one part private, and set up an NSG to secure your API management instance, and making sure in the NSG only front door is allowed to it. How to do this? Well, as I mentioned, you have these service tags, the same as with applications, web applications. WAF API gateway. Yeah, indeed. So service tag, making sure only front door can connect to this API management instance, or at least this NSG will be placed on the API management subnet. And 443, we're only allowing HTTPS, and a nice comment. But as I mentioned, service tags are global, or at least I've said only front door can connect to this now, but it's all front doors in all of Azure. So you still have to do some additional checking, like I mentioned, in the middleware of your own application. And in API management, this can be done via some header. There's front door adds a header to your request, the X Azure FDID. And if you check this, you can check the value. And this is the GUID of your front door instance, or should be the GUID of your front door instance. And if it doesn't match, you'll get a 403 with a nice error message. And that's, well, the protection you need to add to your API management instance. Otherwise, everyone will still be able to connect to it, and that might be a problem. And while you're in API management, I would suggest also adding the subscriptions to your APIs, even if you're not planning on using it right now. Subscriptions allow you to do a lot of stuff. One of them is throttling of requests. So once you're ready to monetize your APIs, you can have like gold partners, silver partners, bronze partners, or customers, whatever. And this, depending on the plan they have, you can say, you have the biggest plan, you can do 1,000 requests per second. And once you go 1,001 per second, you will be throttled. So that's stuff you can do with subscriptions. It's a good way to monetize your API. And even if you're not using it right now, I suggest adding it and having a specific rule within App Gateway or Front Door or your firewall or whatever to add a default rule with unlimited access to your APIs. So that's what I'm doing right now. So having the subscription, and customers can still do anonymous requests to my Front Door or App Gateway. And when the key is not available, I'm adding a default value over here. And that's, a nice starting point, or at least in my opinion, because now I know all requests coming to API management needs a specific subscription key. So that's an additional layer of protection aside from the policy of checking the Front Door ID. That's it. So something I'm adding in a couple of projects right now. So I'll show you in my own Azure instance. So we're in the enterprise app now, which is the same. It's just a different response message. Hello from the enterprise. So back to the dashboard. I've got a complete new resource group for this, which is the most expensive resource group I have at the moment because it has the API management premium in it, Front Door, and that's the most expensive part. The function is a consumption plan, so it doesn't cost anything. So the function app, it's still the same as before. It has the access restriction and the VNet integration. So the access restriction is to the API management subnet. Then we have the API management enterprise instance, which is also set up the same compared to the other one. The only difference is now I have a policy set up to check the header of if my Front Door ID is correct. So just like in the slides, I'm checking the header if it has the Front Door header and if it has the correct GUID. And obviously it still has the VNet integration. Otherwise, I wouldn't be able to connect to the function. So and now for the NSG, it's the same, port 443, connecting to a VNet. Front Door, HTTPS. What do you want to open? Well, only HTTPS traffic, and allow this type of traffic. When I was setting up this new NSG, I discovered you need to add a couple of additional ports for Azure to still see your API management is healthy. So you need the basic Azure infrastructure services, which are these IP numbers, which is the same for everyone. These IPs make sure Azure is still able to do some internal health monitoring, making sure you're to deploy your instance to healthy underlying clusters, stuff like this. So that's kind of important. When I didn't have this one added, API management started acting quite strangely. And you need the management port. the 3443 to be exposed also. Otherwise, you can't manage API management within the Azure portal anymore. This is the port API management or the Azure portal is using internally to connect to your instance. So at first I didn't have this one added to my NSG, but then I couldn't manage my API management instance anymore. So be sure to add it. And in an actual solution, in an actual environment, I'd recommend doing this in multiple NSGs because now the NSG is called allow from door and it's doing quite a bit more at the moment, like allowing Azure, allowing the management board. But that's something you need to know when starting with it. These ports and IP addresses are mentioned in the API management documentation. There's a specific page on this, like locking down your API management instance or VNet protecting. Or it's something. Once you scroll down in the docs, you notice it directly. And there's a whole long list of IP addresses you can add or you should add and ports you should be adding to the NSGs or to allow access to API management. So that's one thing you need to know. It will save you a bit of time later on. So that's the NSG, and I've added it to the API management subnet over here. And now for front door, which isn't doing anything special at the moment, aside from having a specific rule to add the subscription key I mentioned. So this is the rule. Add API management subscription key. So as you can see, if the subscription key isn't present, add it and be done with it. So that's a nice, or at least I think it's a nice solution. So I can start monetizing the API later on when I or the company is ready for this. So just to make sure that doing some invocations. So it's the same as the starter, just so the public function isn't exposed. I won't be invoking this one, but now via API management, I have the subscription key set up. So I'm entering the subscription key over here and trying to invoke the API management endpoint, and will get I think it's a timeout. Because even though I'm specifying the subscription key over here, we have this policy set up, only this NSG setup, only traffic from front door backends should be allowed access to it. So this one doesn't work. Is it done already or still busy? Doesn't matter. It shouldn't be working. So sending shouldn't be working. So I guess it won't work. Oh, maybe I have to. Yeah. As you can see, the previous request timed out. So I guess that one works. In the meantime, I'll also do a request via front door. You can see my earlier dry run. So I'm specifying the API management, the CNAME, the subdomain for me, which is only routing my traffic to API management, sending it, and I'm getting the hello from the enterprise. From my function, which is behind API management. I'm not specifying the subscription key over here. I can, but because of the rule we have set up, it's not necessary. So I can do something. I haven't tried this, so this is an actual experiment. So 1, 2, 3, access is denied because the subscription key isn't valid. So the rule is now seeing, hey, there's a subscription key. I don't need to override this. So it sends the 1 to 3 value back to API management. And as you can see, the subscription key isn't valid because 1 to 3 isn't a valid subscription key. Let me undo this quickly. And now it does work again. So cool, or at least I think this is quite cool, and something I highly recommend doing. It's just the pricing, as I mentioned, is a bit steep if you want to do it perfectly. So adding the VNet is like $0, because it's just a VNet around your data services, and this is something you should be doing right away if you're not doing it already, because it doesn't cost a lot. It isn't a lot of development or ops effort, and it only has benefits, or at least that I'm aware of. And you can even do some NSGs, adding some NSGs to the network security groups to your subnets if you want to. So that's the most basic protection you want for your data. Then adding, as I mentioned, API management with the service tags extra restriction, which is nice, and you can even with the basic plan, which is you can even start out with the basic plan, which is 125 euros per month, or the standard, which is about 600 euros per month, and that's a nice starting point. It's just the basic plan only allows a couple of requests per second, which I don't think a lot of production scenarios can handle this limitation. Standard is a bit better, but yeah, as I mentioned, the VNet integration is awesome. It's just going from 600 to 2400, or maybe even from 0 to 2400 euros per month. It is quite a leap. So I understand why customers aren't using this. And even with API management in place, you still need some additional security features, like the application gateway is offering, or the application gateway and front door is offering, or maybe just front door with the NSGs and API management policies, like I shown you in the last slide, which ends up at about 3,000 euros per month without requests, bandwidth, all based on single units, etc. So if you're only hosting one app service or a couple of functions, or maybe even two app services, your Azure bill is probably around 200, 300, 400 euros per month, depending on what you have. Adding 3,000 euros to the mix, or whatever currency you're using, is a bit out of proportions. So that I understand that's a lot of money, and your customer doesn't want to set this up. So how to proceed? Well, the most basic, as I mentioned, the most basic thing you should be doing is adding the VNet, which is about $0. Sure, you still need compatible services for this, like the app service. You need the standard plan. For functions, I think it's only in the Elastic Premium, the premium offering. It might be in the standard offering. I'm not sure, but I know it's not in the consumption plan. So that's you need compatible services, so that'll cost you a bit of money. But I think all production environments should already be on the standard plan of app services. So that's not really a point. So what you can do, so adding the VNet and then adding the access restriction to your app services, or to your service plans, app services, and also on your functions with the service tag, but instead of API management, like I did in the earlier slides, make sure you check for the front door backend and specify the front door ID over here. So this is the same as the policy I've shown you in API management. It's just now you have front door setup, front door premium, the preview version, and it makes requests to your app services and also to your functions if you want. And only traffic allowed from your specific instance is now allowed to connect to them. And sure, this will set you back like 300 euros per month, or dollars, depending, or whatever currency you're using. But it's the most basic protection you can set up, and I think you should be setting up. if you are serious about your business in terms of the Azure footprint. As I mentioned, if you're doing a side project or you're making a project or an application for a small customer which finds a bill of 100 euros per month for Azure already a lot, this isn't an option, and just start with a VNet integration. And when this customer is moving to different tiers of the Azure bill, this will start to make sense, because Frondor offers a lot of protection, a lot of benefits. It's just you have to check if it matches the expectations of your customer, or the expectations of the enterprise grade level of your environment and the overall solution. So that's it. That's it for me. If you want to reach out to me later on, be sure to check out my Twitter, or read some more about this stuff on my blog. I want to thank you all for watching. I see a couple of comments. Super expensive. Yeah, indeed. All money saved with PaaS has to be paid for security. Yeah, sure. Well, as I mentioned, the PaaS services do offer a bit of protection, the standard DDoS protection, and the PaaS is expensive, but managing your own virtual machine in Azure or on your hosting party also is expensive in terms of managing and operating this, and then you still need some kind of web protection, because when I was doing on-premises stuff, we still needed Barracuda firewalls or Cisco firewalls and setting this up. And last time I saw an offer from the Barracuda, which was tens of thousands of euros just to have the firewall in place. The security stuff is expensive on premises, in IaaS or in PaaS. Expensive, maybe that's not the right word. It's a lot of money, and depending on the company you're at or the project you're doing, it's expensive or not. But it's a lot of money. I agree. So also thanks for the learning partners and the communities sponsoring and working together with this amazing conference. I'm also in Discord all day. I'm at work all day, so I can respond to questions if you have them. If it's long, it'll take me a bit longer to respond. But you can also send me an email if you want. That's it for me.
Thanks for the wonderful session, Jen. You've already answered a lot of questions through the session. If there are a few, we'll just take one or two. I know you've answered most, but we'll try to answer one. There is one question. Between tags and VNet, are these the only way to restrict the access? If you can explain.
I can show you the what other things are possible. So you do need the networking access restriction, and there are some add rule. There are some other options like IP addresses, IP address whitelisting, which isn't much of a protection in my opinion. Only VNet and service tags are actual things I'd be using in a production environment, but it depends on the project, obviously. So this is these are the easiest ways to secure your environment. This is the easiest way. You can also do your own middleware protection. At a couple of projects I've worked at, we only allowed access via the default OAuth protocols, and having managed identities, all services using managed identities, and whenever a function tried to invoke another function or another API, we were checking the JOT in the header to see if your application, if your managed identity has access to your specific API, and that's just protecting or authorizing your identity, just like your users, to a specific service. And it's a protection mechanism, but it doesn't protect you on a lower level. It protects you on an application level, and there are multiple ways you can protect your application on an application level, on a software level. This is just on a level deeper, on the networking level, on a traffic level. So adding software security makes sense. I'm using gel tokens and managed identities for this and application roles. There's a blog post on my site on this, and I'm using it at all customers at the moment. And this is the extra restriction is meant indeed for the other level. And having multiple levels of protection makes a lot of sense in my opinion. Hope that answers your question. How do we?
Thanks, Jen. That was an excellent answer. Thank you. We have one more question. How do we perform the cloud security posture check in Azure?
The cloud security posture check. I don't know what's meant by this. I don't know if you mean something like a security center, because security center, I don't think I have this set up in my in this subscription, but security center is able to do security checks in your application. It does the basic stuff like your app should only be allowing HTTPS traffic. Traffic should be sent encrypted and encrypted at rest. Stuff like this. Don't use SQL logins. Use AAD logins. Stuff like this. The Security Center does something with this. I've also added my own security policies using Azure policies, which notify me whenever something is happening or which I don't want to do. But this is more of on a governance level of my Azure environment. So Security Center is a nice starting point. You also have Sentinel. I don't know if you've heard of this. I haven't set this up. So Azure Sentinel, well, as it mentioned, it's a stop threats before they cause harm, which is super cool feature, super cool service. Also costs quite a bit of money if I remember correctly. So this is definitely worth checking out if you're serious on security, if you're serious on protecting your Azure environment. I haven't set this up yet because, well, I want to dig deeper into this stuff, but I haven't done so yet. So I hope this answers Striker's his question. Otherwise, maybe we should take this offline.
Thanks for the answer, Jen. Thanks everyone for listening. That was an amazing session. And thanks for your time, Jen.
Okay, thank you, and have a great day, you all.
Hi, Hugo. Can you hear me?
Hi, how are you doing? Can you hear me fine?
Hello? Yeah. Can you hear me fine?
Yes, all good.
Okay. Thank you. Thanks everyone for joining. The next session is going to be by Hugo. It is on building microservices and event-driven apps using Dapper. On the stage is all yours. Thanks, Hugo.
Thank you. So namaste, everyone. Happy day. I know that it's roughly lunchtime in India. Here it's around 7:30 a.m. But let's do it. So as Shireen just basically mentioned, today I'm going to talk to you about building microservice and event-driven apps using Dapr. So before we start, I just want to quickly, of course, do an introduction of myself. So I'm an independent contractor based in Ireland. Most of my experience is, of course, related to development using Microsoft Stack technologies, while leveraging, of course, the open source technologies as well. I'm also a certified Azure Solutions Architect, developer, and administrator, and Microsoft Certified Trainer and Azure MVP. So quickly starting, so nowadays more and more developers are asked to create microservice-based architectures and applications so they can break and move out from those big monolithic architectures into distributed microservice-based architectures composed of small pieces, all connected and performing specific tasks and responsibilities, thus enabling them to implement flexible, efficient, and of course resilient and scalable applications. And most important, enabling them to focus on building those applications and abstracting them from the infrastructure hosting those applications. And as you may know, as developers, we always like to have some freedom to pick the language or framework that fits our needs. Some of us may prefer to keep using the same language. The others may prefer to use different language depending on the context and type of application that we are implementing. But sometimes, of course, depending on the requirements we have for our applications, there are some challenge we may face while considering microservice development, including limited tools and runtimes to build our applications, also limited language support or runtimes that target specific infrastructure platforms with limited portability. So the distributed application runtime, known as Dapr, is an event-driven portable runtime that enables you to easily build resilient and scalable distributed applications as microservice on clouds or edge, and overcome a common challenge while implementing distributed applications, such as recovering state after failures, or even managing secrets and discovering and calling securely other microservice. So using Dapr, you can easily build microservice applications using any language, any framework, and run them anywhere you want. One important detail is that Dapr is an open source project, so it is open for the contributions of all of us. So in case you want to follow the latest updates and contribute to this project, follow the link to the official GitHub repository in the slide so you can have a look. And also you have the link for the Dapr website, the official website, where you can access relevant information as well, and you can get some access to guides and learn how to get started using Dapr. So there are many goals and advantage that Dapr is focused on. I will share some of them with you, and we start by talking about the best practice followed to provide the building blocks to enable us to easily build and run our applications using Dapr. Also, it is designed to support any language or framework of your choice. And this is a big advantage. So you can use your own language that you feel familiar with instead of being forced to move to a different language, learn the syntax, learn again the new language, and so on. It also, of course, provides us a consistent, portable set of open APIs that enable our applications to interact with the Dapr runtime. Also, Dapr is adopting standards to ensure consistency across all features and functionality that it provides to us. And we can leverage the extensive set of extensible and pluggable components to easily build additional functionality in our applications. And of course, another important feature I want to share with you is the fact that it is platform agnostic. So that means you can run Dapr and your applications in the cloud or edge. So that's a big advantage in those scenarios that you have requirements about building portable applications. So now talking about Dapr building blocks. So a building block is pretty much an API accessible using HTTP protocol or gRPC framework that is composed by one or more Dapr components. And the main goal is to provide capabilities to your applications. At the moment, Dapr provides you several building blocks, including a block to enable you to perform secure service-to-service communications, also building blocks for state management to enable you to implement stateless or stateful applications, blocks to implement pub/sub or publish and subscribe applications. Also, you have blocks to support you in those scenarios that you are building applications using the actors pattern. Also blocks for provide observability for your microservice and more. So you have plenty of, pretty much the message is you have plenty of work done by the community about bringing these building blocks to easily enable you to speed up the development of your application. And of course, in case you realize that you have a specific need that none of the blocks available help meet your needs, then you can build your own building block and use it. And of course, you can also, if you want, commit it to the official Dapr GitHub repository, so the other community members can use your code as well. So that's the beauty of this open project. So it's open for everyone to contribute. That means all of us can go there, contribute with code to improve the runtime and the tool, and then share with others. So as I mentioned previously, a building block is a set of one or more components providing a specific capability to your applications. So a component is a modular piece of functionality providing an interface definition, and due to its pluggable nature, you can easily replace components in the building blocks and in your applications. You will see during the demo how easy it is for you to create a component with same interface and replace it with an existing component being used by your application, and most importantly, without any code changes required. So Dapr provides you an extensive set of components out of the box, including the state store components that represent data stores, including database, files, and memory to store your application's data. Also, you have components for service discovery to enable the service-to-service discovery and simplify communications between the microservice. And in case you need to build custom logic into the request processing pipeline, you can leverage the middleware components available, so you can perform actions such as authentication, encryption, or message transformation before the request is routed to your application, or even before the response is returned to the user. Also, you have several components available to help you build your applications using the pub/sub pattern, as I mentioned before. So these components will manage the delivery and reception of all message created by your service and your applications. And the big advantage of using Dapr, if you are familiar with Azure Functions, is the fact that it provides bindings to external resources, including Azure Storage, Cosmos DB, Event Grid, and Event Hub Service Bus, SignalR, and much more. So that means all these bindings enables you to improve productivity and accelerate your developments by enabling you to easily connect your application with this external resource without requiring you to invest time on developing those implementations and those integrations. So if you are familiar with Azure Functions, you know that Azure Functions on the other side provides the bindings as well for you to easily integrate with several Azure services. And of course, to ensure that you are building and using secure applications and any private information, including connection strings and keys, you need to store them in the secret stores instead of storing them in your application's configuration or storing them in your code. So you can leverage, in this case, the components to manage secret stores and manage your private information as secrets in those stores. So Dapr uses a set of services to support the runtime and the provided features. We start with the Dapr sidecar service. Dapr uses a sidecar pattern, meaning that the Dapr APIs are run and exposed on a separate process, in this case, the sidecar process. And this process run alongside your application, providing additional functionality to your application. Sidecars are supporting process or service that are deployed with your application, providing an easy way to leverage the Dapr's features and components to improve your application's functionality. And in those scenarios that you are running Dapr in Kubernetes modes, you have a pod running the Dapr operator service. And this service will manage updates to Dapr components and also provides Kubernetes service endpoints for Dapr. So one important detail here to mention is at the moment you have two ways to run Dapr. You can run in self mode and you can run in using Kubernetes modes. And of course, in scenarios that you are using actor pattern with your applications, then Dapr uses the placement service to calculate and distribute distributed hash tables for the location of Dapr actors. So this hash table pretty much maps the actor ID to pods or process, and so your application can communicate with the actors in an easy way. Anytime your application activates an actor, the placement updates the hash tables with the latest actor locations. So everything of this is managed seamlessly and transparently by the Dapr runtime. So you don't need to care about anything of this. And of course, your applications running on Dapr need to be secure. So the Dapr Sentry service manage mutual TLS, also known as MTLS, between the service and acts as a certificate authority. So it generates MTLS certificates and distributes them to any running sidecars. So this allows sidecars to communicate with encrypted MTLS traffic. In case you are not familiar with the mutual TLS, the mutual TLS pretty much applies a two-way authentication when establishing the communication between a client and a server. So that means the client authenticates to the server and the server authenticates to the client as well. And of course, when you're running Dapr in Kubernetes modes, then a pod is created running the Dapr sidecar injector service, which looks for pods initialized with the Dapr annotations, and then creates another container in that pod for the sidecar service. So now I will provide you a few examples on how to use the building blocks that Dapr provides to us. We have this example of a service invocation where I have my app running and preparing to call, in this case, the service A. So it starts by executing a post request to service A, and in this case, it's calling the methods new order. sending a JSON payload in the body containing a hello world message. This post request is using the service invocation API available in Dapr. Then by doing this, our app puts the burden of service discovery on the Dapr runtime. So API will use the multicast DNS components for service discovery, so it can get the address of the service A before forward the request. Then, of course, a mutual TLS authentication is performed to ensure a secure connection between the APIs of the Dapr instance, running, of course, as sidecars and associated to the, in this case, to our app and to our service. After the successful established authentication, the request is forwarded to the service A's API. Okay. Then the API, of course, forwards the request to the service so it can process the new order. So once the request is processed, the response is returned all the way back until reach our app. So besides going into detail of each step in this diagram, just to explain you how these things work, most of these tasks are abstracted from the applications and the developers. So Dapr manages the service discovery and establishing the secured communications for you. Now we have an example of a state management call. And in this case, our app wants to persist some data into the data store. In this case, it's using, Redis cache. So it makes a request to the state API by providing the name of the DB. In this case, it's the core DB, and providing a body with all key value pairs that we want to persist into the data store. And then, of course, the Dapr instance gets the request and performs the operation to store the key value pair into Redis cache instance being used. And now we have an example like the demo I will show you today using the publish and subscribe building block. So all the publishing and subscribing in this example is using Redis cache. And again, our app makes a post request to the publish endpoints, providing the name of the pub sub components. In this scenario, it is orders, and the name of the topic, in this case, processed. And of course, it contains a hello world message in the body. The request is processed by the Dapr API, which then executes the operation to send the message of to the topic configured in Redis cache. And then Redis cache notifies the Dapr's API subscribing to that given topic. Those APIs then call the service A and service B, providing the details of the message. So during demo, I will show you more details on how this scenario can be configured and done. And actually, we reach the moment of the demo because I have some stuff that I definitely want to show you. In the meantime, I just want to be sure. I noticed that my camera is not working. I'm sorry about that. I hope it's back again. Okay, it's all back. Sorry. In the meantime, just asking your help, Shireen, any question? Do we have any questions so far?
As of now, we don't have any questions, Hugo. You can continue.
Okay, great. All right. So I'm just going to share here the browser with you. Okay. So as I mentioned in the slides, you can access Dapr by going to dapr.io. This is the official website, and of course here you have all the documentation you need in order to use in order to get started with Dapr. I will show you some details. The first thing I want to show you is, of course, you have the documentation explaining you how you can get started. And in here, you have all the steps explaining how you can install Dapr on your local machine and start to use Dapr. In my scenario, I just installed Docker desktop, and then I just followed the steps here to install the Dapr CLI, initialize Dapr, use Dapr API to just double check that your installation is all correct, configure a component, and then explore, of course, the quick starts. Okay, our demo will be based in one of the quick starts, so I will show you how easy it is for you to get started using Dapr. But I would definitely recommend you to have a look to the GitHub repo, and so you can get familiar with this. You can access the source code of Dapr, and also you can explore the quick starts available. So let me just open here the GitHub. So once you open the GitHub account, then you have several repos here, of course, and you have the Dapr repo for the source code. You have documentation repo, and you have also the quick starts. I just want to show you here on the quick starts. So as you can see, if you scroll down, you have a set of a list of quick starts available that you can use to pretty much get started with Dapr. Let me just be sure. Okay, the camera is still on. So so in this case, for this demo, we are going to use the PubSub quick start. And what I want to show you before we dive into the code and to the demo is I want to show you one thing, is the diagram. Okay, so one important detail, what we have here, pretty much in these quick starts, what we have here is we have three applications running. We have a Node application that it's one subscriber. We have a Python application, another subscriber, and then we have a React form application, a React application that is the publisher. Okay, and what the React does is pretty much it loads a web page and then allows you to push message to the Redis cache instance being used. And then, of course, you have these two clients subscribing to the topics, to different topics, and receiving the message that you are sending. Okay, it's a really simple example, but it gives you a good it's a good example to understand the foundations of Dapr and how you can get started using Dapr and the components and building blocks available that you have. All right, so what we are going to do is again, just to mention once again, is if you want to get started, you just need to follow here the documentation. It's pretty simple documentation. You just need to follow the steps, and you have all the documentation available for you to get started and install the tools. So I'm going to show you first the code. Okay. So what I did was I pretty much just clone the GitHub repo, of course, to my local machine. And in this case, I have here opened the PubSub quick start. So on the PubSub quick start, as I mentioned, we have three applications running. This is to show you as well the flexibility in terms of technology that you can use in here. So you can see that we have a Node application, we have a Python application, and we have a React application as well. So on the Nodes application, I'm going to show you here, we have just one app.js script, and pretty much what it does is it has an endpoints, get endpoints for Dapr subscribe to specify the topics that this client application wants to subscribe. So then Dapr runtime is able to, and the Dapr components is able to set up those subscriptions. Then it has two endpoints posts using post methods, in this case for topic A and topic B. So that means once the message is sent to the topic A or topic B, then the Dapr runtime will actually, in this case, Redis cache that we are using, Redis cache, is actually going to call your client application subscribing to that given topic to just receive the message. So then the app pretty much is going to receive the message and prints in the log in the console. Okay, and this is the nodes. And again, as you can imagine, the Python is pretty similar. in terms of the structure. Again, it has an endpoint for the subscribe, providing a JSON body with an array and with the JSON objects containing the subscriptions that this app is going to subscribe. In this case, this app is subscribing to topic A and topic C. So in this demo, we have 3 topics. We have A, B, and C. And what we are saying here is the node is subscribing to topics A and B, and the Python is subscribing to topics A and C. And now, then of course, it has two endpoints with using post methods and with for the topic A and for the topic C. So then it is able to receive when a message is sent to the topic A, the Redis cache will call this endpoint, and then this app is able to process the message received. And then, of course, the last app is the React form. So on the React form, we have a client, a simple client with a web interface where it contains the different fields that I'm going to show you in a minute when I run this, but pretty much contains this message form that allows you to select a topic and enter the message, and it contains enough component there. And then the most important is it contains a server using running Express, and pretty much contains here an API, an endpoint for publish using post. So that means the web app, as you are going to see during the demo, when you hit the button to send the message, it is going to call this endpoint to perform the publish. Okay, and the publish, what is doing here is it's calling the app runtime, it's calling the publish API, providing the pub sub name. So this is the name of your pub sub component, and then providing, of course, the message type that you are trying to send. And in the body, of course, it sends the text of the message that you just wrote. So what I'm going to start to do is I'm going to bring now another Visual Studio Code window just to show you. As part of the installation of Dapr, you need to run the Dapr init to initialize Dapr in your local machine or in the environment that you are trying to run Dapr. And during this initialization, it will create some executable files, and it will create as well some default components, okay? And in this case, after running the Dapr init, I have here two components created. So first, I have the component pub/sub. In this case, it's using the Redis for the pub/sub. And I have the state store. In this case, again, it's using the Redis as well. And then, of course, you can configure parameters to configure the components. Don't worry so much about the structure. I will show you in a minute during the demo how easy you can get started with these components and create your components. But for now, let's then try our application. So I'm going to just open here the terminal. So what I have here is I have 3 tabs in my terminal, one for Node, one for Python, and one for the React. So what I'm going to do is I'm going to just run my Node application. The way I run this is pretty much just run a command dapr run. This is part of the dapr CLI. And then you just specify the app ID. In this case, I'm just giving the ID node subscriber. You specify the port where you want to run your app, and then you specify the command to run your app. In this case, since it's a node app, I'm just running the command node app.js. So I run this to run my app. And I have my app listening on port 3000, as you can see here in the logs. So now I should be able to move to the Python subscriber. And again, so see, all these source codes is all available on GitHub. So if you clone the repo, you should be able to reproduce exactly what I'm doing here. Okay, no magic here happening. So again, same commands, dapr run, app ID, a different ID, in this case, of course, a different port, and then the command to run your app. In this case, it's a Python application, so you just run Python and then you provide the name of the script. So again, I'm going to run the Python. You should see confirmation listening to the ports. It's all good. And now I go and run my React application. Again, all the details and all the steps are provided there in the guideline associated with the quick start. Again, the same commands, dap run, app ID, a different port, and then the command to run your app. In this case, we are talking about a Reactor app. So that means npm, and then you just run and you specify the name of the script that you want to run. In this case, it's the start script. I just hit enter to just run my web app. It's up and running. So now what I'm going to do is, let's just, okay, should be fine. What I'm going to do is, I'm going to open the browser, and I open here the localhost on port 8080 because that's a port that we specified for our React app. I just refresh to be sure that this is running. And now, as you can see here, in terms of the message type, I have message A, message B, and message C, okay? And then you can specify as well, enter your own message to send the message to the subscribers, okay? So since both of them are subscribing to the topic A, I will start by sending a message to both of them. So I will just say hello road, and I just submit. Now, if I just minimize this, I can see on the React, I have here a confirmation of publishing the message. In this case, a message for topic A and the message hello road. On the node, of course, I received the message here and it printed the message hello road. And on the Python, again, you can see it received the message and it printed the message hello road, okay? So now let's say, okay, I want to now test the sending a message only for Node, my Node app. Okay, I will say hello Node, and I will again send the message. So once again, I go to the React. I have the confirmation of publishing the message, all good. I go to the nodes. I receive the message. I have here hello Node. But I go to Python and I did not receive the message. Okay, so that means that the subscriptions are actually working. You know, so it's actually tracking the subscribers and it's only sending the message for the real for the application subscribing for the given topic. So, and in the same way, of course, if I go back to my React app, if I go to the topic C, in this case, it's Python subscribing to topic C. So I just say hello Python. Once again, send the message, and I have here confirmation from React, publishing message for topic C, hello Python. I go to the nodes, no message, because node is not subscribing to the topic C. But if I go to Python, I can see here hello Python, okay? So this is just to show you a quick way of how you can get started using dapr and use these different components and building blocks that you have available. As you can see, my code did not have any specific, well, not my code, sorry, the code in the GitHub repo in the quick start does not have any specific code to integrate with Redis, okay? So this is all managed by dapr, okay? And now what I want to do, of course, is, let me just double check here to ensure that I'm not missing any steps. All right, so let me just go back to the quick start. 1 second, just to show you here. Okay. Okay, so going back to our diagram, right? So as we see here, Redis cache is managing the publishing and the subscribing, okay, of the message and the topics in this case. So now imagine that we want to say, imagine that you have your application running in production, but you realize, okay, I no longer want to use Redis, I want to use Service Bus. Okay, So if you are not familiar with Service Bus is pretty much an Azure service available that allows you to implement messaging architectures using the service. Okay, so you can actually send message, create queues and topics, and then send message to the queues and topics, and then have client applications consuming those message. So I'm just going to do one thing now. In this case, let me just go back here to the portal. So what we are going to do is, as I mentioned to you, we are going to replace Redis with Service Bus, right? So what I'm going to start, because this will take a few minutes, is I'm going to start to create my Service Bus on Azure portal, and then I will explain you the details. Okay, so let's start. I just hit the button to create the resource. I search for Service Bus, and I hit the option to create. Then you just fill in the normal settings. In this case, okay, I'm just going to give it a unique name. I'm going to select the region, and then you need to select the pricing tier. For the purpose of this demo, right, you need to, the most important thing is you need to select the standard pricing tier, because Service Bus on basic pricing tier does not provide topics, and we want to use topics in this case, not queues. So I just select standard. I just proceed to review. I'll skip the tags. It's not in context of this demo. And I'll leave it creating, okay? And in the meantime, of course, I'm going to show you one important thing. So if we go here to the, I think it's on the reference. Yes, you have the component specs option, okay? And then in here, you have all the specs for the different components you have available, okay? So on the PubSub brokers, you can see that if you go to the PubSub brokers, you have plenty of different brokers available here, okay? Different components to use different types of service, okay? Including Rabbit MQ, MQTT, Apache Kafka, and also, of course, Microsoft Azure service, including Event Hubs and Service Bus. If you go to the Service Bus, okay, then you have the specification of the component that you want to create. And that's exactly what we want to use to create our component, because if we want to use Service Bus, we definitely need to create a component, a new component. So what I'm going to do is I'm going to just copy this, and I'm going back to my Visual Studio. In this case, I'm going to just create a new file, and I'm going to just put the text I copied, and I'm going to save, of course, these components, and I'm going to call it service bus -pubsub the .yaml. This is using, of course, YAML files, okay? So as you can see here, the only thing we need to configure in this case is the connection string to access our service bus, okay? Topic in this case. So what I'm going to do is I'm going to just remove this. I'm just going to remove this comment just for simplicity, and I will go back to the portal. One sec. And hopefully, so our resource, our service bus namespace is created. So if I go to the namespace, the first thing I need to do is, of course, create my topics, okay? So I know that the topics, we have the topic A, let's just wait a few seconds for this to create. We have the topic B, and we have the topic C as well. So I'm going to create those 3 topics, and then I will just configure the connection string in my components, okay? Okay, I will show you one detail in a minute, but for now, let's go back to copy the connection string. So we go to the shared access policies. There is a root policy that it's always created in the once you create your service bus namespace. I'm going to just copy here my primary connection string, And I'm going to just move to the topics back to the topics because I want to share something with you. Okay, I'm going to just zoom in a bit. Now I want to go back to my components. I'm going to set the connection string. I'm going to save, and now I have my component to use that allows me to use service bus for the pub sub. Okay, so now I just close this. I'm going to my applications. And now the important thing is, of course, in a normal scenario, you would be using configurations associated with your app, right? And including the configurations about the PubSub component that you are using and the topics that you are subscribing and so on. For this demo, these configurations are hard coded. So actually, I said, okay, we don't need to change code, and we don't really need to change code in terms of logic, but we need to change those settings. So I go to my Nodes app, and I need to be sure. Let me just copy here the name of the component because we need to definitely use the exact name for this to work. I'm going to just replace the pub sub name with the name of my new components using service bus. Okay, so I just replace here the name, and it's all good for the nodes. Now I need to go for my Python to my Python application, and again on the subscribe, I need to change the pub sub name again and specify the service bus, the new components. Just double checking, all good. I'll leave the same subscription in terms of topics for simplicity. And of course, on the React on the server, as you know, this has this publish endpoint publishing the message to the given component. In this case, I need to change here the name of the component as well. So I'm all good. I just changed. I just did the change I'm required to. So now I should be able to go to the terminal. What I'm going to do is I'm going to just cancel this. All these apps, I'm going to just clear, and I'm going to start to run again my applications. So I'm going to run the Node app. Okay, it's running. I'm going to run my Python app. It's running. And I'm going to run my React app. Just 1 second. Okay, all good. So now one thing that I want to show you is if I go back to my to the Azure portal, as you can see here, we don't have any subscription when we created our topics and we created our namespace. Now let me just refresh this, and as you can see now, okay, now there are subscriptions. So that means DAP is able to, based on the configuration that you have in your applications, is able to set up the subscriptions for you. Okay. Now you can see now another advantage of this, because it pretty much sets up everything, all the configurations and all the integrations and all the subscriptions for you. So you don't need to care about this. The only thing you need to care, of course, is configuring your application. So now I have my my React running and my applications running, right? So Node, the Python, and React. So now I go back to the React app. I'm going to just refresh, and I'm going to send a message for topic A. So that means Node and Python should receive the message. So I'm going to say hello world using service bus. Okay. Okay, and submit. Once again, go back to the terminal. As you can see, nodes immediately received hello world using service bus. Python immediately received as well. As you can see here, hello world using service bus, and of course React confirmed that it published the message. Okay, so now once again I can go quickly due to the time we have available. I can go back and send to the topic B. In this case, only nodes should receive hello node using service bus, send, and again, it published React. I go to nodes, I have here my message on nodes, but I don't have on Python, of course. And the same applies for Python. So I go to topic C, hello Python using service bus, submit, and again, I go to React. I have the message published. I go to the Python. I have Python here printing the message, so confirming that received the message. But I have here Node not printing anything because it did not receive the message. So that's pretty much it. Another thing that I can quickly show you is, as you can see, we run a lot of commands using the Dapr CLI, but if you want to, of course, visualize some of these components that you are running locally, you can always use the dashboard. So what you are going to do is you run the Dapr command dashboard, and then you specify the port that you want to open the dashboard. Okay, so and pretty much I just run this. It can take a few seconds. Let's just wait a little bit more. All right, it's running. Okay, so if I go back to my React app, if I open the browser on 999, then I have the Dapr dashboard. Okay, so in case you prefer, instead of commands, you prefer to visualize it, you are able to here to have a UI that enables you to interact with Dapr runtime as well. So quickly, as you can see, if I go back to the terminal, I have still my apps running, right? My 3 apps, but I can go here to the dashboard and say, okay, fair enough, time is off, time is over, so I'm going to stop these applications. So you just hit stop, and you just hit stop, and you just hit stop for the React. And now I just stopped all my applications. So as you can see, it's no longer running in the terminal, it just stopped. So that's just an additional to just share with you. So given that, let's go back to the slides and Q&A. I don't know if we have any questions so far. Shrib, you there?
Hi, Hugo. And there's one
Yeah.
question.
Uh-huh.
Let's wait for a few more also. There's one question. I'm just showing it up. Is there some latency because of the use of Dapr? Are there any disadvantages other than this?
Well, yeah, that's a challenging question to be honest. See, what I can tell you is before Dapr, before I started to use Dapr, I'm a big fan of Azure Functions, honestly, because I really like the concept of PaaS, or platform as a service, which gives us developers and architects, gives us abstraction from the environments and machines and operating systems running our applications. Okay, so it means you can speed up and accelerate the development and the deployment of your applications without spending time with things that most of the times that you don't care so much, including the operating system and so on. So given that, I would say, honestly, personally, okay, take it personally, that's not an official opinion, but it's my opinion. I would say that it all depends on the requirements. Okay, so as you know, if you are familiar with Azure Functions, you can build microservice event-driven applications using Azure Functions. I actually built a few projects using Azure Functions for a few clients, and of course, you can connect your Azure Functions with Event Grid topics. You can connect your Azure Functions with Service Bus topics and queues. Whatever you prefer, and depending on as well on the requirements. But besides the fact that Microsoft and Azure are working on the portability of Azure Functions, there are two important things on the Azure Functions. Is the portability sometimes can be a challenge depending on the context and the requirements you have. And the other thing is, as you know, the limitation in terms of technology stack. Okay, so you with functions you cannot use any language that you want. Okay, you need to stick to the supported language. Okay, so there are some I don't call it limitations, but there are some specifics on each service. So I would say, depending on your project, depending on your requirements, you need to assess what is the best. So ultimately the rule is for any service that you run in the cloud or anywhere, there is no service that is a solution for everything, you know. So depending on the scope, on the requirements, you need to pick the best service. But definitely, if you have just to give an example, if you have scenarios that you want high performance applications, you're leveraging auto scaling, leveraging the service discovery, leveraging the if you are using containerized apps, if you have requirements about portability, then you can consider using DAP, because then it means that you can actually use DAP for those scenarios, you know. But it, as I said, it all depends on the environment and the requirements, I would say. Do you have more questions?
Yeah, yes, Hugo. Thanks. That was a great answer. We have two more questions.
Okay.
The next one. This is how to push the application log to observability building block.
You don't need to worry about that. The building block and the components available will handle all of this for you. Okay. So because this is these components are using a concept of distributed traceability. So if you are familiar, as you can imagine, you are building an architecture of microservice, so you have small pieces floating everywhere, all flying everywhere. So that means in those scenarios, sometimes you need to be able to have a way to correlate the logs, and in order to ensure and troubleshoot the sequence of steps in your applications that a given request or a given operation is performing. So that means you don't need to worry about this, because DAP manages this for you.
Thanks, Hugo. We have the last one.
Yeah. Is there a
Is
way
there
to
a way to
integrate?
integrate monitoring tools? Example, data.
Yes. So as I told you, see this nature of pluggable and extensible on the components. That means you, if it's not available, I'm not familiar, to be honest. If I'm not sure if it's available for Datadog there, a component. But if it's not available, a component there for Datadog, you can always build a component and integrate with Datadog. As long as Datadog has an API, and I know they have APIs available, you can integrate with their APIs and just use Datadog as well. Yeah.
Thanks, Hugo.
Yeah,
That
I
was a
just
great
I just need. Do we have still more questions? No.
That's it, Hugo.
Okay, I just want to share just a few slides here. So first,
Okay.
if you want to keep reference of the links, you can maybe take a screenshot from here, from this screen, so you can get the relevant links for this session. Also, you have my my Twitter and my blog. In case you want to connect, feel free to connect. I'm happy to answer any questions offline in case you have, or if you face any issues getting started with DAP. To be honest, I see this DAP is an early project. It has 1 year and something, if I'm not wrong, or 2 years most. And in the beginning, when I started, maybe 1 year ago, when I started to use DAP, I faced some issues. So two things: it's always good to connect with the DAP team via GitHub or even Discord. They have channels available for you to get help. And also you can always reach out to me, and I can support you. And I just have one more thing to just share with you guys, if you allow me, please. Are we on time? I just need 2 minutes more.
Yes, yes. Yes,
I
you
think.
still have time.
Okay. All right. So quickly, just to share. All right. First of all, I want to say a big thank you to the Azure Community Conference team for organizing such great events, and thank you so much for the invitation. I want to also share this opportunity with you. So I'm part of a community group called Lunch and Learn, and pretty much the message is simple: is now you are learning fantastic technologies and with fantastic sessions. And if you want to take this to the next step, once the conference ends and once you learn about the different technologies, you have here the possibility, the opportunity to participate in our event that is coming in the next week. So it's called the Cloud Launch and Run Ideathon, and it's pretty much a challenge that is for anyone, even non-tech people and non-developers, to participate. So if you are familiar with hackathon, consider an hackathon, but in this case, you are not required to implement solutions. So that means even if you don't know how to code, you can participate. The good things is, good news is, the registrations are still open. We have still place for you, and we have a participation with Baran Polytechnic, and pretty much we have a big challenge related with air pollution and air quality. And of course, Microsoft is our sponsor, so Microsoft people will be there to help you, guide you, coach you, and support you. And also the winners have a chance to win amazing prize. So if you want to have a look, then on your own time after the conference, for now focus on the conference, then you can have a look to cloudlunchandrun.com/ideathon. Okay. And another important thing that I ask the moderator, if it's possible, is on this session, if you want to continue the journey of learning, I would say there is a live workshop on the 31st related to building apps using Dapr. So maybe Sharib, if you can share the link in the chat for the workshop, then on the 31st you can go attend the workshop and then put on practice the things that you learned in this session. Sounds good?
Sure, Hugo. Sure, Hugo. Can you pass the link on to me? I'll pass it on to the public chat.
The link is of the conference, of the Azure Community Conference. I can give you the link, but it's on your website.
Okay.
If you go to workshops, I will give you the link just in 1 second. Yeah, and if you can, please, yeah, can you see there the chat? So please, that live workshop, I think it's something really beneficial for you, because while still information is fresh in your mind, you can start to apply that information about using Dapr in that live workshop. Okay, I just passed there the link for you, Sharif.
Yeah, yes, I've posted it on the public chat.
Perfect. And if you can, please post as well the link of the Ideathon. So I just invite everyone,
Sure.
if you want to participate. And once again, thank you so much. It's a pleasure for me to be here, and I hope you enjoyed the session.
Thanks for the session, Hugo.
Have a great day. Namaste.
Thank you so much. Thank you. Hello.
Hello.
Hi, Saro. Can you hear me?
Yes.
Okay.
You're able to see my desktop?
Yes. Have you shared it? Yes. Okay. Okay. So thanks everyone for joining. The next session is going to be by Saro Chandrabhushan. It is on software-defined marketing. Thank you. It's all yours.
So,
Take it.
it is now 12:56, right? Can I wait for 2 minutes?
No, that's okay. You can start off.
Okay. So, good morning, everyone, and good afternoon. So, thank you for AzureCon for giving this opportunity to give a speaker session on this conference. And today, myself, Sarath Bhushan, founder and CEO of Series 5 Labs. It's currently incubated in India's in one of the IIM called IIM Bangalore. And I have been in the software development and architectural for more than 15 years, got 2 granted patents. And today I'll be sharing our experiences on building a software-defined marketing. It is a next generation cloud unified converged cloud for media and marketing. So built on top of Azure platform. So I'll be sharing what is all about software defined marketing and Then what are the different components of what are the use cases what we are trying to solve using software defined marketing, and what are the components of software defined marketing. Then finally, I'll be sharing what kind of technology stack we used on Azure platform for building quickly and deliver some of the features which some of our customers are using right now today. So let me begin with software my agenda. So today's agenda is going to be the software defined marketing and the marketing and communication challenges existing today, and software defined marketing, the architecture and the terminology what we have used in our platform, and some of the use cases, and the Azure component or the other platform, how it is helping us to build such a quickly a platform which is meant for next generation media and marketing in a highly scalable and available environment. So before jumping into software-defined marketing, I just want to give an overview of how we have reached the acronym called software-defined marketing. So earlier days, we used to have nowadays all the computing have software-defined something, whether it is software-defined compute, software-defined storage, software-defined networking. So everything is associated with the software-defined way of doing. So in the some a decade ago, the technology was if you are stick on one particular vendor. So we had many computing vendors like HP, IBM, Cisco, and so many people. We were relying on building our infrastructure using these brands or the products coming from these kind of brands. But if you are sticking on one particular brand, you have to purchase the hardware, the software, and we used to build application on top of their application, their platform. So when it came to the software defined way of doing, what we got the opportunity was we got the opportunity to build or take any commodity software. We can procure the commodity or the hardware from any vendors, and we can run these vendor under using same one unified platform. So that now the customer had an opportunity to innovate their business or innovate their IT environment. So when we look at the earlier days, we used to have a switches, server, and firewall, etc. Coming from the vendor, and we had a software and the platform coming from the vendor, and we used to stick on that platform. Now, if you see the same thing when it comes to a media domain, so especially a media marketing and domain. So instead of the computing hardware like switches and servers, here we have a hardware or the assets like we have a outdoor or the non-traditional media. We have a digital media. Then we have a broadcast domain like TV and FM, and we have a other mode of mass media like print media. So the challenge existing for the marketeers or the advertisers or brands today is if they want to launch a campaign in country level or a region specific way or in a local specific way, that they have to rely on different agencies to run their particular campaign on these particular media. For example, if I want to run a campaign on print media, I have to. There are some agencies or media agencies or media owners. They do the campaign particularly on the print media. And similarly, if I want to run a campaign on the billboard or a hoarding, the idea is they have to rely on something um, specific to the media agency. They run it on the traditional media like billboards or the bus stands or the kind of bus shelters kind of stuff. So what we are trying to achieve here is we built a platform called software defined marketing, which is going to be the platform meant for me managing all the medias and creating the media analytics and exposing or sharing the media across media agencies or brand. Then plan the campaign, run the campaign, and after that, analyze the campaign from a single dashboard so that the brand can see how their campaign or the communication is reaching out to the different target group or TG specific group, and how the how the reactions or the actions or the engagement happening, and ultimately we are going to measure the ROI of the campaign happening in the thing. So if you see the currently in the online world like social media platform or any other online advertising platform, most of the we get the analytics and the interaction and engagement almost 100%. But in case of other media like billboards or the traditional media or digital out of home, the engagement and the ROI getting is not very easy. So, but we have built some kind of techniques and the kind of additional hardware and software solution to measure the ROI from the thing. So this is what actually we are meant for software defined marketing thing. So this, if you take the definition of the thing, software defined STM is a cloud native platform that unifies management of all classes of media's infrastructure, plan the campaign, play the campaign, and measure the ROI of the campaign using IoT, AI, and ML techniques. So that is how the Azure or the Microsoft Azure is coming a big way to helping us in this area, because it comes along with all the kind of solution or pre-built template which we can directly use or indirectly use so that we can deliver the solution to our target customers. So it's a pretty much a big architecture. So this is a high level overview of the STM architecture. If you can see the asset owners and agencies and advertisers, and we have a supply side platform, and we have data aggregation platform, and then we have different agencies or government agencies or advertisers agencies, or so that they make the policies. And then we have the media planners and advertisers. They actually consume the media assets and consume the insights and input from the TG specific venues or the domains or the demography. And ultimately, there are consumers who are going to consume the campaign or the communication happening across this media, and ultimately giving the input to the brands or the communications. So there is going to be a single dashboard now available for managing the media and running the campaign and selection of the campaign and playing the campaign and running the thing. This is actually the high level architecture. And the value of proposition, what we are going to give to the customers are, we are going to do marketing spend optimization and decision support analytics. And we can find the consumer journey solution to enable cross-sell and build brand loyalty. So addressable advertising, programmatic advertising, and targeted advertising. So actually, if you see a one channel, for example, if you take a online media or if you take a print media, there are teams or the platform available to do the specific task on each of this channel. But if you take the entire whole mass media ecosystem, there is no single solution available today. So the kind of terminology what we are going to use in software defined marketings are, we have a term like media aggregates or workspace. We have a venue, and we have a media assets. We have IoT, and we have some kind of personas implemented like media owner persona, media agency persona, and publisher or advertiser persona. So actually, these are the kind of terminology or the key terms we'll be using in our thing. So ultimately, what you can onboard to a cloud. So if you see in the computing world, we have a hardware like physical storage, networking, and computing, memory, so many things. So in our media, the media cloud, that the thing is, what we are going to onboard is a media aggregates. So media aggregate is a place or a venue or a platform which you can be seeing a multitude of different kinds of media. For example, a mall, for example, a hospital, or example, a theme park, where you will be finding different kind of media like digital media, physical media, virtual media, and print media, so many kind of things. So in our platform, you can create a aggregate or a workspace where you can say that this is my mall or a hospital. In this mall, you will be finding 100 different kind of media assets, which I will be using for communicating the content or pushing the content or playing the content to the target audience. So next item is a kind of venue. A venue is a place inside a media aggregate or workspace. For example, in the mall, if you can create a venue like mall entry or a food court or a brand retail storeroom or a level 1, so or a children's play area. These are all kind of venue where target audience will be assembling, and they'll be looking for some information, or they'll be engaging in some activities. So in each workspace, you can create a multitude of venues. Then there are assets. So in the venue, you can now fix, or you can assign, or you logically you can put an asset like billboard, digital media, kiosk, or a website, or a virtual or AR engagement area, so that somebody comes to the venue, they can engage and they can interact. And now the third thing is IoT devices. So inside the venue, you can also have a IoT devices like IP camera, or edge camera, or a Wi-Fi access points, or you can have a security or a thermal scanning image, so that these scanners can take some data and send it to the backend, so that you can analyze that these are the crowd is having this much, and somebody is not wearing mask, or somebody's temperature is this much, or somebody came in this venue, multiple kind of things. Or so IoT. So in the venue, you can have IoT devices, and you can have a media assets like you can. So now the idea is, if IoT devices can detect something kind of thing, accordingly you can now you create a campaign, and you can schedule, and you can play the content into asset played on the kind of media assets. And campaign is nothing, the kind of communication where which we are going to flash or play into the asset which fixed onto different venues of a workspace. So it could be a digital content, it could be a physical content, or it could be a virtual content like AR or VR interaction, or it could be a streaming content like audio and video. So now from all this, these are the technology or terminology in the thing, right? So if you see the entire architecture of software defined, you can see that the Microsoft Azure perfect blend of technology which could satisfy our requirement, and we are almost using all these features in our platform. So where we are going to use our SDM? So SDM use cases which we are primarily meant for media owners, like conventional media owners like OOH or digital OOH industry, or retail industry like malls or theme park. And we have a hospitality use cases like hotels and resorts, and hospitals, and mobility use cases like public transport and manufacturing use cases. So one example I would so we used to deliver digital ticketing for one of the largest public transport system in India. And so what we essentially converted was, using our technology, we converted the bus as a IoT devices, and which could sense the passenger and check automatically their digital ticketing, and allow the passenger to travel inside the bus. So this is the kind of technology which we are doing for the next generation mobility use cases, or like metro, or public transport, hospitals, or mall, or university kind of stuff. So we also have an engagement platform called Research. It has a multiple integration with technology like AR and VR, and it has a technology like Wi-Fi and a BLE and NFC, so that it actually meant for discovering the physical world, so that you can now physically interact with the content or the communication across media right now. So the thing is, so how does the thing? So our entire software-defined marketing platform is actually running on the Azure, and we have a um, different pipelines for production, staging, and QA and development. Everything is right now accessing on the Azure, and the thing is, we are using Microsoft technology like compute and virtual machines, Logic app, and media services like streaming audio and streaming video services. And recently, we have started consuming the AI and machine learning like facial recognitions and IoT services. And so we also it's initially we were using the the Nginx as our load balancers, but now we are slowly planning to move to the Azure front or and kind of technologies. Yeah. So this is what actually I want to give you a overall architecture of the software defined marketing. And I would like to have questions coming back from the audience so that I will be more interactive and I can give you a much more broader perspective of what the technology, whether we are using Azure thing, and why we are not moving to some other technology like a function app or kind of stuff. Virtual, yeah.
Saurav, we don't have any questions as of now. You can continue. If there are any questions, I'll let you know in between.
Yeah, yeah. So, okay.
Please continue, Saurav.
Yeah, so actually I'm done with the presentation. So,
Okay.
yeah.
So okay then, let's wait for a few minutes. As of now, I don't see any questions.
Yeah,
We'll
so
just give,
I can give you a demo of the product. One second.
sure.
Yeah. Yeah, so this is the landing page of our cloud platform where it'll be there are a lot of so each customer will be getting a unique tenant ID to access the cloud platform. Once you go to the um, you once you enter the tenant ID, it will be taking to the login page. So, for example, yeah. So this is actually the landing page of our dashboard or the executed dashboard available for the tenant. And in this here, you can see the kind of number of venues managed by the software defined marketing and the number of asset managed by the thing and how many campaigns are currently running on the different assets in the different venues. And you can also see the kind of engagement or the actions happening on the campaign running, and you can also see the engagement trend. So now, if you go to the project level now this is actually this particular tenant is actually a retail tenant, and they have onboarded two malls in their thing. For example, there are two malls onboarded to the platform, and if you go inside a particular mall or a kind of aggregate workspace, you can see these are the different 36 numbers of venue inside a mall, and there are 39 assets already onboarded, and we have some 43 campaigns. So you can see now there are different media assets onboarded into the system. Like there are physical billboard, there are digital signage, there are different kiosks, everything we have onboarded. And we also have a venues where like different brand showroom or a kind of retail showroom configured as a venue. And in each venue, we have configured multiple assets. Now, if you run the campaign, now you can see there are multiple campaign running on each venue. And from the summary or the audience page, you can see the kind of actions or interactions happening on each campaign. And then ultimately you will be we'll be able, because we have not enabled the ROI tab here, but ultimately you can see for each campaign this is the kind of ROI you are getting to the thing from different medias and different campaigns.
As of now, we don't have any questions. So,
Yeah, I
are you
think.
done with the presentation?
Yeah, sorry, I'm done with the presentation.
Okay.
Looks like it's in the lunchtime, right?
Maybe, I'm not sure.
Yeah.
Okay. Okay, then thanks for the session, Saroj. It was a great session.
Okay, thank you. Do you
Thank
have
you.
any questions? Do you have any questions?
Nothing. Thanks.
Okay. Okay.
Hello, everyone. Nice to have you with me today. First of all, before even beginning, I would like to thank to the organizer for having me and congrats on the event.
Hi, Mihaela. Can you hear me?
Yes.
Okay. Thanks for joining in. Thanks for joining in, everyone. The session is going to be on many faces of architecture by Mihaela. Thanks. The stage is yours. Thank you. Take it up.
Thank you. I was just started to thank to the organizers for having me, and yeah, congrats for the event. It's a very strange period to have events, but it's nice that we can meet even in with this kind of solution. So thank you very much. My name is Mihaela Ghidersa. I'm a software engineer, and I always like to say that besides my interest in software and technology, I like to research and take things from other people's experiences, from my experiences, lessons learned, and create content for events like this one today, for trainings. Just discussing with people and doing some knowledge sharing. When I'm not coding or speaking, I like to do all sorts of activities outdoors. Well, it's a bit harder in this period, but just trying to make it fun. Today we are going to discuss about the two many phases of architecture, the way we interact with architecture, the way we use architecture in our team, because you will see that it's not only about the product itself, but also about the team. And as you maybe have noticed, I gotta say that this time I'm not here to turn your world upside down with technical concepts or give you perspective on the best architecture. Sometimes I think that this is a toxic tree that we have, thinking that it always is about the technical knowledge. Well, today I challenge you to quit being so emotionally attached to the rules, the tasks, the processes that we have and sometimes are never ending, and stop a bit, stare at the team, and use our expertise and knowledge to see the shape of the current context. We have to admit that, developers are real people, and all the technical stuff you can find everywhere. Like we have a lot of resources from conferences to tutorials to blog posts and things like this, where when it comes to team dynamics, when it comes to how to actually integrate technical knowledge into the team and create some team dynamics in order to make some of the technical things actually work, it's not that easy to find this kind of resource. So yeah, this is why we are here today to discuss this subject, or at least try to learn from each other. Beyond delivering a presentation, I'm here to contribute to creating better teams, to create better products. And yeah, as I was saying, I'm interested in learning from your experience. So I'm hoping that we can discuss at the end much more. And why not keep in touch? What is architecture? Oh my God, I think this question has been asked for so many times, and maybe people that were so much more experienced than us try to answer it. Well, to be honest, when it comes to clearly defining what architecture is, I looked and yeah, found many interpretations and definitions. Many of them were pretty confusing, I gotta say, especially if I'm thinking from the perspective of a developer that's in the beginning of the career of, just trying to understand a bit how the technology context actually works. So maybe you have to try to be a bit more explicit. So I tried, and I think, as a conclusion of mine, that software architecture is a set of characteristics combining both technical and business requirements. Of course, we have to take also into consideration both the product that we are building, but also the organization, the company and the organization of the company that we are being part of. With all this information, I will be able to define a structure that will help me build a performant, secure, flexible system, and so on. And here also depends of the quality attributes that we find as the most important for our application. So it is basically a structure upon which we build step by step. We add one component after another, creating relationships between those components. And consider that all of this is being realized while taking into consideration the whole picture of the system that we're building, of the system, of the product that we want to build in the end. So when we talk about architecture, we can't avoid the discussion about the confusion that we often make between architecture and design. This makes me think, again, that is because we have this tendency of defining it in a very abstract way. So we don't really understand what is architecture. So let's take it again. As already discussed, the architecture is a blueprint, a structure that defines at high level the units of our system, the way they interact, the way they evolve in relationship to one another. Choosing the right or the wrong architectural pattern will determine how those quality attributes that we were discussing will be, validated. On the other hand, a system design shapes things more at code level, the way components interact. And when I'm talking about components, I'm actually talking about, things like some modules, some classes, depends on the area that we are working with. What is the purpose of each of these elements and so on. Having a strong system design helps the development team be more organized, even more efficient, because when you are organized and write code in a very good way, you're also more efficient in terms of extending that system or of maintaining it, if it's the case. So it's easier to understand all the responsibilities, what can we do in one area of the application, what we can do in a certain area of the application. So all of this is possible by defining a system design, so we can later decide what design patterns we want to use, what is the context in which we can use certain approaches and things like this. If it is to extend a bit the discussion about the design, I really like this idea by Grady Bach, that he's saying about the architecture, that architecture is represented by the significant decisions that shape a system, and that significance is measured by the cost of change. And this cost of change is determined by a lot of other characteristics, but it's good to take it into consideration. About change, we will also discuss a bit later in the presentation about change and about decisions regarding both those changes, but also decisions in the beginning of the product. But basically, significant decisions are architecture, and the rest is design. So let's just conclude. Software architecture is focused on the entire system, while software design focuses on a more specific context level in the application. Components, modules, structures, things like this. Another very nicely expressed idea is by Simon Brown, that says that architectural decisions are the ones you cannot reverse without a high degree of effort. You can't change an architectural decision in an afternoon. So let's stop a bit on this idea, because precisely because we can't change an architectural decision in an afternoon, the first step in architecture, creating actually software architecture, is about understanding what is significant and why it's significant. When talking about significant matters, we talk about concepts like the technologies that we choose to work with, or maybe the high-level structures, or how to tackle some risks at some point. So let's go a bit more into the discussion about the significant matters. And a very significant part is the interaction of developers with the architecture. It's easy to think that if you are writing good code and following some well-tested approaches, it's not important to keep an eye on architecture. Well, there are some huge benefits for getting the bigger picture. From understanding how components in the system should interact, to which should have what responsibility, to the cost of what I'm doing, to how my decisions at code level impact the whole context, and so on. Having an overview on the architectural dynamics helps answering questions like this one. What are the components in my system? How they will evolve? Is what I'm doing on the same page with the evolution that the architects saw for these components? The change that I'm making in my area, where I'm solving my tasks, is going to make, I don't know, is going to take maybe some later decision be developed in a very long time. So time will be something that we'll need more. So my company or my team will have this cost. So it's good to actually take into consideration all of these changes. And since I'm mentioning change again, you know that Darwin's theory says that the species that survives the longest is not the strongest, but the one that adapts better to change. Well, I like to think that if Darwin would have worked in software development, he would have stated that the system that survives longer is not the strongest with the best qualities, although they are important, but the one that has an architect that is able to predict and adapt better to changes. So the best solution is to build an architecture that anticipates change and it's open to evolution. And as we were discussing, we had to deal for a long time with this idea that the development team should get their attention, more on the coding part and don't bother with architectural concepts because, your task doesn't mention something like this, so just stick to your task. And I have to be honest, it's such a wrong way of looking at things or doing things in a team. Because, as I was saying, there are benefits to having the overview look. And let me give you my perspective. When I stepped a bit from my editor, and trust me, I did this because at some point, nothing made sense anymore in the project. So I had to try to find solutions on how to solve some problems that I had, and I just tried to understand what is happening. I started asking, and I started looking a bit more on the entire system, how my work or the area that I've been working with will impact other areas, how my module, the module that I was working with, will impact the evolution of the product or what other teams might be doing, because we were working in several teams for several features in the team. And the moment that I started doing this, everything started to make more sense. And instead of complaining, this is something that I really liked about my evolution as a developer, because this moment made me become a more solution-oriented person. I stopped complaining about, oh my God, why isn't this working? What decision are they making? And they're bad decision, and I don't understand how they are capable at a high level to take this kind of decision, and actually understand why they took those decisions, because now I had the whole picture. And I just tried to come with my solutions and discuss with people that had the power to actually do some changes. So it all started with this mindset of looking a bit outside of my coding box. At that moment, I was able to see where some technical guidance might be needed. I was able to visualize how components interact. I changed my perspective, and I actually started liking it more, liking my job even more. So, that's pretty important. And by doing this mindset switch, I was able to quit maybe on some of the myths that I've grown to believe in time, such as, software architecture is something that we discussed in the beginning and never changes. So we don't really have to think about how we impact that, because architecture is strong and the architect is the one that has to guard that. Architecture is not about coding. Oh my God, this is another myth that I had to go over. And yeah, the architecture is an architect's problem. We don't have to take care of that. So I think that it's important to discuss things like this in order to break the toxic cycle. So let's start. And let's start by discussing, since we were having a meet about this person that we thought that it's his or her problem. Architecture is his or her problem. Because we can't really discuss theme and architecture without discussing this key role, the architect. And I just want to let clear from the beginning that independently of what we are about to discuss or how often the role of an architect is pretty hard to clearly define, well, it's good to actually have some metrics or some idea about how this role might evolve in time. Of course, depending on the context in which we work or the methodology that we are using. What is common and what I strongly believe is that there is a strong need for evolution, experience, gradually growing towards having the expertise and the attitude that will help a developer face the role as it comes. And this role comes with both challenges and a lot of decisions that have an impact. So let's just try to see some of the myths or some of the ideas that we had until now regarding the architect role, and just try to define how it's better to actually work with the architect in terms of also team interaction. So for the longest time, the idea was that the architect, the one that at some point maybe he was also a developer, just went away from the team, and there's nothing related to code, just spread some directions and creativity. Now, I have to apologize for the irony, but giving my experience again as a junior, I remember that I worked in a project for like 1.5 years, and I never got the chance to meet the architect. So later on, when I started working in a team where the architect was having the desk next to mine, I was so impressed about how open he was to work with the team and explain and try to understand what are the burdens that we are having. And in that moment, I just understood that architect, it's more than a title, it's a role. So let's see. This role is defined by the person that is taking it right in the end. So it's important to, beside being in interaction with the team, close to the team and open to the team, a thing of leadership that we will later discuss. This person also, we had a myth that has to have the most experience, like he has to know it all. And, I'm thinking the whole stack. The architect has to know the whole stack, every technology, every detail. This is preposterous. It's unrealistic, considering the speed with which the technology stack evolved in the last years, in the last decade. This means a lot of pressure on an architect. Who would ever want to take such a role? I think that it's more about, being part of the development process, understanding what is happening in there, come with the perspective of an architect, and use the expertise of the team. Of course, it is important as an architect to have an overview, to have knowledge about practices, to have experience in a lot of projects, different projects, in order to, have both good and bad experiences and lessons learned. But you don't have to know every detail of every technology. It's more like trust the team, collaborate with the team, and see what are the results then. Then there was this myth that the architect defines and guards the architecture. And we already discussed that The architecture is not something to guard. It's not something that we, forever keep in place since the beginning of the project, especially with the speed in which the market is changing, stakeholders, expectations, and requirements, user requirements. You are a user yourself, you know how much you want to have your applications up to date with the latest trends. Well, there are some developers in there, some architects that have to comply with that. So it's pretty hard in this time to actually have a very strict architecture that you follow from the beginning to the end. It might suffer some modifications in the process. Of course, in here I have a disclaimer. If we are discussing about a very simple project with no complexity, almost no complexity, it might be that the architecture might not change in time. So it's okay. I'm not saying that will always evolve, but most of the time, especially when we work towards complex structures, the architecture might evolve. So the architecture is not being built by only one person. We need to get away from the mindset that the architect is the person that architects the architecture. I'm not saying that the team shouldn't have someone clearly owning the role, but somewhere in time, in the evolution of the project, any team member can come with ideas and some insights and some suggestions that can impact the current state of architecture. This is what I mean by a very flexible role and collaboration. Yeah. So just go with this if you want after the discussion, that architect is a flexible role, is a role in which we have to use the technical expertise of the team while growing the team. And the architect is someone that understands the system from high level, but also understands the developer's perspective, or how the idea, the high level idea of the system is actually being implemented. So in the following minutes, I would like us to look at some drivers or some ideas that make the difference in the role of an architect. And maybe if there is something that you will remain with after the conversation that we are having, make this two. One is the leadership part, and how in most of the time we have to go over the management part and be more leaders than managers, and how it's better to have expertise, it's better to have knowledge and an overview than knowing it everything, which we already discussed is not really possible. So let's start with the first one. Leadership goes over management most of the time, and when we are talking about the team interaction again. There's a difference between management and leadership. Management is more about some tasks, some processes, metrics, very specific steps. Leadership is more about people, about who you are to them, how you inspire them, how you show up for them when they need you. And I gave you the example of the good architect, the one that was standing right, the good architect, oh my God, how this sounds. Let's say that it was a more open architect, open to discussion to the team. Well, he was a leader because he was open to the team, he was in the team, he was collaborating with us, and he knew how to put some limits in order to be able to do the role of an architect, also taking his time to work with stakeholders and with business and things like this, because you will see that the role of an architect is more than just creating a structure and then staying with the team. An architect should be a leader that has a better overview, definitely. Should have experience in a lot of areas, should have a lot of lessons learned and insights in both technical and business requirements. But in the end, the architect also has the responsibility to raise the team. Because if you have a very weak team and the knowledge is, not so good in the team, you can have the best architecture. Chances are at some point you'll have to think about how to solve some technical debt. Also, the architect has to be very careful about the fact that team members have different experiences, knowledge, perspectives. So he has to take care that everyone understands his or her perspective in terms of architectural structures or the vision that he has when it comes to architecture, in order to be sure that everyone is working towards the same goal. So we don't usually talk so much, when we're talking about the architect, we don't really talk about these kind of things, the soft side of being an architect. But in the real world, an architect's role is both worrying about important technical decisions, relationships with stakeholders and business and things like this, but also leading. He is the one that gives the team a direction. He has to explain, has to coach the team, and has to collaborate with the team. We are basically talking about a full-time leadership role. So yeah, soft skills are extremely important. And one thing that I want to underline in here maybe is the fact that a team with the same view finds it easier to collaborate, and it's more engaged and delivers quality and quantity. And again, I have this kind of experience, and I was able to see the changes in how people worked, how people resolved their tasks in the end, and how open they were to actually discussing solutions for the problems that they encountered. So team dynamics are so important, even when we're talking about architecture. Then we are going to the second thing that I was mentioning in the beginning, expertise over knowing it all. If you ask me, I really think that an architect should have software development background. If as an architect you don't know and you don't understand what is happening in the code base, you might fail to make good decisions. But then again, here is where the misunderstanding is being born. Many think that the architect has to also be the best developer in the team. We already discussed that it's almost impossible. We can't master the whole stack. But I think there is something even more valuable than mastering the whole stack. And that is the ability to switch between code, implementation details, and the big picture. I think this is more important than knowing every detail. And yes, as an architect, you should own best practices, approaches, have an overview and design, know the patterns in order to make the best decision, of course. See what patterns work better with what technologies in order to choose the right technologies for the context in which you are going to use them. But when it comes to keeping an eye to the details, to the low-level code, I think it's true that the value exists in using the technical expertise of the team. The collaboration that we were discussing before. What we need in order to do this is to create a trustful and an environment where we can collaborate and where people can express their ideas and their expertise, because there is expertise in the team if we look closer. So being an architect is challenging and takes a lot of knowledge and experience. At the same time, you don't need to be an expert in every particular area of software development to become one. It's better to have a broad understanding of software development and be able to communicate your knowledge and communicate in an effective way. And also always be backed up by best practices and experiences. I find it important to know that you don't have to be the god of the technology stack. And I can't insist more on this. More is useful to have a broad perspective on software development, emotional intelligence, leadership skills, and some coaching for the team. And maybe going a bit outside of the team, but not for too long, it's very good to understand how you're making decisions and how decisions impact your system. As the business evolves over time, so do the things that we do in software. It's just a natural consequence. Sooner or later, depending on the context or the domain in which our product is being developed, we will need to make some changes. What we need is to think in terms of building tolerance to change in the system. Observe where and what kind of changes appear through iterations. This way, you can expect this kind of changes and be prepared to meet them. Just try to see a bit in how you can control things. So in the end, why so much analyzing? Well, because when you're an architect, your decisions impact a lot of areas in the system and also impact a lot in terms of cost, resources, and requirements. So making decisions concerning architectural aspects is a very sensitive aspect because those decisions are, full of impact. One of the best practices in software development is to avoid making decisions until the very last moment, because especially in architecture, there is always a high level of uncertainty. And why is that? Well, because there are a lot of things hard to predict. We were discussing changes. You can't predict exactly how the framework that you are working with right now, that is the base of your architecture, maybe will evolve in 5 years. You can see some ideas or some directions, but you can't know 100%. So any fixed decision might take us to the wrong path. This is something that we need to be aware and try to push the moment of making a decision to the limit. Another good aspect, because you can't push that decision on and on and on. So another aspect or another approach that you can take is think in terms of evolvable structures. Always build in mind with the idea that at some point, if you need to add something to delete something or make any change, your system will allow you with the lowest cost. There will be a cost, definitely, but you have to think in terms of creating this kind of capacity for change into your system. So we talked architecture, we talked architect, we talked team context. But how about the ones that want to grow from developers to architects? Well, I want to start by pointing out that becoming a software architect is not something that you become automatically. As we discussed, is a role, and it's hard to strictly define it. But the road to becoming an architect will always be full of challenges. In that road, we have to build experience, and we are the ones responsible for building this. So there's experience. We need to build expertise and the confidence in order to, in the end, be worthy and ready for the role. From what we've discussed, maybe with some exceptions we already mentioned, architecture is part of the development process. Part that later is taken over and being implemented in the team. Architecture is not about forgetting implementation details and just staying and looking at abstractions and not care about how it is implemented. I think that you become a good architect when you're able to slightly move from one to another, as we were mentioning before. Software architecture is about understanding how the system works as a whole and going from contributing. Let's say that as a developer, you can contribute to the architecture we discussed. But it's a difference between being a contributor and being the one that is responsible for making changes. So you need to make some steps as a developer if you're interested not only on becoming an architect, but also maybe you want to step up your career and go to the next level in your career. So whenever you want to do this, look at the ones that have the role that you are interested in having at some point where you want to grow, and see how they are doing things. Ask for their perspective. Ask for their help. Find a coach, find a mentor that will help you. Basically, what I'm trying to say is that it's your professional duty to actually change the context, change the perspective, and evolve from your level. Make any learning opportunity that you have a significant stone in your career. Don't wait for someone from outside to come and tell you, oh my God, hi, would you like to be an architect for our team? Because that is never going to happen. You have to build, you have to create the best context for you to grow. You have to look at the ones that you admire and try to see how they are doing things, how they are making decisions, and things like this. The other professional duty that we have is from the architect. And we already discussed this, so I'm not going to insist very much. But the architect has the responsibility to cross the line to collaborate with a team in order to make informed and reality-oriented decisions. You can master it everything. So why not just work with the ones that you have closest? The experience will be next level. Then we have this idea that, okay, you might be thinking, so Mihaela, are you actually saying that if the team is self-organizing enough, the role of an architect is not important anymore? My answer is not. Why I'm saying this? Because we have to keep it real. Yeah, we might have a team of seniors, or more like, let's take into consideration two aspects. One, how complex is the system? Because if the system is not that complex, again, we are going to the same discussion that we were having before, that maybe the system won't change, so we don't need a lot of decisional impact on the way. We don't need someone to actually take responsibility for those decisions or the changes that are going to happen and things like this. So we have a team of seniors. Most of the time it might work. If the system is stable, maybe you can have someone that just from time to time checks to see what is happening in the architecture. But in real life products, where we actually have different developers with different kind of levels of knowledge and engagement, it's pretty hard to have that self-organizing vibe, to say. So we need someone that takes responsibility for the build, for the project we are building, for the product that we are building, and we need someone that is focused, that keeps the relationship also with the stakeholders. We need that person that has the overview that we are talking about in order to be sure that everything is working smoothly. So developers, can grow, can actually at some point become an architect, but it's important to put this accent in growth. Developers should grow into becoming an architect. So we have to understand two aspects. The architect is important, especially in evolvable products, and having an overview and engagement with a system architecture does not make you an architect. So being an architect is a bit more than that. The second, the fact that you have an architect does not make you responsibility free of how the system will evolve in terms of quality. And not only. Let's think about quality attributes. You can say, oh my God, the feature that I built is not okay, so I'm just going to blame it on the architect because it's not working like that. It's team dynamics, again. So as a developer, you are taking, at some point, parts of the role, but it's your responsibility to actually create the context for yourself in order to grow, to actually deserve the role. So yeah, architecture is for every developer, and I highly encourage you to understand what is happening in the context of your project, and not only architecture as a general idea, but that doesn't mean that only by doing your daily tasks you will become an architect. So it's your professional duty to do more in order to step up your game and go to the next level in your career. And again, we are discussing about this difference between, okay, are we going to just focus on our thing? Definitely not. We already discussed. I'm not going to insist on this. But it's good to remain with two things. As an architect, you need to understand the context of the application, components, code base from a developer's perspective in order to take more informed and realistic decisions. And I'm not saying that you have to write code like stay from 9 to 5 and write code all day. No, but you can use the opportunity of doing reviewing a PR or looking from time to time to the code base, see what is happening in there. You can keep track in a very easy way without being too focused on low-level code. Then the team will understand the impact and importance of their work and will trust you more. So there is no such thing as coder's gonna code and architect's gonna architect. The thing that I strongly believe in is team, leadership, and creating expertise. Not knowing a lot, but not understanding a thing. So, although we discussed a lot about the best ways to do things, there always appears a gap between the development team and the architect because, yeah, sometimes we put, again, on, or we put first the technical matters more than the team dynamics. So, in order for everything to work very nice, the effort has to go both ways. So the team has to collaborate with the architect and the architect has to collaborate with the team. Software development is a team activity, and in the end, even unintentional, we will help each other grow. There is no doubt in that. Even architects can grow from where they are. Even though they have some knowledge, they always have to, or can and have to build more and stay up to date with what the technology stack is offering. So architecture definitely is not an esoteric concept, but it's not an easy road either. But this doesn't mean that if you make one step at a time, you can't grow in the direction that you find interesting. You definitely can. Always surround yourself with people that are better than yourself. See how they approach certain issues. Read their code. Look at why they did some decisions and think how you would actually decide or how you would approach a problem if you were in their case. Challenge the architectural decisions. Of course, come with arguments when we are challenging. Don't just say, I don't think your architecture is good, and then bye-bye. No. Try to understand what is happening in there. Ask to be involved and ask for help. Don't be afraid to ask for help. There is no reason to be afraid if you are determined. Then for the architects, when it comes to building the right architecture and for the right context, I came to learn that the most important maybe fact is that the architect in the architecture has to be engaged with the team. The value that this approach brings in terms of very quick feedback on the architecture is something that is a game changer. On the other side, the best way to keep the team aware about the architectural vision and direction is keeping in touch with them. This way, again, they become more efficient and build a better product, besides the fact that they will be much more engaged with their work in the end. Always lean for collaboration, work together, and create two-way feedback processes. In the end, maybe from Monday, I'm not saying today, but maybe from Monday, you will just go a bit out of your zone and look at the team from another perspective. See what you can change in order to create a better product. Don't get lost in details, don't get lost in abstraction, but more like collaborate and try to understand what you're building. In the end, this is what matters the most. Thank you very much, and let's see if we have any questions.
Hi, Mihaela.
Hi.
Let's wait for a few seconds. Let's wait for a few minutes. As of now, I don't find any questions. I have one personally, if you can take that up. Like, how do you, if you need to change your architectures pretty quickly, let's say you're working on already pre-built application. If you want to change the architectures quickly, do you have any frameworks for that? Steps to change the architectures quickly?
So basically, you're saying that, okay, we are in a project that has already an architecture in place, so I have to change it in this moment, how to make the best decisions.
Exactly.
Especially if the product is, let's say, in a very advanced stage, I wouldn't go with the idea of changing it very fast. I would challenge actually the stakeholders that I'm thinking that usually stakeholders push most in order to change things, to actually give me time to create a gradual process of changing the architecture or evolve with the architecture in the direction that I want to go. Because first of all, you need the expertise and understanding of the current product. Then you have to see if all the reasons for which we want to change the architecture are really valid. And then we have to see how we can build an architecture or go towards an architecture that later on we won't have to change, but more like extend. So I wouldn't, I at least from what I know, there is no magic tool that does that and this for us, but more like we have to be very, to pay attention to the context in which we are working, to, again, as I said a million times in the presentation, to be sure that as architects, we have the perspective and the experience to actually work with different systems in order to have an overview on how the approach that I'm using right now is not going to end up in something that I want to change in, I don't know, 6 months, 2 years, or things like this. So I would do it gradually to make sure that I'm building in terms of evolvable structures than doing it quickly and not have the time to build something that I'm sure that it's of quality and that evolves naturally. And it is also very hard for the team to change just like that something, because you'll create a lot of technical debt. So think of terms of evolvable structures and how your architecture with which steps or what steps you need in order to evolve from the current state to the state that you want to take it.
Thank you. That was a wonderful answer. I don't see any questions. Probably, if you don't have anything else to come, let's complete the session.
Okay. If at some point appear questions, you can find me on LinkedIn, you can find me on Twitter. Let's discuss if you have maybe some experiences to share. Thank you very much for having me, and have a great day full of knowledge today. Thank you very much.
Thank you so much. Hi everyone, thanks for joining in. The next session is going to be on building an end-to-end ETL pipeline using Azure Databricks by Mohit Batra. Hi Mohit, can you hear me?
Hey, hi Shri, I can hear you. Can you hear me as well?
Yes, all good. You can
Fantastic.
start sharing your presentation.
Sure, we'll do that in a second. Can you see my screen?
Yes. Okay, so
Fantastic.
please post all your queries and feedback will be on the URL, and please post your queries for Mohit on the YouTube chat window. Thanks everyone. Mohit, the stage is all yours. You can take it forward.
Yeah, thank you, Shri. First of all, thank you, Shri, and your team for having me here at the Azure Community Conference. I'm very excited and looking forward to, deliver this session. And thank you, everyone who has joined in to attend this session. I hope this will turn out to be a productive session for all of you. So basically, this session is all about building an end-to-end ETL pipeline with Azure Databricks. Quickly, before we go and look into the session, let me quickly introduce myself. My name is Mohit Batra. I'm founder at Crystal Talks. This is company that this company is into training and consultancy. I'm also an author with Pluralsight, so I do publish a lot of video content, not just at Pluralsight but at other places as well. I'm also a Microsoft certified trainer. Of course, I'm a trainer, so I do deliver a lot of classes as well. And prior to working full time as into training and consultancy, I worked at companies like Microsoft and Saxo Bank. My LinkedIn profile is there on your screen, so in case you wish to get in touch, I'll be more than happy to connect with you. All right, so let's get started and look into what is the agenda for today's session. So we have got around 60 minutes. So what we'll do, first we'll do a quick introduction on Apache Spark. So we'll not be going deeper into the concepts of Spark, but we'll quickly talk about what is Apache Spark and where we can use that, what are the challenges associated with it, and stuff like that. Then we'll talk about what is Azure Databricks, and we'll look into what are the features of Azure Databricks and what kind of problems it can help us solve. And finally, that's where we'll be starting building the ETL pipeline, and that is where we'll be spending most amount of time. All right, so let's first look into the first part, which is the Apache Spark, and what exactly is that? So Apache Spark is basically, and it's a very powerful in-memory engine. So if you want to build, if you want to process massive volumes of data, if you want to do parallel processing, so this is an extremely powerful in-memory engine. So which means all the computation is performed within the memory, and whose memory? It is basically in the memory of the cluster. Now, if anybody who is not aware about the cluster, so cluster is basically a group of machines which works together to actually, to process the data. So Spark is basically an in-memory engine which can, and it processes the data, everything inside the memory. So this is what is Apache Spark. Now, let's see that, now we have talked about the cluster computing technology, which means it works on a cluster. So let's see what do we have here. Now, what you can do, you can download the Spark and you can install it on a single machine. So you can have your laptop, and on your laptop, you can download Spark and you can install that and you can start working with it. So there is absolutely no problem if you're working with Spark on your laptop or even on one single machine. Now, since Spark provides distributed data processing, so that is why you can install it on multiple machines as well. So that means you can have it on one machine or you can have it on multiple machines, and these machines can work together as a cluster. So you can have the Spark on all these machines, and now you can start doing the distributed or the parallel data processing. So that is what we have in the Spark. Now, why do we need Spark? As I mentioned that, it's an open source engine which can help you perform distributed data processing. Now, I'm sure many of you must have heard about Hadoop, and a lot of you must have worked on Hadoop as well. So basically, Hadoop used to perform disk heavy processing, which means it used to work a lot on, with the disk. But when we talk about Spark, it is basically an in-memory engine. And because of that, it can perform even 100 times faster than Hadoop. So, this is very, very powerful. It can work up to 100 times faster than Hadoop. Obviously, it depends on the scenario and what kind of data you are processing, but then it can work really fast as compared to Hadoop. It is an open source project, so you can as I mentioned, you can download and install it on your machine as well. And the interesting part here is that it has got support for multiple languages. So you can write your code in Scala, Java, SQL, R, and Python. Even there is an open source support for C# as well. So you can write your code in C# and run it on Spark. So there are a lot of different languages are supported. So you feel free to write your code in any language and you can work with Spark. All right, so this is what we have, that is why Spark is very beneficial. So now let's see the architecture of Spark here. So as I mentioned that you can use any of these languages to write the code. And at the bottom, we have got Spark Core. Now, what is this Spark Core? Now, this is the engine of Spark, or this is the heart of Spark. So the actual distributed data processing is performed by, the Spark Core. Now, the interesting aspect here is that on top of Spark Core, you can, there are multiple built-in in fact, there are multiple libraries which are available. So for example, we have got, Spark SQL. This library can help us perform, the batch processing of the data. So if you want to work with, let's say, if you're building, if you want to process the data every day at 9 p.m., you want to process the data in batch. So this is where you can use the Spark SQL library, which is the built-in library, or which is the library available along with Spark. Then there is another library for performing streaming. So you can not just work with batch data, you can also work with streaming data. So you can do batch processing, you can do stream processing, and then if you want to perform machine learning, so there is a built-in library which is available, you can use that. Or if you want to use any third-party libraries, you can also do that as well. And if you want to perform graph computation, you can do it here. So this means that Spark is one single engine that can help us perform, first it is helping us perform distributed data processing. You can do batch processing of data, stream processing of data, machine learning, and graph computation. And you can write your code in any of these supported languages, and that will work with Spark. So it's a very extensible, very powerful, very useful engine, which is Apache Spark. So it's all good. People have been using it for a long time, and it's working out pretty well. But now the thing is that there are certain problems which are associated with Spark. Obviously, whenever you're working with a certain technology, there are always certain challenges that come along with that. Now, one of the biggest challenges, or in fact, some of these challenges which are with Spark, is that you have to manage the infrastructure on your own. Now, why do you have to do that? Because Spark is just an engine. It's a small utility that you can download and install it on your machine. So if you are installing it on hundreds of machines, this means you have to take care of the infrastructure. So think about if you want to process terabytes of data, you need to have those hundreds of machines which you need to set up, and then you have to install the Spark on all the machines. If you want to do an upgrade, that is something that you have to take care of. So because the problem is that it's just an engine. So you can work with it, but all the other things you have to take care of, like security. If you want to do development, there is no user interface which is available. So you need to use any open source interface to do the development. So infrastructure is a challenge. There is no interface because it's just an engine. That's also a problem. And if you have installed the Spark on hundreds of machines. Now, what you are doing, you just want to upgrade that version. So obviously, there is another problem with that. You can't upgrade, or in fact, if you have to upgrade, you have to go to all those machines, and then only you can upgrade to a newer version of Spark. And Spark, the newer versions comes up very, very frequently. There are a lot of development which is happening. So that is why upgrading to a newer version is a bigger challenge here. Then, of course, you need to have the other tools in place to do the development. And obviously, when you're working in a big team, you want to collaborate with other developers or your colleagues and friends, and it's very difficult to do that. So these are some of the challenges which are associated with Spark. Now let's see that how Azure Databricks can help us solve these challenges. First of all, know that Databricks is an independent company. It's a separate product. Now, on Azure, Microsoft has taken the Databricks product and they have onboarded onto Azure. So Azure Databricks is a first-party service in Azure that can help you. So basically all the support, all the support and all the other good features are coming from Azure as well. So basically, it's a collaboration between Azure and Databricks. Azure has onboarded the Databricks platform, of course, onto Azure. So let's see what Azure Databricks is. Now, Azure Databricks is an engine which is based on, or in fact, it's a platform which is based on Apache Spark. That means that it is giving us all the good features that Spark has, But along with that, it is providing us a platform where we can do development, where we can collaborate, where we can handle the security. So all these different features are available within Azure Databricks. So it is one single platform which has been optimized for the cloud, and you can utilize Spark here. So let's see that, what are the features of Databricks. Now, when you have now obviously Databricks is a platform based on Spark. So everything that you have in Spark, that is available on Databricks. So that means you can perform in-memory distributed processing of data can be performed by Databricks. Then it has got support for all the same languages: Scala, Python, SQL, R, and Java. All these languages are supported. And you have the same use cases, you can perform the same use cases that you perform with Spark. So you can do batch processing, streaming, machine learning, and advanced analytics. So all these things which you do with Spark, you can also do it on Databricks. But along with that, let's see that. So this is the platform of Databricks. So Databricks is available on Azure. It is available on AWS. And now it is also available on Google Cloud. So it is available on all the three major cloud platforms. Now, on top of it, we'll talk about what are the features it support. So along with all the Spark basic, all the Spark features, it also provides a platform and in fact, the Spark here is highly optimized. So that means you don't have to worry about the optimization of Spark. There are many other there are many optimized features which have been added to Databricks. So you can simply go to Databricks and you can just set up the infrastructure with a few clicks. So you just need to go to Databricks and say, okay, I want to set up a cluster with, let's say, 100 machines. That's it. So it's just a matter of few clicks that your infrastructure will be ready. And who is going to provide that infrastructure? It is the Azure who is going to provide the infrastructure. So I'm sure all of you are aware that you can create virtual machines in Azure. That is why you can go to Databricks and say, okay, I need a platform, I need 100 machines, and you can get those 100 machines with just a matter of few seconds. Now, once you have the infrastructure ready, it also deploys the Spark on top of it, so you don't have to worry about deploying the Spark on your cluster. Then along with that, it also provides us a UI where we can start writing the code, and we can also do collaboration with our colleagues. So obviously in a bigger setup, where are, let's say, hundreds of developers are working, or let's say, even if it's a small team with 5 to 7 developers, or 10-15 developers, you can also work on that. You can also use Databricks. Or even if you have hundreds of developers, plus you have got data scientists, you have got business analysts, all of them can work on one single platform. So on one side, the developers or the data engineers can write the code. The analysts can, use the, you can use the data sets which have been created. They can, do the analysis of the data, and the data scientists can also consume the data to build their machine learning pipelines. So all these things, or in fact, a complete collaborative environment is available within Databricks. Now, the next thing is that obviously, when you're working when you have built your pipelines, let's say you have written your code, and you want to process the data every day, or you want to process your data every 6 hours. So what you can do, you can write your code, and then you can schedule them as jobs within the Databricks platform. So Databricks is not just helping us build an end-to-end system, but it is also providing us with with an optimized Spark environment that we can utilize. So let's see some more features. Now, it also provides us with the enterprise grade security. So whether you are working on Azure, you're working on AWS, you're working on Google Cloud, the Databricks provides us with enterprise grade security. Now, specifically when we are working with Azure, the Databricks is fully integrated with Azure Active Directory. So you can fully utilize the Azure Active Directory, whatever users you are configuring in Active Directory, you can use them, or you can allow them to access the Databricks platform. So Databricks is fully integrated with Azure Active Directory, so you can you get the full enterprise grade security here. So this means, for the administrators also, it becomes much more easy to manage this environment. Then on the other side, there are, as I mentioned, there are lots of optimizations that have been added in. Now, one of the very interesting things is that when you are using, let's say, you are using Databricks and you set up the infrastructure, by default there are lots of predefined libraries or in fact there are a lot of libraries which are automatically installed. Now let's say I'm working with PySpark or I'm working with Python on Spark. So obviously I would want to use some other libraries as well, which are open sourced or which are very useful for doing the development. Now in the Databricks platform, whenever you set up your infrastructure, all the, in fact, there are a lot of common libraries which are pre-installed as soon as you create your cluster. So you don't have to think about, okay, I want to work with, let's say, HTTP. I want to make some REST API calls. How do I do that? So that is available within the Azure Databricks platform. So that is the benefit of using one single platform for doing development, for scheduling the jobs, and for having multiple personas like the data engineers, the business analyst, the data scientist, all working on the same platform. And finally, it also perform. Let's say you deploy the Spark in your on-prem environment, and if you do and let's say you're running some code, the same you deploy the same infrastructure in Databricks, and you also run the same code, you can get up to 50 times higher performance. So any deployment which is there in the on-prem, obviously you will require specialized engineers to optimize that environment. On the other side, if you come to Databricks and just start running your same code on the same infrastructure or the same set of infrastructure, then you can get up to 50 times better performance. So with Databricks, you're getting a fully optimized platform, you're getting the complete infrastructure management, you are getting a UI to write the code, you're getting the full enterprise grade security, and you can even put your pipelines in production. So that is what we get from the Azure Databricks platform. All right, now let's move on and let's see that what are the different components which are associated with Databricks. Now, I'll not go through all these components here. We'll see these components as we go in the demo. So we can, for the Databricks, you can create one single workspace where all your, all your users, all the, let's say, again, the data scientists, data engineers, business analysts, they can come to this workspace and they can work together. Then in the Databricks, you can easily go ahead and set up the clusters with just a matter of few clicks. As I have been mentioning, as I've mentioned few times, you can just create your clusters with a matter of few clicks. Then you get notebooks where you can start writing the code. This is the built-in feature of Databricks. You can write the code. You can connect it to, let's say to your source control like GitHub or Azure DevOps. You can connect to it, and then you can, all your code will be automatically checked in or saved inside your source control. Then if you want to schedule your jobs or if you want to schedule your pipelines, you can use the jobs feature. There is also a feature of databases and tables. We'll see that what exactly does that mean. And if you want to manage your machine learning models, you can also do that inside Databricks. So these are the different features, and obviously there are much more, like Delta Lake is there. So there are lots of different features which are there in Databricks, and we'll start seeing some of the basic features of Databricks here. All right, so let's move on. And before we go forward, let me just bring up a quick slide about the ETL pipeline. That is what, the things we are going to do here. Let's first understand this ETL pipeline with Spark, and then we'll see that how we can build one. Now let's assume that there is some raw data which is coming in from different sources. So it could be data coming from databases. It could be data coming in the form of files like CSV files, JSON files. It could be any kind of format like Parquet files, Evro files. So there are different file formats which are there. So the data, which is structured raw data, which could be in the form of, let's say, which could be coming from databases or business applications. So what you can do, you can get this data and put it inside, let's say, your data lake. Now, when I say data lake, this could be Azure Storage. This could be Azure Data Lake Gen 2 service. So we can go ahead and put this data into data lake. Now, when we, now this is something we will not be doing using Databricks. Why? Because there are other different tools like other ETL tools which are available, which can perform this job better. For example, I can use Azure Data Factory to move my data from my sources into the data lake. Then on the other side, so this is about the structured data. On the other side, you might have got, you might be getting data from IoT devices, or you might be getting data from your log server. So there could be, all the streaming data which might be coming in. So let's say, I am, let's say there is a banking system, and banking is, there are some transactions are happening. So all these transactions are continuously coming into the system. Or another example, let's say if you're building a solution for, let's say, taxi rides. So it could be Uber, it could be, it could be Ola. So there are different taxi ride services which are there. Now, let's say anytime the taxi ride will start, I want to capture that information. When the cab is moving, I want to capture that information as well. So this means there is streaming data which is coming in. Now, what we can do, we can take the streaming data and maybe put that into Azure Event Hubs. So you can put that into Kafka, you can put that into Azure Event Hubs. So any kind of stream ingestion service, you can put this data. Now, this is something which is outside the scope of Databricks. So what we are doing, we are capturing the data, which is batch data, and we are capturing the streaming data. Now, what you can do, now you can process this data using Spark. And not just Spark, but Spark on Databricks. So which means now we have already talked about that we can process batch data, we can process streaming data, we can apply machine learning. So what we can do, we can capture the data from all these different sources, whether it is streaming, whether it is batch, and we can process them using one single pipeline using Spark or Spark on Databricks. So Spark gives us a very good set of APIs to work with batch and streaming data, and the code is also very similar. So what you can do, you can write one single pipeline to handle the batch as well as streaming data. Now, once we process this data, we can go ahead and put this back into Data Lake. So now we have got the raw data being stored into Data Lake. And that's what you can see here, raw data being stored into Data Lake. And of course, we can go and put the streaming data as well into Data Lake. So there are different types of architectures we can go and set it up here. Then we have also got the streaming data, or in fact, we have got the process data inside Data Lake. So we have now one single repository for having the raw data as well as for the process data. Now, once we process this data, of course, this is not the only place we can keep the data. From Databricks, we can put the data into databases, let's say SQL Server, Azure SQL. We can put it into a dedicated SQL pool of Azure. We can put it into Redshift. We can put it into Snowflake. So wherever you want, you can put your data after processing using Databricks. Now, once we have this data, this process data, then we can go ahead and consume this data, let's say using Power BI, or there are various other tools which we can utilize to analyze the data. So what we will be doing here, we'll be focusing on using this data lake where I already have the raw data. So I'm going to process that using Spark, and then we'll be putting this data into Data Lake. So these are the three areas we'll be focusing on, and this is where we'll be extracting the data. This is where we'll be transforming the data. Of course, we'll do the extraction from Data Lake. We'll transform it in Databricks, and then we'll load it into back to Data Lake. So this is the ETL pipeline that we'll be building it in the next 40 minutes. All right, so let's move on and see, let's look into the demo now, that how we can build this ETL pipeline. First of all, let's understand that, how we can set up the environment of Databricks, and then we'll look into the code that we can use to build this pipeline. All right, so let me take you to my Azure environment. So here I'm inside the Azure portal. So what I can do here, I can go ahead and create a new Databricks workspace. It's a very simple task. So I can just click on create here. I'll not be doing it because I already have the workspace, but I'll show you how easy it is to do that. So what you can do, you can use your subscription, select a resource group in which you want to deploy this, or in fact, in which you want to keep this workspace. Define the name for the workspace here, and select the region in which you want to deploy that, and select the pricing tier. Now, obviously, there are two pricing tiers which are available. One of them, the standard one, is good for most of the people. But if you want to have fine granular controls on, let's say, because you have got clusters, you have got notebooks where you are writing the code. So if you want fine-grained access control on these objects, then you can go for the premium pricing tier. Of course, there are more benefits of using premium tier, but for most of the scenarios, it is good to use the standard pricing tier. Now, once you do that, you can just go ahead and create this workspace. So I'm not going to do that here. So I already have the Azure Databricks workspace available. So what I can do, I can go to one of my workspaces, which is the Azure Databricks workspace, and then I can go ahead and launch the workspace. Now, when I'm launching the workspace, carefully notice, I'll just show that in a second. Just carefully notice that it is using Azure Active Directory single sign-on to log into the workspace. That means it is fully integrated with Azure Active Directory, and we are using single sign-on to log in into Databricks. All right, so I'll just So once you do that, you will be reaching to in your Azure Databricks workspace. Now within the workspace, let's quickly look at what features are there, or in fact what what these tabs mean that you see on the left hand side. Now in the tabs, what you will see here, first you have got the option of compute. This is where you can create your clusters, and we'll go ahead and see how to set up the clusters. Then if we want to have the databases and tables, so we can have it here in the data section. Now what does this mean? What do we really have a relational database here? No, this is the Hive support, Hive, the Hive support which is available inside Databricks. So if you are new to Hive, we'll see a we'll get a basic idea what exactly Hive is doing, but this is the place where you can you can create your databases as well as tables. Remember, this is not like a relational database. The Hive database works in a different way. Then on top of it, we have got the repo. So if you want to connect to your source control, you can do that here. And then if you want to start, of course, if you want to create a jobs, you have the option here as well to set up the jobs environment. And then if you want to write the code, then you can come to the workspace section. And of course, the recents, it will show you all the recent notebooks which you have created. So let's first see that how we can set up the compute, which means how we can set up the our cluster here. So let me go to the compute option. And what I'm going to do, I already have one cluster which is running. So you can see that it's already running. Now let me just go ahead and create a cluster. So what I can do, I can provide a name of the cluster. Let's say this could be demo cluster 2. Then I can go and select something called as a Databricks runtime version. Now, what is this Databricks runtime version? Now, think about, so what you will do here is you can see there are lots of different versions which are available. Now, what is this? Databricks runtime version is something that is provided by Databricks, and basically it's nothing, but it's a set of libraries. So what you can do, let's say if you want to find out that what libraries will be installed when you used version number 8.4, you can go to the documentation and check it out. So some things are showing up right away here. So you can see here Scala version 2.12 and Spark version 3.1.2 will be installed if you will select Databricks runtime 8.4. But it's not just these two things. Obviously, there are libraries for Java, there are libraries for R, there are libraries for Python, and there are commonly used libraries which are also installed. So the language-based libraries, machine learning libraries, common libraries are also installed when you select the Databricks runtime version. So Databricks runtime is, it will allow us to define the libraries that we want to install. And you don't have to, you don't even have to worry that whether these libraries will be compatible with each other or not, because that is something that is automatically taken care by Databricks. So I can go ahead and select the Databricks runtime version. Then if then I can define how many, if I just disable the auto scaling, so I can even say, all right, I need 100 machines here. Once I go and define that, okay, to process my data, I need 100 worker machines. I can simply define it here. And then what will Databricks do? It will create these machines using Azure. So Azure will set up the machines. Then it will install the Spark on all the machines, as well as all the libraries which are defined by Databricks runtime. So everything, all the libraries, all the machines will be set up, Spark is installed, and all the libraries will be pre-installed. You can also go ahead and set up the auto scaling. So obviously, sometimes the load can vary. Let's say if it's a festive season going on, and you're processing, and let's say you are building an e-commerce solution and you are getting a lot of data during the festive season. So obviously, the load will increase. So that is where you can use the auto scaling option. Now, other thing what we can do is also say, terminate my cluster. Let's say if I set it to 30 minutes, so this would mean that my cluster will auto terminate if there is no activity going on. So straight away, I can save a lot of cost by setting up the terminations, by setting up the terminate option. So, if I, once we're doing let's say, after the session, I don't switch off the cluster and, there is no activity happening for 30 minutes, automatically the cluster will terminate. So that is how we can set up the properties of the cluster. So we have seen that provide a cluster name, set up the Databricks define the Databricks runtime version. That will help you, define the libraries you want to install. Then do you want to enable auto scaling? Do you want to how, when do you want to terminate your cluster if nobody is working with that, so you can save the cost. Then you can define the number of machines you want, and you can also define the size of the machines that you want. So you can have, this machine size is saying 4 cores and 14 GB of RAM. And of course you can go and select a bigger size machines, like machine with 112 GB RAM and 16 cores. So of course once you learn, I'm sure many of you must be working on Spark. So if you are using Spark, or let's say if you're not using Spark, then once you learn more about Spark, you can decide that what kind of cluster you want to go for. All right, so this is how we can set up the cluster, and I'll not do it here. Now you can see I already have a cluster which is running. Now let's see that how we can write the code. So now I can go to the workspace section, and for example, I can go ahead and create some folders here. So you can see I can create a notebook. Notebook is the place where we can write the code. We can create a folder and other stuff. So let's say if I want to create a notebook, I can define the notebook. Let's say azconf notebook. So whatever name you want to keep, you can keep it here and just create the notebook. Now then you can define that in what language you want to write the code. So this is going to be the default language for the notebook. Let's say Python, Scala, SQL, R. So you can decide on in which language do you want to write the code. Now once you define this language, then you can even select the cluster on which you want to run the code. So this is how you can easily go ahead and set up a notebook. Now once you set up the notebook, I'll just not do it here. Actually, it's a very simple thing. Now just clicked on create, and this is how my my notebook is ready. Now let me show you an existing notebook that we have that will help us create the ETL pipeline. So I'm going to take you to one of my notebooks. All right, so I have a notebook called ETL pipeline, and let's see what do we have here. So maybe I can just slightly increase the size here. Now see that what we are going to do. First, what we'll do, we'll explore the data in Data Lake. So I've got some files, and we'll see what is there in the file. So we'll explore the data in Data Lake. Very useful for data engineers, very useful for business analysts, as well as for the data scientist. So if you want to explore certain data in the Data Lake, you can do it here. Then what we'll do, we'll extract the data from Data Lake. Then we'll clean up and transform the data, and then we will load this data back to the data lake, the process data, as well as into Spark tables. And then at the end, we'll see how we can schedule this notebook as a job. So let's get started by, you can also do the documentation here. So within the notebook itself, I have added the documentation. I can even put up the full HTML content here. Now, once let's start getting to see that what is there in my data lake. Now what I'm going to do, I'll first take you to inside my Azure account. I have a inside Azure I have got a data lake account, and let me show you what do I have here. So you can see that I have got a raw folder. So this is my container, this is my data lake, and there I have got a folder called raw, and these are all the files present in this folder, the files in the folders. So this is present inside my raw folder. Now I can go and explore this data without coming here. I can explore this data within Databricks. So let's say I can I can say, okay, show me list all the files. So here I'm getting some command line utilities as well. So I can run this one and see what files are present in the data lake. So I'm just looking into the raw folder, and it will show us all the files in the folders which are available here. All right, so there we can see that all the files which which I showed you inside the Azure portal, here we can see that as well. Now what I want to do, I want to specifically focus on this file called Green Taxis 2019 11.csv. Okay, so let's go and look into this file. Now what I'll do, I don't know what exactly is present in the file. So let me go and use the head command. Now this is a typical Linux command I can use to see what is present in the file. So even if I have a 1 terabyte file, I can easily go and see that what is present in this file within just a matter of seconds. So it will read top few bytes from the file. So you can see that it has read 65,536 bytes from the file, and this is showing us that this is the first row where I can see all the column names, and there we have the data. So very quickly we have looked into the file and see what is present in the file. So now that we know that what is present in the file, it looks to me like a CSV file. Yes, it looks like a CSV file. So let's start to go and extract this data. So what I'll do here, I'm going to use a command called Spark dot read. So I'm going to read the data, and in what format? I'm going to read the data in CSV format. So I can read the data in CSV, Parquet, JSON. Lots of formats are supported, so we can read the data in any of these formats. Now this looks like a CSV file, so I'm going to provide the path of the file, and let me go and run this one. So I'm going ahead and reading the file, and this is a variable, data frame variable, where we are keeping, where we are creating all this and keeping all this instruction, and then I'm displaying the data in this data frame. So there you can see that we have got, this is what the data is there in the file. It is comma separated, and it does not look good. There is, the column names are not coming up properly. So what I can do now, this is the data set we are looking at. Now first we need to fix in the column names. So let me go and use an option. Again, same command, spark.read.csv, but here I'm providing an option saying header equal to true. So I'm just want that first row should become header and give me the names of the columns. So let me just go and run this one once again. And there we should be able to see that, yes, now it's showing the correct column names and we have the data coming up properly. Now, if I look at the schema of this particular data frame, I can see that every column is showing up as string. Now, obviously, there is something not right here because everything is coming as string. Since we are reading a CSV file, so actually, it's cannot determine that what is the data type of a column. So what I can do here within the Spark, I can start using another option, called infer schema to true. Now, this is something which is, you should not do that in production because you should not infer the schema of files in production. But just for the development sake, I want to infer the schema and see what is the data type of these columns. So once again, using the same command, I'll keep adding more and more stuff. Header equal to true, infer schema to true, and then I can, let's see if it can infer the schema properly. So remember that if you're trying to infer the schema, it is going to read the whole file and infer the schema for us. So that means if you have a 1 terabyte data in a file and you're trying to read that data, so it will read the whole 1 terabyte data and then show us that what are the data types here. So what you can see here is, let me just go and show you the schema. So now you can see that it is correctly showing us different data types, like vendor ID is integer. Then we have the pickup date time. So we are using the taxi data. So pickup date time is it's coming as string. Ideally, it should be timestamp, but maybe there is some data which is not correct. Then I can see rate code ID is integer, pickup location ID is integer, drop location is integer. So this way we have figured out the right data types for these columns. Now, once we have the right data types, now obviously, as I said, you should not do this in production. We should not do this in production. So let's go and define our own schema. So what I'm going to do here, I'm going to define the schema. Now, if you look at, if you're working on ETL tools like SSIS or Informatica, you'll find that we are doing some very similar stuff. We are reading the data, we are defining the data types, that what data we are reading. So this is all part of the extraction process. So here I'm manually going ahead and defining the schema. Let's run this one. So, if I haven't shown you how to run this command, so we can run these commands one by one, and there we can just use the option of run cell. You can click on this and run it, or I can use the shortcut which I'm using right now called shift plus enter. So when I do shift plus enter, it actually runs this particular cell. So we are running it cell by cell, and that is how we work with the notebooks. Okay, now that we have defined the schema, instead of doing infer schema, now see here, I'm just changing the command. Again, spark.read, option header equal to true, and we are saying I want to read in the CSV format from this location. But then now I am defining the schema here, which is the variable that we created previously. So if you look at in the previous step, we are saying green taxi schema. The same thing I'm putting up here saying schema, green taxi schema. So this means that now we are manually applying the schema. Now, if there is any record in the file which is not according to the schema, obviously the job will fail. So, but you can see here, it has been able to read the data properly. It was not able to identify that it's a timestamp, but when I explicitly mentioned that the pickup date time is a timestamp, it was able to parse that information. So that is how now we have the right data types and we have applied the schema as well. So step one, we have completely extracted the data. Now, what else we can do? I can also go, as in first, I would like to analyze this data. So what I can do on the same, the variable that we have, the data frame variable, I'm going to use the describe command, and I want to see that what is there in passenger count column and what is there in the trip distance column. So what it is doing, it is analyzing the whole data set and telling me that, okay, there is what is the count of records in these columns, what is the mean, what is standard deviation, what is the minimum value, what is the maximum value. So using this information, I can find out that whether there is any problem in the data set. So this can be first level of analysis of the data. I can see the passenger count is minimum is 0. Now this looks pretty strange. How can a cab ride start with with the passenger count as 0? And how can a cab ride go with maximum count as 9? So obviously, if you, this is basically New York City taxi data, where having 9 passengers is not allowed, but still I can see that 9 passengers are are traveling in a cab. So maybe we can go deeper and analyze this data. And I can see a very interesting thing. The trip distance is showing in negative. So maybe there is some data corruption or data has not been properly added into the system. So using this kind of information, I can analyze not just these 2 columns, but obviously all the columns in my data set. I can analyze and look for their minimum, maximum values, count, mean, standard deviation, all these things we can analyze. Now that we have analyzed the data, let's start to clean up the data. So what I want to do, I want to filter out the records. So I'm going to use, now let's focus on this part. So what I'm going to do, I'm going to say on my data frame, filter the records where passenger count is greater than 0. So I don't want any records where passenger count is equal to 0. I want to filter that data. Obviously, it depends on the business requirement, but just for the demo purpose, I want to filter the records where passenger count is equal to 0. So I'm removing those records. Then I can also filter where trip distance is less than 0. I just want to filter those records. So this is how on my data frame. So just like in your SSIS packages, in Informatica packages, you go and filter the data. In the same way, I can filter the data here as well. So along with this, I'm going to print the number of records so that we can see that how many records we have filtered out. So you can see here that out of 4.4, I think this is, so 449K records, now we are left with 349K records. So 100K records have been removed based on these 2 filters. Now, in the same way, I can go and do other cleaning operations. For example, I can remove the records where any value is null. So in fact, any row which is null, I want to remove those records. So what I'm doing, I'm running this command to filter all the records where the rows are none. So again, we are doing another cleanup operation to remove the null records or completely records which are completely null here. So you can see there was no null records. Actually, I'll tell you, this is all the live data which is available on, which is an open data set. There is not something I have created. I'm picking up the data. So we can see that, we have some incorrect data. So we have filtered that out and there were no duplicate records. Now let's go and do some more stuff. What I can do here, if there are any missing values, for example, obviously there can be null records as well or null values as well in the columns. So for example, if the payment type value is null in a record, I can go and replace it with 5. If the rate code ID value is null, I can replace it with 1. So again, maybe you may not be able to see all the code here right away, but the point is that what the Azure Databricks can do, it can help us do cleaning of the data, it can help us in analyzing the data and perform multiple transformations. So what we are doing, we are on the data frame, we are using na.fill method to replace the missing values. So let me go and run this one as well. And in the same way, if I want to remove the duplicate records, I can use the drop duplicate methods to remove the duplicate records here. Now, let me just use another where clause. I'll just quickly run this one. So we can see the transformation functions as well. So here we are filtering certain records where the dates are not within the range. So if the date is not within November 2019, if it is not within November 2019, I want to filter those records. So this is how we just went ahead and cleaned up our data set. Now that I'll just skip through this one. Now that we have cleaned up the data set, let's apply certain transformations to it. So how can we apply the transformation? Just like, again, if you are using any of the ETL tools, you go ahead and let's say, I'm sure you go ahead and rename the columns. Okay, so in the same way, I can rename the columns here by using select method. I cannot just rename, but I can, if I want, let's say just like you write select star statement in a SQL, and now instead of select star, you want to extract only few columns. So instead of extracting, I think there are close to, it's double the number of columns which are there, but I'm reducing the data set to certain columns only. So I can only mention the column names which I want here, and I can even go ahead and rename them. So renaming the operations, selecting certain limited columns, all these things we can define it in the pipeline. So you can see here now my data set has been reduced to these columns only. Now, once I have this column, or once I have these columns, I can go and create derived columns. So if you want to, for example, on the data frame, if you want to set up a derived column, so I'm using a function called with column. So this will create a derived column for us. So once I'll tell you, once you start writing the code, if you're using it for the first time, if you start writing the code in in Spark, it may look a bit difficult at the first point, but once you start writing it within a few days, you'll be very comfortable, and this could be much more powerful, and you very quickly you can write this kind of code and set up your can complete your work. Now what you are doing here is we are using the with column method, which will help us create a derived column. So this is the name of the derived column, and we are writing a formula for creating the derived column. So we can use the expressions to build up our derived columns. Let me go and execute this as well. And there you will be able to see that if I open up my data frame, I have got a new column now called trip time in minutes. So we are taking the start time, we are taking the end time, and after subtraction, we are getting the trip time in total number of minutes. All right, now that we are going ahead and doing more and more transformation. Now, once again, if you want to create another derived column, so you can see I'm creating a derived column called trip type, and I'm applying the if else statement. So if the rate code ID value is equal to 6, that should be called as a shared trip. Otherwise, it should be called as a solo trip. So again, we are creating more derived columns by applying the if else conditions. So we are creating the derived columns by applying an expression. We are creating the derived columns by applying if else conditions as well. Right now, let's say in the same way, I can create more derived columns by using formulas. For example, now we have a column called pickup time, and from the pickup time, I want to extract the year value. From the pickup time, I want to extract the month value, and from the pickup time, I want to extract the day of month value. So I'm creating 3 new derived columns called trip year, trip month, and trip day. That will give us the data for month, year, month, and day. And let me just show you. So if I run this particular, if I displace this data, we can see that what is present. I will show you these columns. And at the end, you can see trip year, trip month, and trip date. So from the date time column, we have extracted these values as well. So very, very typical of an ETL pipeline. Whatever you do with any other tool, you can do that in Spark as well. And of course, we have the Databricks platform. So very easy to write the code, very easy to manage the clusters. Now, we can also go and perform group bys. So I'll just skip through this part. In fact, let me just run at least this one. So we can do the group bys. We can, perform the aggregation. So all these things we can perform here. Now, the other interesting aspect is we can see that this is the data set that I have. I can immediately convert this data set into a chart as well. So for example, I can just go to this option, and you'll see this, there is an option of charting. So I can just click on this, immediately convert that into a chart. Obviously, there are more charts options which are available, and you can use any of these charts. If you want to set up the plotting options, so let's click on that, and you can define that, okay, what do you want in the keys? What do you want in the values? So I can go and use the trip day column as well and remove this one. So this is how I can easily set up my charts. Now, once I have transformed all the data, now comes the final thing that I want to load the data into. I want to load this process data back to my data lake. So again, I'll just skip through these couple of things where, again, you can perform the joins as well. So perform the joins, inner join, outer join, full outer joins, cross joins, all kinds of joins you can perform here inside Spark. Now, let's say I want to work with, in fact, I want to write this data back to data lake. So what I can do, I can again use the same data frame. So where we have applied a lot of operations, I can use this data frame, and I can use the command called write. So data frame dot write. I want to write it. And where do I want to write it? I want to write it in CSV format. So first, take the data frame, use a write operation, and I want to write it as a CSV format into this location. So I just need to define this, that where I want to write the data. So I can define it here. And again, I can define more options like header should be true. You should add a header in the CSV file. This should be the date format. So we are defining the date format here. And I want to override the existing data set, or I want to override the existing files. So this will go and take my data and write it into this particular location in CSV format by using these options, and it will override the existing files. So that is how I can go ahead and write the output back to my data lake. So we extracted some data. It had a lot of problems. We cleaned up the data. We analyzed the data. We looked into what is there in the data set. Then we started cleaning up. So we applied, we filled up the missing values. We removed the empty rows. We went ahead and applied the where clauses to remove the incorrect data set data. And once our data set was cleaned, then we applied the transformations. So there we can do joins, we can do group bys, we can sort the data, we can also, we can create derived columns. So all these things we can do within the Spark. So you can see within a very short period of time, we have completely extracted and analyzed and cleaned the data as well. Now we have loaded this data back to data lake. So if I go into my data lake, I can refresh here. Let's first see what is the path. So it should be facts folder and green taxi fact.csv. So you can see here it should show, okay, not in the raw folder, but here you can see the facts folder. And in the facts folder, I can have green taxi fact.csv where my data has been written out. So even if you have terabytes of data to process, you can easily go ahead and do that in Spark. With the same code, no code changes, you can go ahead and do that in Spark. Now that we have written it back to data lake, there are two more things which I would like to show you. Now the same data frame which contains the data, I want to write it as a table inside Spark. So what I'll do, I can also go and create a database. So you can see that within my Python notebook, I'm actually running a SQL command. So in the same notebook, I can write, the SQL commands as well. So let me go and create a database here called Taxi Service Warehouse. And if I go into my data tab, I'll show that to you in a second. So if I go to the data tab, you should be able to see this database as well. And then I'm taking my data frame and I'm writing it, but this time I don't want to write it as a CSV file in a data lake. I want to write this data as a table inside Spark database. So here I'm going to save this data frame as a Spark table. So Taxi Service Warehouse is the name of the database, and this is going to be the name of my table. So it's just going ahead and writing the data, and then I'll show you that how we can access this data. All right, so here we are almost done by writing the data, and let's see that in a second. Let's go to the data tab, and there you should be able to see the Taxi Service Warehouse, and there we have the table which has been written out. Now the tables are created. Now I can start writing SQL queries on top of it. So I can, once again, I'm running the SQL command in the Python notebook, and I'm saying select star from Taxi Service Warehouse fact green taxi trips. So very typical SQL queries. You can do group bys, where, joins, everything that you want to do, you can do it here in SQL language. Remember, in Spark, we can run SQL, Python, Scala, R, and Java. So here we are running we are running now a SQL command on our tables. So you can see now all the data is coming up. And if I want, I can, just apply the filter commands like where passenger count is equal to 1. So whatever conditions you want to apply, you can apply it here. Now, final thing, that now that we have created the table, now what else I can do? Obviously, I would want to make it production ready. So what I can do here, I can go to this option of jobs, and now I can schedule this notebook. So what I can do, I can create a job here, and then I can define that I want to, this is my daily pipeline. So I can write something like this, or let's say this is my daily pipeline. Let's define it here. And I want to run, let's say, my ETL, or let's say, taxi job. So I can go ahead and define the task name here, select the notebook which I want to execute. And there I can go to my notebook, select the notebook, and I'm defining the notebook that I want to run every day, or maybe for whatever time frame I want, and then I can go and select the cluster on which I want to run this notebook. That's it. This is how I can create my pipeline, and of course I can define the schedule as well. All right, so this is the this is the stuff that we can do inside Databricks. So you have what we have seen so far. We can set up our clusters, we can set up our notebooks, we can write our code, and we can schedule the jobs as well. So of course you can define the schedule here. And one thing maybe we can, which I would like to show very, very briefly, is that you can also go ahead and set up dashboards. So we may not have the time to look at the dashboards, but you can also go ahead and set up the dashboards. So whatever data sets that you have, if you want to build up the dashboards for that, you can also do it. And once you click on refresh, it will refresh all the data by running the notebook. So that's all we can do inside. In fact, not all, but this is for now, this is all we can do inside Databricks. So we have seen that how we can build this pipeline, and I think that's all we have in today's session. So thank you so much for joining in, and I hope you enjoyed the session. Thank you to all the partners and to the team for bringing up this great conference with a lot of people around. I hope you're having a good time here, and wish you all the best. And we'll catch up in some other session as well. Thank you and have a wonderful day. Shri, back to you.
Hi, Mohit. Thanks for a great session.
Thank you.
Let's
Shri.
wait for a few minutes for questions. If there aren't any
Sure.
questions, you can connect. Maybe anyone can connect with Mohit offline.
Let's see if there are any questions. So I'll just bring up my LinkedIn profile. If anybody is interested, feel free. I'll be more than happy to connect with you guys. Okay, I think Shri, that's all. I don't see any
Okay,
any
Mohit,
questions
I don't
here.
think there's any questions. Thanks for the session, Mohit.
Yeah. Yeah. Thank you so much.
It was a great session.
Yeah, thank
you
you
so much.
Yeah. Bye-bye.
Hello, everyone. Thanks for joining. The next session is going to be by Michael. It is on keeping your secrets safe using Azure Key Vault. Hi, Michael. Can you hear me?
Yes, I can hear you. Thanks.
Okay.
Good morning to you.
Okay, so please feel free to post all your questions to Michael on the chat window, and there will be a feedback URL shared. Please provide your session feedback on the URL. Thanks, Michael. The stage is yours.
Good morning, guys.
Well, thanks everybody. First of all, of course, thanks to all the sponsors to making this event possible. It's a delight to be able to speak to you today. My name is Michael Hompes. I'm an IT architect and a chapter lead at InfoSport in the Netherlands. I'm also a Microsoft MVP specialized in Azure, so that's quite fitting for this conference. Have questions, like just has been said, put them in the chat, or otherwise later on you can reach out to me on Twitter, on GitHub. If you think about something later on, just contact me and I'd like to help you, and maybe we can discuss some interesting things around Key Vault. So my session is about keeping your secrets safe and why you could use Azure Key Vault in your situation. For the session, we only have a lightning talk, so it's very limited in time, so I won't be doing many demos, but I'm going to show code, I'm going to show configuration, showing you some screenshots. So at least you get an impression and you can replicate things later on if you like. I'll start with an introduction about what is Azure Key Vault, and some interesting terminology that's being used and which can be very relevant for your situation. So if you're very new to Azure Key Vault, then at least you know what we're dealing with. If you already know what Azure Key Vault is, it might be some additional details you might not know about Azure Key Vault, so we will be going through them first. And then we will go into some of the concepts of Azure Key Vault. Also here, if you're new, it will be a good introduction. If you're already using Azure Key Vault, most of the concepts might already be familiar with you, but also here, Azure Key Vault has been around for a long time now, at least 5 years. And also new things have been introduced over the years. And then I want to look at all the scenarios we have, where we can use Azure Key Vault and what we can do with it. So that will be the remainder of this session. So what is Azure Key Vault? Well, I'm starting with some quotes from certain parts of documentation, and I'll also be using some quotes from Wikipedia. So for this, I'm a little bit reading what's on the screen. Azure Key Vault is a cloud service for securely storing and accessing secrets. So what are secrets? The secret is anything you want to make sure not everybody gets access to. Think about API keys, passwords, connection strings, certificates, or even keys. So that's the basic premise of the service. And how it works is like many Azure services, it's a multi-tenant service. So that means it's not something which is only running for you. You share it with everybody else running in Azure. And it runs on a pool of hardware security modules. And I'll dive a little bit more into those in a moment. And those modules are geographically shared within the same boundary. And this might be already familiar if you are working with the zones like North Europe and West Europe. They are together a geography, but also all the zones in India are sharing the same geography. So if you use Azure Key Vault inside one of those regions, they can back up, restore, fill over within those regions without you encountering downtime. So hardware security modules. A hardware security module is a physical device which safeguards digital keys, but also can perform encryption and decryption. It can verify and sign, execute authentication and other things you do with cryptography. So this is not your run-of-the-mill VM or PC equipment you have at home. This is quite tailored for specific means. And HSMs have features to provide temper evidence. So if somebody starts messing with the software or the hardware, at least it will be logged and it can be alerted about, or even be tamper resistant, so making it hard to corrupt the data, and also responsive. So if I would remove the lid of this device, it would wipe out everything that's stored on it so that nobody can access whatever stored on these devices. So very specific equipment. And in Azure, Key Vault uses specific Encipher HSMs, which are FIPS standard 140-2 level 2 validated. So when you're working with Key Vault, or at least reading up on Key Vault, you will find often references to FIPS 140-2 and certain levels. So for now, I also want to explain a little bit more about it because it might be relevant for your field. So FIPS itself stands for the Federal Information Processing Standard, and that's something governed by the US government, and they describe how you can validate equipment dealing with cryptographic modules. And you can get certified if you meet certain specifications. And currently, or basically until last month, FIPS 140-2 was the standard. There is also now a -3 standard. Basically, from last month on, new equipment can't be validated against this standard anymore. So I expect in the future that Azure also will be starting to report that they are meeting the 140-3 standard. But for now, we are stuck with the -2. And within that standard, there are 4 levels of security. So level 1 basically says your software uses state-of-the-art cryptographic algorithms, but it doesn't say anything about how secure your operating system is or the equipment you're running on. So this is basically just you use secure software. Level 2 already adds some role-based authentication, at least logging if the system is tampered with. So a key might be stolen, and you know it's stolen, but it doesn't prevent it from becoming stolen. So level 3 already starts with the physical part of the system. So can I access the device, and can the device wipe itself when it detects that somebody's trying to mess with it? And these 3 levels we'll be seeing when we are talking about Azure Key Vault. It might be as a financial institution, you have even more requirements, and then level 4 can come into play. And that's, for example, actual physical resistance to tampering, but also being resistant against temperature failure or cooling failures in your data center. This is not something that's available in Azure. So what is Azure Key Vault or Microsoft offering? Well, we have the standard edition. To be honest, for most of the people, most normal usage of storing secrets, I think this will be good enough for you. It's multi-tenant, so you share it with other customers of Azure. It only provides software protected keys, but they are protected using encryption with a key that is stored in an HSM. So basically, you are meeting level 1. If you really require your keys to be in the stored inside the HSM itself, then you can use the premium version, which adds that additional value. And if you really need to meet level 3, then we can now choose managed HSMs. Then you get a single tenant dedicated pools of HSMs. So they are not shared, the infrastructure is not shared with other customers in Azure. They are specific, only reserved for your usage. Of course, this is more expensive, but also one of the benefits is that the equipment is validated an additional layer, and they are meeting level 3. So if that's really a requirement for your company, then managed HSMs are the solution for you. So to illustrate it a little bit more, if you have a key vault, you access it via the API, you can store secret certificates and keys. With a standard edition, that will be all stored in normal storage, but using encryption. That encryption key is stored in the HSM itself. And if you want to store your own keys in the HSM, then you need a premium edition. So let's look a little bit more in the concepts, because I used some terms and we dive a little bit more further into them. So the API, like every Azure service, you can manage and access the data in Azure Key Vault using APIs. For management, you can do that using the portal, PowerShell's Azure CLI, ARM templates, Bicep, or just REST interface, like usual. If you want to access secrets, that can also be done using the REST API of Azure Key Vault, and that's fairly straightforward. I want to get from a certain vault a secret with a certain name. Secrets can be versioned, so I can also specify a certain version. And I also can execute post commands. For example, I can create a certificate with a certain name in a certain vault. To make it easier and not to have to write all those raw REST commands yourself, there are SDKs available for .NET, Python, Java, and for Node.js. So secrets. Secrets are basically the base object of Azure Key Vault, and it can be anything like a password, a database connection string, but you could also put an image, PNG in a secret, whatever you think is valuable to keep secret. In the end, you post it as a string, and it's stored as byte data, and there's a limit of 25 kilobytes. But because you can put anything in that string, you can optionally also provide a content type. So if you put in a JSON, you can set that as a content type. You can set it as plain text, at least so when you retrieve the data, you get that content type back, and you might know how to deserialize that data. Like I already mentioned, all secrets in your Key Vault are stored encrypted. So even though you provide them plain text, they will always be encrypted. This will be done transparently for you, so you don't have to call any encrypt or decrypt commands or do those things. That will all be handled for you. And that encryption key is unique for every Key Vault instance. So even though you would get, somebody could get access to that raw data, they could not decrypt it in another vault other than your own vault. Additionally to your secret, you can optionally specify not before time, an expiration time, and an enable true false field. This is a little bit more so you can manage keys. You can set an expiration date time for a certain value and a not before time for another value with the same key. And that would mean that until that time passes, you would get a certain version of the value. And after the time has passed, you get a new version. So you can plan, for example, a different password getting into effect tomorrow. But you can already store it in the Key Vault, and every application accessing the secret today will get the current value. And when we will access that value tomorrow, they will get a new value. So the basic operations you can do on a secret is just setting a value, getting them, listing them, and more management like backup, recover, restore. So keys. Keys are the things you might know from PFX files, from PAM files. Those are the ones that most of the time are the private part of a key value pair, or a key for asymmetrically encrypting and decrypting. So the key part is storing and managing cryptographic keys. And they are stored in the JSON WebKey format if you're interested in that part. And just like I show you with secrets, like getting them, listing them, you can also create a key, update a key, and import a key. And because they are keys, you can have specific cryptographic operations with them. So you can use a key stored in Azure Key Vault to encrypt, decrypt data, wrap a key, unwrap a key, or sign and verify a hash value. And the third part, which is common to use with Azure Key Vault, are certificates. So that's really about the X509 certificate, so the TLS certificate or other things where you can use certificates for. And basically, Azure Key Vault acts as a key certificate store, and it can help you managing the lifecycle of certificates. So for example, you can renew certificates automatically using integrated CAs. And there are only two at the moment available, and that's DigiCert and Global Sign. And those certificates are CAs. They're not the cheapest ones, but you can use it to automatically have renew your TLS certificate, for example. Of course, these days, most of the people will probably use Let's Encrypt, but this was already available long before Let's Encrypt was big. But you can also renew certificates using other CAs, but in that case, you will get a CSR file, which you can then move or transport to a CA, sign it, and import the certificate in Azure Key Vault again. Also, like the basic secret operations, you can create, update, and import certificates. And you have some specific operations like manage contacts, because when a certificate is expiring, it can signal the contacts to let them know the certificate is expiring. And of course, you can manage the certificate authorities when you want. Like I said, you can use notifications. One of the nice things that has been introduced over time is event grid integration. So when a secret is about to expire, so 30 days before, or when the secret actually has expired, or when a new version is available, those 3 moments in time can generate an event that can be used by event grid. So for example, you can have a Slack channel, and 30 days before your certificate is expiring, you will get a post in your Slack channel using Event Grid. So that can be very helpful. Even if you don't integrate your Key Vault with anything else, at least you can use it to keep track of expiring certificates within your organization. One thing we also need to mention is that in contrast to many of the other Azure services, Azure Key Vault has 2 management planes, or two planes of managing authentication and access control. So first we have the management plane. So that's really about who can manage Key Vault itself, assign policies, change properties of the Azure Key Vault. And this uses the normal Azure role-based access control, or RBAC. But we also have the data plane, and that's really like who can access the keys. So even I could manage the Key Vault, it can be that I'm not allowed to read the values stored in the vault itself. Or the other way around, I can read maybe from the vault, but I can't manage anything else about the vault. So the data plane is really like getting values, storing certificates, things like that. Up until recently, that was a complete separate way of doing that, so the vault access policies. But recently, it's also possible to switch to role-based access control as well. You can't have both, it's one or the other. But RBAC for the data plane is a fairly recent introduction. So how would it look like if I compare it to the old days, I hope? Let's say I'm a developer and I have a web application that needs to access a database. Well, how do I do that normally? I would store the connection string with the web application, and the web application can access the database. But that means that the developer knows which the connection string or the connection string is somewhere plain text available in the web app server. So maybe I want to separate those two worlds, and I want to introduce key vault as a secret store. So what I would do is store the connection string in key vault, but then the web app needs to know to retrieve my connection string. So for that, I need to be able to identify my web application as someone who can access my vault. So for this, I need a proof of identity. That can be a username password, but that's not what we want, why we introduce a key vault, of course. So that can be a certificate, or in Azure, a managed identity, but something that proves the identity of that web application. Using that approval, I can configure the key vault that they are allowed to retrieve that key, and then the web application can access the database. For one of the benefits is that we can create multiple vaults for multiple environments. So for example, for the development environment, I have a key vault, and the web app in the development environment can access it. So the developer might know the identity, might know where the vault is. But as an admin, when I'm using infrastructure as code, for example, I don't want the developer to know anything about the production environment. So the admin can roll out the same environment, but with a different key vault, with a different identity, and keeping those environments really separated. So no configuration settings from production in the dev environment, and no accidental using dev connection strings in the production environment, for example. So the developer knows everything about the development environment, but doesn't know anything about the production environment. So, for example, the developer now makes a mistake and puts the production key vault URL in the web app. Not on purpose, just by accident, but that would mean that the web app would get the connection string from the production database. So for that, because they are now different vaults, they use different identities, and therefore this would not be possible. We would get a access denied when the identity of the web app in the dev environment would try to access the production environment. So some of the best practices is really use multiple vaults. Don't try to use a single key vault. Use as many as possible to have separation of concerns. This also would reduce the risk if, or what we call the blast radius, if somebody would get hold of access to a key vault, because then they only could get access to the key stored in that vault. And if they would get access to the dev key vault, they would only be able to read those secrets, and all the other environments or all the other applications would be shielded from that compromise situation. And from a cost perspective, it doesn't matter, because reading two values from a single vault or reading two values from two different vaults is just as expensive. So really, not cost should not be a reason to not separate your concerns. And of course, if you are using Azure-based services, try to use managed identities. Not every situation can use managed identities, so you can also use Azure AD to use username, password, or certificate, or other auth flows to access or get an identity to access key vault. But if you're working with Azure-based services like app services, try to use managed identities. Okay, so that was a lot of the theory. Let's look at some scenarios. First, of course, we have the Azure Resource Manager, where we can create and manage key vaults, add and update secrets, and use secrets as parameters and templates. So the first two might be very obvious. The third one, I think, is much lesser known. Also, not everything we can do with Resource Manager is available in the portal. So, for example, we are going to see storage access policies and SAS templates. You won't find them in the portal, even if you have created them in your Azure Key Vault. There's just no UI for it. So Azure Key Vault can do more than you see in the portal. So first of all, a simple ARM template like we have known for years now. I can create a vault. I have to provide a family, so for standard edition in this case. And I have to, or at least up to very recently, I also had to was required to add the access policies immediately. And you have to provide a tenant because you're adding policies against the Azure AD. And then you can set permissions like all permissions for keys and secrets. I also can use Azure templates to insert secrets. So in this case, I have just a plain text value, or maybe I can put in a whole private key or a PFX file in this case. A little bit more advanced scenario is when I want to use other services. So for example, I can create a secret that uses string concatenation to build a complete access connection string to a storage service. Well, here you really see the downside of using ARM templates because this is not very readable, but the benefit is that this creation of this connection string is happening in the Azure Resource Manager. So it never leaves Azure itself. So at least it's very secure to do it this way. And one lesser known option is that if you have an ARM template and you put in a property, in this case, or a parameter, in this case password of the type secure string, I can create a parameter file where I say, hey, password, but instead of providing a value, I can say it's referencing a certain key vault with a certain secret name. So when I deploy this template with this parameter file, the resource manager would go and access this key vault and would retrieve the secret with the name password and use it as a parameter. Also here, I won't be storing anything in my source control system or have to provide it manually during deployment. The resource manager can deal with this for us. So shielding us from using the actual values. With Bicep, other than making your code much more readable than the JSON versions, we can also separate the access policies. So that makes it easier if you want to separate adding and changing your administrators from managing and changing properties on your key vault. So that's at least already a big improvement. If we look at adding secrets, basically the same as we did with the ARM templates. I think that the string concatenation and referencing of properties of other Azure services is at least much more readable, but technically it's just the same. Reading from a key vault is really very easy. Just use the NuGet package, Azure Security Key Vault Secret, and you can create a client. You can authenticate, but if you use a managed identity, for example, you can just use a default Azure credential, and then it's just very easy to set a secret to get the secret. You can also use, at least for ASP.NET, but I think you can also use it for command line applications. You can use the configuration provider for Azure Key Vault. This is using the Visual Wizard. You can add Azure Key Vault as a connected service. And then you can just choose your key vault, and then all the values in that vault will be available as configuration values in your application. And this is automatically.
Hi, Mikkel. Sorry to interrupt. I have only 2 minutes left. Sorry to interrupt.
Like I said, for app service domains, you can renew your certificates automatically. So I won't dive much into that, but at least it's an easy feature if you don't want to have the hassle of managing your certificates. And the last one interesting feature is also you can have certificates automatically injected into your virtual machine. So you manage keys of Key Vault as a certificate store, and the virtual machine extension will automatically import those certificates when they change. This is not available for every operating system. Also, Azure DevOps has a task you can import certificates, both in the visual version and in the YAML notation. But another hidden feature that most people might not know is the variable groups. In a variable group, you can link with Azure Key Vault, and you can then specify your vault and also choose which variables will all automatically be imported into your pipeline. So you can link a variable group, choose where it's available, and also here both for the visual and for the YAML version. Disk encryption, not for every operating system available, but just good to know. If you have a file on your data drive with super secret data, this is just plain text. So if anybody gets a hold of your disk, they can just read it from disk. If you use disk encryption, then the keys are stored in Azure Key Vault, and your disk is no longer easily read by anybody else. So
Hi, Michael. I request you to complete the session, please. The next session needs to be started. So there's one question. Probably you can take that offline. I'll just show you the question. What is the difference between a standard and premium tier is the question. Probably you can take that offline since time.
Okay.
Thanks for a great session.
You're welcome. And so if you want more references, just make a screenshot of the screen, because that's all the data I have provided. And then I want to thank you, everybody, for attending this session.
Thank you, Michael. Thank you so much.
You're welcome.
Hi, Marco.
Hello. Can you hear me?
Hi, can you hear me? Yes. Loud and clear. Thank you.
Perfect.
Thanks for waiting. Hi, everyone. The next session is going to be by Marco. It is on Azure IoT Central. Thanks for waiting. Marco, the stage is all yours. You can take it forward.
Okay, I can start. Okay. So thank you everyone. Thanks for having me in this session. Thanks to the organizer. Thanks to the sponsors that makes these events possible. So my name is Marco Parenzan. I come from Italy. If you think I live in the northeast of Italy, Pordenone, that is near Venice. If you like Venice, probably you know where I live. I am a senior solution architect in BayanTech, that is a company that works in many fields. One of these is IoT. I am an Azure MVP, and I have a community in Pordenone where we perform this also. Not that big, but lovely session and events like this. Here you have my LinkedIn reference. So if you want to contact me after this session, so no problem. Here the information go next. So I want to speak you about Azure IoT Central, and we have to speak about in 30 or less minutes. It is possible, yes, if we speak about why Azure IoT Central is an interesting service from Azure and all the IoT space, and if we explain why Azure IoT Central is not a toy, because this is a misconception that many people has. Me too, we can say, because before getting deeper inside Azure IoT Central, you can consider, I admit, you can consider IoT Central just a toy. Well, it's not. It's far more interesting. It's a very, very interesting service, and I show you. So the starting point is that the reality of IoT, it's the only business slide I have, is that a lot of projects, and now that I live in a company that makes these IoT projects, does not move beyond the concept due to complexity, high cost, lack of staff, concern, security. You can say everything that goes around the IoT space. IoT projects are very big, and or at least they're not big on the focus, because you focus on the device, ingest the data, process data, and so on. Well, IoT is a lot more about all around this particular scenario, and that's the field where IoT Central perform. If you think what is scaring about an Azure IoT solution, think that this is an IoT solution made, well, not, it's just a map with all the services that can be involved inside an IoT solution. And I admit it can be very scary because you have a lot of services that you have to adopt. So many services that you are hearing about in this great event. So not only the resources you have to use, we are not speaking about money, but all the pieces that you have to use, and how to connect all these services. Well, IoT Central is not a toy because it can overlap on some of these on these services, and we can say that substantially IoT Central cover all these services. Probably I have made more, it's not precise, because I can say that all these services that are under here, you need also this. But if you want to start, you just need only with IoT Central, and you have to concentrate yourself on your device, because the service is about devices, or about the data that the devices allow you to collect to be consumed. Look at the right side. You can consume inside your business application. That can be an ERP or anything you want to create. So this is the value of IoT Central. Simplify the starting from this kind of service. The misconception is that it's not only starting, but you can, with some, we can say, parameters, sizing, it can be a definitive solution for you. So why IoT Central is interesting is not a toy. It's a fully compliant with Azure IoT platform. So behind IoT Central, there is IoT Hub, there is IoT device provisioning, you build your IoT device that is exactly the same device. It has an interesting pricing model, and we look at the next in the next slide, because it has a device, per device, not per message pricing. This is very interesting because device is more similar to a licensing model of what you deploy, not what you consume, that is the message. It's another interesting thing that lacks, we can say, out of the box from IoT Hub is the terms of modeling. That means which concept your device represents that is implemented in your device, but which are the information separated from how do you implement in your specific device. So this is good because it gives you a fast start, because not only the device but also the scenario. With IoT Central, you have a lot of scenarios that are out of the box ready. You can build up and set up IoT Central for a specific scenario. That is very, very interesting. But obviously, it's also extensible. And we can also say that as the template, as the modeling represent the experience that Microsoft gives us on how to set up Central, is we can say that is the experience of many people that has worked on IoT solution, and now they are inside these templates. So when you adopt these templates, you start with a real world infrastructure, and this is very good. It's extensible in the same way IoT Hub device provisioning you can extend, so you can add services in the same way. This is great. And issue, I have already told how an IoT solution should be. One interesting concept about business is the OEM notion. That means the open equipment manufacturer. Why IoT Central can be great? Can be great because a company that makes a device for our companies. So think about, there is a tree, there is a hierarchy about organization. That means a company that sell, a company that and produce, a company that apply the device. You can be at the middle. You can have a company that apply the manufacturer to the customer, so you can have a hierarchy of people that is typical of OEM business. And IoT Central is a good place, starting point place where to start this business. So OEMs, I already told, open equipment manufacturers. It means a couple of things. They create devices for someone else in a product manner. The business is repeatable. So think that if you need an IoT solution to collect the data for the customer, you need to repeat that portal, that application many times. And you work exactly through directly or through a partner. So you need an application where every role can make very specific task. And this point triggered me to make this session, because this is something that changed recently, and this is why many people I have talked to left out IoT Central, because a single application was not repeatable in a more simple way to adopt to many customers to manage Central in a standard way. So this is something that allow lowering the barrier to adopt IoT. And I think not only medium companies, but also very small companies that, for example, they are typical here in Italy. And everything, when you speak about OEM, you are speaking about servitization, that makes it, that creating a solution that allow you to sell not selling your device, but being paid by usage. So let's look into specific topics that for me are very interesting for you to adopt IoT Central. First, I already told, device management. First, it enforces you to use modeling. The modeling is done through the device twin and plug and play templates. That is the definition language, that is a specification, and we'll look in the demo session how it is built. You are forced to use device provisioning service. That means you sell a device, it is not connected to any endpoint, just to the provisioning service. When you deploy remotely anywhere in the world, you connect and it receives his identity at the time of installation, not at the time when you deliver. And this is great to manage the licensing model of your solution. The fact that you have templates and you describe the device allow you to manage versioning. That means you can update your device. There will be a variable, a configuration, more feature, and you can version this and you can manage the versioning of these templates. And when you have dashboard, at least a machine has their KPI, has their value, and you have a dashboard for your specific device out of the box. The pricing model. The pricing, I told you, IoT Hub is sold by messaging. Remember, we are not speaking about the pricing. The price is low for this kind of service. Think that IoT Hub S1 tier costs €21, $25 per month for 400 key messages per day. What is bad with that? That is difficult for you to estimate and to discuss with your customer how many messages. You think, I sell you and I implement to you 1, 2, 10, 100 devices. And so IoT Central have this pricing. A price for each device you deploy, for each identity of a device you deploy. Each device has its own message pool. This is great, because things that for about half enough euro of 60 cents, you have 300 messages per month. That is quite low, because 30,000 messages per month can be quite a lot for a device. Don't think that they are not much, because it is not typical to have one message per second, but you can have for one message for every 30 seconds, one message every minute. This is a real world scenario. Also, obviously, it depends on the process you are applying this. Another thing that is interesting is that you have a specific API to many aspects of IoT Central. So you have out-of-the-box application, but you have API to use this. This is probably the most specific part of it, IoT Central. But if you use the right patterns inside your code, you can use the code. And when you grow, because, for example, you substitute the IoT Central with IoT Hub, you can only rewrite only the simple part, where obviously when you implement or adopt any other tool, but only the adaptation layer, while the interfaces are always the same. And this is very, very great. Another interesting feature is that while you are used in IoT Hub to connect on the Event Hub side to work with streaming, and we have in IoT Hub routing to service bus, to message queue, to a function, or to our Event Hub, we are not used really to work with first. No, in IoT Central, the first the Event Hub point is not accessible, but you can only route outside the message on every service you need: your service bus, your service topic, your Event Hub, your function. This is great, for example, because first you are not focused on time window of aggregation. That is, in general, is not always what you need, because if you have one sample per minute, one sample every 30 seconds, you don't really need time window aggregation that runs continuously. You're focused on give me the last sample, the last value for that variable, for that device. So routing is the first way you handle message, and this, when you think about that, is great. These are the templates. The templates are proposed architecture that you can adopt using IoT Central. Again, when you look at these diagrams, you see, okay, this is an architecture I can adopt, and you have also templates for IoT Central. This is great, because you know that if you adopt these services, this is the way Microsoft is telling you this is how many people work in this particular scenario. That can be in-store analytics, connected logistics, water quality, energy management, and so on. And so this is a good indication from the field and from who has experience on that. There is an extreme compatibility, I told you, with Azure IoT platform, because the devices are the same, the routing is the same, the external services are the same. The Event Hub platform is almost the same, but in this case, you don't have the access, but you can route to another Event Hub and you work exactly the same. So this is a good way. You start with IoT Central, and if you need, you can grow up with IoT Hub with and you throw away the minimum. And the final thing that I say, and then we show a demo, the organization. Now in IoT Central, you have organization. That means you can build up a level of organization and user-related organization. And to the organization, in a three-way, what is you affect specific devices. So if you are the OEM, you have all your devices. If you have an intermediate, you have all the devices that the intermediate manage. And at the end, you have the company where you deploy your device, and that company, that organization, look only their device. So let's go to a demo. What do I want to see? Okay, first and foremost, IoT Central is a service that may have is an Azure service. It has a few features inside here, because when you create, you have your portal, and the portal is this. Two parts in the portal. Settings, that mean configure your environment, your solution, and then use your environment. So here you define how it works. Here you work. So here you have manage your devices. Okay, for example, I have your device. Here the device template. So how is organized? For example, think in a cooking solution, you have a cooking block that is something that has restaurants, and then you have a single appliance. So you have, for example, the pasta cooker that has his temperature and power. He has the brasserie where you cook meat, and that has temperature and power. And so you have your cooking block that has both on that. You see that you have publishing. You can study your new device and publish, and so you can manage version about that. And so when you deploy, you have your devices. These are all the devices that you have, and you see these are my organization, and then you have your customer with their reseller. So these are all your devices, but you have an organization. So you have a selling infrastructure. That means you, your reseller, and the customer that are provided by your reseller. And when you have the customer, you can structure your customer, and then you can have your user that are related to your to specific organization. This is this you have a limit, because probably you ask the identity provider is the identity provider uses is Azure AD. That means Microsoft accounts or Office 365 accounts. This is currently limitation, also because the identity provided is not explicit, so you cannot configure anything about that. But I show you in a moment what you can do. I make it fast. Here you have your API tokens. So here is your security when you create your token. For example, if you want to provide, okay, I access from this customer to these resources, or from the root, with the role, what a role, for example, as an operator, generate, you have your token, and use in your application to connect to your resources via API. And this is great because you don't have to access to ID and create an app service principal, but you manage everything inside here. Just to look at that, all the devices that you see are simulated devices that inside IoT Central you can build up. A simulator. You have out-of-the-box simulator that generates for you data. I make it fast. All this code I will publish it during this day. So tomorrow you will find you in GitHub. You have a link in the slides. Okay, first I show you. So first you have API, and I show you. So certain startup. Okay, this is an API. For example, having an endpoint where you can get your telemetry. Okay, so I connect this just to look at if it is working. Get telemetry. Okay, telemetry, and you see. Okay, waiting for activation. Sorry, but I restart. Just a moment. I go inside, get string, response, telemetry value, and see here you see the telemetry for that property. That's great. Think about, okay, so with the API, you can access your data outside. What you can do with that? Okay, think, for example, that I connect from Cook as a service as IoT Central. I connect with my another identity that is associated to a specific organization. Okay, you look at the, so we have our standard identity, and I have my devices. I have configured very few, but if you look devices, you see that I look only my device, not all the other device, and you have all your identity. The nice thing is that you have your dashboard, and this is where I have configured. So a dashboard, you can pin many things, but for example, look that I have connected these actions. This is a markdown code. I click, I go, and you see that I'm going to an application that is authenticated through the same identity. I am inside my custom portal, because you can add your value connecting that data, the data from IoT Central in your application. This is the only connection that you can do. You can go back and forth from the devices, back and forth. Look at that, this dashboard. This is external content. In external content, you connect devices. You connect devices. You cannot use the same authentication. You can only use secrets. Here I have my secret passes given by URL. But you see that I have my custom portal. Another portal is a page that is not authenticated with ID, but with a secret. Okay? And here, with an API, you can click and you can collect with the data. I show you, I have a Blazor application. The two portals are Blazor, and you see dashboard. It's just a page where we have the same code that connects and obtain the value. This is a way you can extend IoT Central with your pages, so you can build your solution. But all the ingestion, all the storage is given by IoT Central, sorry. And just to show you one very, very fast thing, not showing that is working, but I reload the project just to show. This is the IoT device, and you see that is a standard device, Azure IoT Hub device, but with DPS integrated. So you have to have your connection string. You need to go through DPS information that you obtain when you are in your device, because here you have your identity, and you have your identity, and you have your device. You have your device pool which connect to DPS. This is great because IoT Central gives you the correct way to work with an IoT solution. So my time is finishing. I go back to the end slide, just to say, if you don't know how to start IoT, IoT Central is the correct way, because one service and you have a lot of infrastructure, and you can just focus on what is business for you, because everything else is almost not functional to your business, because there is just infrastructure, not value for you. I hope for improvements on organization. The identity is the correct way. Hope to have more integration with third-party code that you can add. So thank you for partners, for sponsor, thank for organizer, for the opportunity. I have a space for a question if you want.
Hi, Marco. Thanks for the session. It was a great session. As of now, there are no questions. And
Okay.
we are very short on time. Probably you can take the questions offline, as there's less than a minute.
Exactly. You have again LinkedIn. contact me, no problem. Tomorrow I will publish the code, so you have something to start with this service. Thank you.
Just a minute. There's one question. I'll just pop it
Okay.
up. You can take it offline. You can answer the question offline in YouTube.
Okay.
The question: how to remove the noise and only collect the necessary logs from IoT devices.
Okay.
Since there's very less time, probably you can answer that offline.
Okay. I write.
Thank you.
Thank you
so much.
Bye.
Thanks. Thanks for the session. Hi, Rockford. Can you hear me?
Yes, I can.
Hi, everyone. Thanks for joining the session. The next session is going to be by Rockford. It is on how to build a Raspberry Pi Kubernetes cluster. You can post all your queries on YouTube and other social media for Rockford session, and there will be a feedback URL which will be shared on the YouTube link. You can give us a session's feedback on the same. Thank you so much. Rockford, the stage is yours. You can take it forward.
All right, let me get my screen sharing here. There we go. Hello, everyone. It's a pleasure to be here. This is, I think, a fun topic. I'm going to discuss how to build a Kubernetes cluster using Raspberry Pi devices, and also some old well-used laptops. And basically, it's kind of a do-it-yourself project, so kind of fun. By way of introduction, my name is Rocky Latka. I'm CTO at SoftVision, which is a Cognizant company. Also, over the last 20 or more years, I've been writing books and speaking around the world on how to build distributed enterprise software, mostly with the Microsoft platform. And that's really what drove my interest in Kubernetes and building my own Kubernetes cluster, is because, of course, I'm all over Microsoft.NET, and I use that a great deal. And for several years now, .NET has supported compiling and running on Linux. And one of the best ways to use Linux to host software is using containers, and containers are often best run on Kubernetes. And so I'll talk through some of this in a little bit, but I want to provide this background because I think I of course started exploring Kubernetes using various things that you can install on your local machine, and I tried Azure, but neither of those were quite the right answer. So let's get into this and kind of talk through what's going on. So just to make sure we're all on the same page, a container is a hosting model for software. And the framing, or the reason that we talk about it the way we do, or why they're so compelling, is that containers in software are really very similar to containers in the real world. The idea being that if I write my software and put it inside of a container, then I can run that container on a Windows server or a Linux server or a really big server or a very small server, and my software doesn't care, right? My software is inside the container, so it isn't really aware of how big or small or anything else the hosting computer is. Also, the hosting computer doesn't really care what's inside each container, right? To a large degree, each container is the same thing from the server perspective, and so a real server can be running a container that with Linux and a container with .NET and a different container with Java and a different container with PHP, and the server doesn't care because it's just running containers. And so it's this really nice abstraction that is really powerful for us as developers because we have a predictable deployment model. Everything is a container. We write everything to run inside of a container, and we don't have to worry about infrastructure. And it's really nice for the infrastructure people because they don't have to worry about our software very much. They just have to set up hardware that can run containers. Now, obviously, there's networking and security, and I'm being a little overly simplistic, but this is pretty powerful. Another big benefit is because of DevOps. Again, my CI/CD pipeline can build container images, and that's all I ever have to worry about. And then I can take that container and I can run it in dev, I can run it in my test environment, I can run it in my staging environment, and I can run it in my production environment. And I don't have to rebuild the software at any point because all we're doing is taking that container image and choosing which environment I want to run it within. So it's good for everybody, good for developers, good for IT, good for DevOps. The way that containers are hosted is typically using Docker or something called Containerd, although there are other options that are coming along. I see that I should hide that. So typically what we have is a physical computer, and inside that computer, there's often a hypervisor and some sort of virtual machine. And this isn't always true, but certainly if you're, for example, trying to use containers on a Windows computer and probably on a Mac, this is the way it's going to be set up. If you're using containers in a Linux environment, you might in fact not have the virtual machine involved because Linux can host the containers kind of more directly. So in the past, what we used to do is we would create a virtual machine, and in that virtual machine, we would run a service or some application. And because of DLL conflicts and version conflicts and everything like that, really it was only safe to run one application or one service per virtual machine. And that's expensive because a virtual machine has a lot of overhead. With containers, what we do is insert a container runtime inside the virtual machine. Or if you're running on Linux, you might run the container runtime just right on Linux itself. And then the container runtime hosts containers, and each container typically will host or be containing one service. And the idea here is all of the benefits that I talked about on the previous slide, or for developers, for operations, for DevOps, those are all true. However, the other real big benefit here is actually environmental, and its cost. But this allows, the container model has so much less overhead than the virtual machine model that we can get higher density on each server. In other words, each virtual machine can run a lot more workloads than it could before. And that means that each physical computer can run a lot more workloads than it could before. And this is all good because we're all trying to reduce carbon emissions and reduce the consumption of electricity and air conditioning, HVAC. And so the more software we can run on fewer servers, the better off everybody is on the planet. And of course, your accounting people will be happy because this saves money too, right? It's making the best use of the limited physical servers that you have. So that's containers. Now, Kubernetes is a way of managing large numbers of containers. And this is important because if you start building software that uses microservices in particular, but other architectures too, where you start breaking down your server-side code into, instead of one big monolithic deployment, you break it down into a lot of small deployments. Instead of just having a few instances of your application, you might have hundreds or thousands of instances of parts of your application all running in different containers. And so you might end up more like that picture of the container ship, where you've got just thousands of containers running on all of your servers. And how do you keep track of that? And it becomes a really daunting task. And so Kubernetes is an orchestrator for containers. And the idea is that one of your computers will become the control plane for your Kubernetes install. And so this is the computer that manages all of the rest of the cluster. And of course, you might have more than one control plane if you've got a fault-tolerant or high availability installation. In that case, you would have at least 3 control planes that are all working together. So if any one of them fails, the other 2 can pick up the work, and then they will in turn pick yet another one to be the third. So Kubernetes in our simple environment is only going to have one control plane, but it could easily have more. And then you have at least one worker node, and probably more. Each worker node hosts what are called pods, and each pod hosts at least one container. And normally a pod does in fact host just one container. Although there are quite a few scenarios, increasing numbers of scenarios where a pod will run 2 different containers all at the same time. And I'll talk about that a little bit later. And the idea is that then I can have more and more worker nodes as I need more compute power. And so a typical Kubernetes cluster will probably have 3 nodes. It'll have a kind of a minimum, right? It'll have the control node, there's a control plane, and then it will have 2 worker nodes. And this allows the control plane to do load balancing between the 2 worker nodes. If one worker node were to crash, everything gets shifted over onto the single remaining worker node until you can get a replacement put in. Obviously, everything runs a lot slower, but at least hopefully you continue running. Now, in real life, in production environments, you probably actually have more than 2 worker nodes. You might have 3, 4, 5 worker nodes. And that's important because that allows you to do like rolling upgrades, maintenance, where you take one worker node out of the cluster. And if you've got 5 worker nodes, the other 4 pick up all of that work, and it probably doesn't get super slow. And then you can upgrade or work on that one node, and then you can put it back into the cluster, and then take another node away and do any sort of upgrades or that sort of thing. And so really, when you're looking at this, again, 3 is kind of the minimum, and more is generally a better thing. Now, how do I get container images, right? Because remember, I said that when I build my software in my CI/CD pipeline, the output of my build process is what's called a container image. And how do I get that actually running in my cluster? And the way that works, and I'm being very broad here, but the way that works is I build my image, I tag the image so that I can identify it, I push it into what's called a registry or a repository. And examples of this are, for example, Docker Hub. Microsoft Azure has a container registry. There's a whole bunch of different software that from pretty much everybody at this point has some sort of container registry. All the public clouds have something, and also you can run container registries even inside your own Kubernetes cluster. So I take essentially, we'll call it a file, this container image. You can think of it like a file, although it's actually more complex than that. But you take this file, you push it into the registry, and then your whatever runtime you have to run containers, whether that be something simple like Docker or something more robust like Kubernetes, pulls the container image from the registry onto your cluster, and then it runs it on your cluster. And so this is the workflow to get software onto or into my cluster. So what drove me to create my own cluster using Raspberry Pis is that I started because I wanted, I started first off exploring and working with Kubernetes on my desktop. And my computer has 32 gigs of memory, and it's a good computer. And I started using something called Minikube. And Minikube is a way of running, that's probably not ideal. Minikube is a way of running software that is running Kubernetes on a Windows or Mac computer. And that worked actually pretty good, but then Minikube for me started becoming unstable. And as they would release new versions, it would kind of work and kind of not work. And I just was having a lot of trouble. And so then I started running Kubernetes in Azure. And the problem with that is that Azure is expensive. When you create a Kubernetes cluster in Azure, it does in fact create three, at least by default, 3 nodes. It creates a control plane and 2 worker nodes. And it ends up costing roughly $200 US every month if you leave it running all the time. And so if you're a company, that's not a lot of money. But if you're just a developer trying to learn Kubernetes like me, then that's a lot of money, right? That's becomes rapidly very expensive. Now today, a Docker desktop has an instance of Kubernetes that you can turn on, and I find that Docker desktop has been more stable than Minikube. So that's good for single node, just experimenting on my computer. So that works. And maybe Minikube has gotten more stable. I don't know. I should try. Also, from Canonical, the company that brings us Ubuntu Linux, has something called Multipass. And if you install Multipass, it's a very easy way to create small virtual machines that run Linux on your Windows or Mac computer. And then each of those can run a Kubernetes node. And so there are increasing numbers of solutions for running a Kubernetes cluster just on your developer workstation. This assumes that your developer workstation has at least 32 or, if you're going to run multiple nodes, you want a lot of gigabytes of memory, 32, 64, and multiple CPU processors. So you need a fairly powerful computer. But I was looking for something better, right? Something that didn't consume all of the resources on my computer, and also didn't cost a whole lot of money like public cloud solutions. And so I started exploring this idea of building my own cluster using Raspberry Pi devices. The reason being that when I was looking into this was right when Raspberry Pi 4 was first coming out. And so at least here in the US at that time, the Raspberry Pi 4 was on sale, and I was able to buy them for, I think it was $50 or $55 US for each device. And so I went out and bought 4 of them. And today, because of the chip shortage and various other, the pandemic and everything else, it's harder to find Raspberry Pi devices, and they cost more than they did, a year and a half ago. So that's unfortunate. So the last Raspberry Pi that I bought was just over $100. On the other hand, instead of 4 gigabytes of memory, this new one has 8. So, that's a good thing. So this one that I just bought is a Raspberry Pi 4. You can see the red box. It has 8 gigabytes of memory. And then I also bought a stackable case, and I'll show you other photos in a minute. I guess I could pick up my camera and walk around, and in fact, what I'll do here, I don't know if you can see me in the corner, but this is in fact the device that I'm showing you on the PowerPoint is what I'm holding in my hand, the completed device that it's even got the red light. It's running. So it's an active node in my cluster right now. So this is kind of an unboxing slide. Right, I bought the Raspberry Pi. I bought the case. You can buy the stackable case as a single unit, like I did here. You can also buy a stackable case that comes with 4, or at least I did originally buy one of these that had enough to do 4 Raspberry Pis all in one box. You can see that when I open the Raspberry Pi, the red box, inside is the Raspberry Pi itself, which is roughly the size of a credit card. These things are not very big, and it has a couple of heat sinks and then some documentation. The stackable case is an acrylic case that has a top and a bottom, and then hardware to put it together. And interestingly, it also comes with heat sinks, and it also comes with a fan. And all of this is important because Raspberry Pi 4 devices generate enough heat that they need some sort of active cooling. Raspberry Pis 1, 2, and 3 did not necessarily need any active cooling. They were not as powerful, but also they run cooler. So like I mentioned, the Pi itself came with 2 heat sinks, and the case came with 3. Now, all of mine, what I've done is use the 3 from the case, and so you end up putting one on the CPU, and then the other 2 where they belong on different chips in order to siphon off the heat better. And I assume because the Raspberry Pi itself ships with 2, that probably only the CPU and this one are necessary. And we probably, it's these 2. The one in the middle is probably optional. But I'd rather be safe than sorry. So putting the case together is kind of just a simple little project. There's some instructions. You follow the pictures. It's kind of like an IKEA project. The one thing that I have noticed in all of my, now I've built 5 of these, is that these little fans, if they work at all, they're loud. And this one that I just put together, this new one, actually was the fan, when it was running, was bumping up against the acrylic top. And so you can see here, I was experimenting by putting a little shim in between the fan and the case, and I ended up and I don't know if I can show, probably not, but I ended up putting a little shim here, here, and here. So I've got 3 little shims in between, just to, and all it's doing is adding, not even a millimeter of separation between the case and the fan, but it's enough that it still isn't completely silent, but it's at least tolerable. Now, my 4-node cluster, which is my original, used a slightly different case. You can see that it's clear instead of whatever you'd call this, semi-opaque. And these fans really were loud, and one of them never worked out of the box, or maybe it did work and then it quit right away, and then another one quit shortly thereafter. And running 4 of them, it was just way too loud for me. I couldn't handle it. So I actually came up with a different solution that I'll show you in a minute. But you can see here that this picture is the front side, I guess you'd say, of the Raspberry Pi. So you've got the red power light, and then light showing disk activity, and the quote unquote hard drive here is a micro SD card, and I'll talk about that in a minute. On the back side of the each device, you've got 4 USB ports and a network connector. And then on the side of each device, you've got a power, so it gets its power from USB cord, USB-C, I think it's called, right? And then it's got 2 video outputs. These are micro or mini HDMI. And so if you end up needing at some point to connect yourself to, or connect the device to a monitor, which you might need to do, then what you'll need is either a thing that converts it to VGA, or a cable that converts it to full-size HDMI in order to be able to plug this thing into a monitor. And when I built my original cluster, I absolutely had to connect it to a monitor, and I'll talk about that in a little bit. Oh, and the final thing that I want to point out is all of these pins down the side, because you can use Raspberry Pi devices for a lot of things. And so a lot of the online discussions and forums about Raspberry Pis tend to focus on do-it-yourself projects to do home automation, or create little computers for gaming, or all sorts of fun things, right? Really fun. In my case, I just wanted them to run nodes in the for my cluster, and so I kind of ignore all of these pins down the side, except that there's a power and ground that you can use to power the fan, which I'm using on this node. But on all of these, I've actually, on my big 4-node cluster, I've got it all disconnected because I'm not using these fans. So other things that you have to have in addition to at least one Raspberry Pi, but again, you probably want I would go with 4. I did, right? A control plane and 3 worker nodes. But you're going to need some way to power them. And so you can get, and there's many options for this, but this is a powered USB hub that provides enough power to run all my devices, right? So I can run 1, 2, 3, 4, 5, 6 devices if I want to. A network switch, because you're going to want to plug these in. They can, or they do all run on Wi-Fi, But realistically, because there's a lot of traffic inside the cluster, realistically, what you're going to want is some sort of a network switch that has at least one node or one plug for each Pi device, and then one to plug into your home network. And because this is a switch, what happens is that all of the local traffic doesn't clutter up my home network. It's most of the traffic ends up being just running between the switch as the nodes talk to each other. And then if they need to, they can reach out and talk to the internet or to other devices on my network. And then I did buy, and this is actually, I think this fan is intended for sitting on top of a either an Xbox or a PlayStation in order to add extra cooling. But it's a large fan, doesn't run very fast, but it moves a lot of air, and it has rubber bumpers on the corner. So when it's sitting there, it's actually very quiet. In fact, it's almost totally silent. And so I think I've got a photo later. I'll show you how this whole thing is set up. So I don't need to use the noisy little fans because I've got this big fan that's blowing air across the entire 4-node cluster. And then obviously you're going to need 4 network cables to go between your Raspberry Pis and the switch, and you're going to need 4 short USB A to C cables in order to go from your power into your cluster. And so I bought all of this stuff. In my case, I bought it off Amazon, and I've got at the last slide here. I have some reference links, and one of them is to my blog post that I wrote when I originally built this thing, and so it's got essentially a parts list to make things easy. So once you've built the physical device, right? You've put the heat sinks on, you put it inside its case, you have the power, and you have the network. Then what you have to do is install the operating system. And so you've got some options for operating systems to run on a Raspberry Pi. The most common operating system that people install is Raspberry Pi OS. It used to be called Raspbian because it's it's based on the Debian distro for Linux, and it's customized for the Raspberry Pi. Last year, or within the last several months, they've changed the name from Raspbian to Raspberry Pi OS, and they've got a prototype 64-bit version that's not yet released. And so this is why I say maybe on this slide. When I originally tried to do this, I installed the Raspberry Pi OS because it's very easy. It's the simplest of your options. The problem is that the released version of this operating system, the operating system itself is 64-bit, but it only gives your software a 32-bit space in which to run. And at that point in time, a year and a half ago, roughly, there were very few, or maybe none. I was unable to get Kubernetes completely running in a 32-bit environment on a Raspberry Pi at that point. Everything that I found that I needed required 64-bit space. And so I ended up installing Ubuntu Server, which at that point had a very early release of Ubuntu Server that would run on a 64-bit ARM processor. And this becomes important because most of our computers, our PCs or our Macs, generally are running some sort of Intel-based or AMD, but it's all x86 or x64 rather, processors, right? It's all Intel-based at one level, and these Raspberry Pi devices are more like your phone, where they're running an ARM CPU, which is a completely different architecture. And so they're not interchangeable at all. And so the software, in your operating system and container images and utilities, everything that you need has to be available on a 64-bit ARM processor. And so Ubuntu Server had just come out with a version of their operating system that worked. Now the more recent versions, that was I want to say it was 1908 or 1910. Now the current long-term support version is 2003, and that has much better support for Raspberry Pis. And so I'm calling this out because when I built my original 4 nodes, it was a lot of work, and my blog post that I'll point you to talks about a variety of things that I don't find are necessary anymore. Things are a whole lot easier than they were just in the span of a year and a half or so. So the steps to do this are that you image your storage device, and the storage, your quote unquote hard drive, and here I'll try and hold this up. They're tiny. It is a micro SD card, right? Just like you might put in a phone or a Microsoft Surface or something. It's a one of those really tiny ones that's the size of your fingernail. And you have to image that with your operating system. And to do that, you need a Mac or a PC, and then or a Linux machine. But you have to have some other computer running that you can use to you download the image file for the operating system, and then you use some special software to write the image file onto the micro SD card. And then you plug the micro SD card into your Raspberry Pi device, and then you give it power, and then it all works. That's basically the process. So your micro SD card has to be a 32 gigabyte minimum. I actually think maybe you could install the operating system with 16 gigabyte. But in order to install Kubernetes and then also have room for container images and databases and anything else that you're doing, the minimum is 32. And so my original 4-node cluster is in fact all built with 32 gigabyte. This new device that I just built is 128 gig, just because the cost of micro SD cards has gotten cheaper and cheaper. And you can see where this goes on the front of the device itself, right next to the power. There's this little slot here, and that's where the card slides in. And that is, in fact, the quote-unquote hard drive for your device. So how do you image, how do you get the image, and how do you put it onto that little micro SD card? The easiest way is if you're running on Windows or a Mac, you can download the Raspberry Pi Imager software, and this is available from the Raspberry Pi website, and they have nice instructions for how to do this. And again, I'll provide the links for this. And so if you download this imager and run it, and again, this is so much easier than it was just a year and a half ago. This didn't used to be so easy. But today, what you can do is download and run this Raspberry Pi imager. You click the Choose OS button, and you can see in the other part of this, it gives you a list. You can do various Raspbian or Raspberry Pi OS installs, several other operating systems, and they actually just have Ubuntu Server 2004 long-term support for Raspberry Pis 3, 4, and 400. And it's a 64-bit server OS. And so I just pick that. I choose the SD card. So this does assume that your computer has an SD card reader. So in my case, I used my Microsoft Surface Pro because the Surface Pro device has a built-in slot for an SD card. If you've got an older Mac, I know they do. A lot of modern computers don't have card readers anymore. And so you might have to buy a card reader that plugs in through USB or something. But the point is that you download this image file, or actually the Raspberry Pi imager downloads the image file for Ubuntu and then writes it onto the SD card. And that process takes quite a long time, 30, 45 minutes, maybe. It's not a fast process. Once you've got the image all set up, then what you need to do is put the micro SD card into your computer and then use, well, the editor of your choice. But in my case, I tend to use the MinGW. I run on Windows. And so if you're running on Windows like I am, I've got the Windows terminal. And if I run Windows terminal, then I am running inside of Git Bash. That's my preferred environment. So if you've got a Git for Windows installed on your computer and Microsoft Terminal installed on your computer, you can set it up. And Scott Hanselman has great blog posts and videos on how to set everything up. Very nice. And you can see that from my terminal, I can run Git Bash, I can run PowerShell, I can get into my Windows subsystem for Linux instance. I can connect to my Raspberry Pi cluster. But in this case, I'm just using essentially, this is like running the Linux shell directly on Windows is what Git Bash does. And so with the micro SD card plugged into my computer, I change directory into onto the SD card, and on the SD card, there's a file called network config, and you edit network config. This is before I boot all I've done here is run the Raspberry Pi imager. I've created the image on my SD card. I have not yet put it into my Raspberry Pi. And this is an important step. So your network config file, when your device boots the first time, this is the configuration for the network that's going to be used. And so their default is not a bad default. So if it's got an Ethernet cord plugged in, it'll use DHCP as a normal device, and it will find an address. So this is good. But when you're running with Kubernetes in your cluster, Kubernetes does not like it if your nodes change IP addresses. And so for a Kubernetes node, you really need to do what I've done here and not use DHCP and instead put in a manual address. And so in this case, I've said I want an address of this is using my home network address space, right? So 192.168.0.202, and then the /24 says that it should have a network mask of 255.255.255.0. That's just an alternate notation. And then I have to specify my gateway, which is my internet router or firewall, and then at least one name server. And so I'm in this case using 1.1.1.1, which is Cloudflare. You can also use 8.8.8.8 to use Google or whatever works for you. But the point is that I'm not using a DHCP server. I'm hard coding my IP address, and so each of my nodes has a different hard coded IP address. That way they never change. You can see, they've got an example here. You can uncomment all of this and change it if you want to turn on the Wi-Fi for the device. And so that's another option. If for some reason you can't use wired connections, you might uncomment all of this, put in your correct access point information for the name of your SSID and your password, and let it connect to your home Wi-Fi network instead. And that will work. But again, as you use your network cluster, there's a lot of traffic between these nodes. The final thing that you have to do is you have to edit another file, as well as that network config. You have to edit boot firmware cmdline.txt. Although in recent versions of Ubuntu, that might have changed, that file name. But you need to add, and again, I've got links to the instructions here, but you have to add what I've got in green here. And this is because Kubernetes requires a certain set of Linux features to be enabled. And so when your device boots, you want these features to be turned on around how memory works in particular. So once I've done edited those two files on my PC, then I take that SD card out of the PC, I plug it into my Raspberry Pi, I plug a network cable into the Raspberry Pi, I put power on the Raspberry Pi, and again, you can see that here in my video. So I've got a network cable and I've got power, and you probably can't see, but I've got the SD card plugged in right here in the end. And the first time that you boot this thing, it takes a long time because it has to configure the operating system. So what I found is you have to wait 5 or 10 minutes. I guess I would just recommend plugging it in, turning it on, and then stepping away for 10 minutes, because otherwise, at least I was sitting here very impatiently waiting. But after about 10 minutes, when the operating system has completed its first boot and configuration process, then you should be able, from your computer, to open a terminal and do SSH of Ubuntu at, let's see, where am I going here? Pi 04, I think. And it should prompt you, and actually, I skipped a step here because I've done this before, but what will happen the first time that you attempt to do SSH, it'll ask you, it'll say, hey, you've never connected to this device before. Do you want to trust this device? Because you have to get a key, an encryption key. And so you answer yes. And then from that point on, your computer knows about this other device and doesn't ask you anymore, because it now has that other device's encryption key. And then it will prompt for your password. And now I've logged into one of my Raspberry Pi. In fact, the one that I keep showing you is where I'm connected here. And so you can see that I'm running Ubuntu 2004. This computer's, out of its 4 processors, has one of them that's got some activity on it. Basically, it's the system load could go as high as 4. My hard drive in this particular node, I guess actually I've only got a 32 gig SD card in it right now. I've been messing around with all this all the time. I'm using 11% of my memory. It's running at 31 degrees C. And so forth. And then you can see that there are some updates to be applied and so forth. So that kind of gets me to where I am here. So then the next step, so if you can't connect, if for some reason the SSH doesn't work, then and you can look at the dust on here, man. I had to go into my storage closet because I was having some trouble actually, and so I had to dig out my keyboard and an ancient monitor. Oh my, this thing is so old. But an old keyboard and a monitor to plug into the Raspberry Pi, because then when you boot it, it's like you're literally sitting at the console of the device, and so you can watch the entire boot process unfold. And you can log in and configure the operating or the network and some other things. You shouldn't have to do this, but sometimes it might happen. So the next step is that you need to update Linux. And this might take a while, and you need to do this regularly. I mean, we're all familiar, if you run Windows anyway, with Patch Tuesday, right? Well, Linux has the same thing. You can see I've already, and this device I put together just a few days ago, but already there are 19 updates, and one of these is a security update. So, you know, Linux, I would recommend at least updating your Linux monthly, if not more often, just like Windows. You don't want to fall behind on security. So this is the end. This is what I've got right now, plus this little one that I keep showing you here. So I've got this fan blowing right across all 4 nodes to keep them cool. My cluster now actually has 2 old a laptop from 2008, and an old MacBook Air from 2009. You know, neither of which are very useful for anything today. You know, but they are. This is the great thing. I just had these sitting around, right, gathering dust, and so I dusted them off, and I installed Ubuntu Server. Obviously, not the ARM. I installed the Intel or x64 version of Ubuntu Server. But now I've got 2 Intel nodes, and I've got 4 ARM nodes running in my cluster. So the Kubernetes cluster itself, the 2 big options that you have for installing Kubernetes are Micro K8s or Micro K8s, which comes from Canonical, and Rancher K3s, which comes from SUSE. There might be other options, but these are the 2 that, you know, everybody that I know tends to use one of these 2. I'm personally running Micro K8s because that's what existed a year and a half ago. Rancher has been rapidly coming out with better and better stuff, and so next time I rebuild my cluster, I might use K3s. So you kind of choose which of these packages you want to install. You install the software. You choose whether you want high availability or not. I have had trouble with Micro K8s turning on high availability because it uses too much resources on my Raspberry Pis, and I can't do anything else. So I'm not using high availability. And then you add worker nodes. And so the way that this works with Micro K8s is and Ubuntu is you use something called Snap, which is an easy way of installing software. And so if I go to my Raspberry Pi cluster in my terminal, and so this is my control plane that I'm logging into here, which is pretty busy, so I'll move that down here. You can see that I type sudo to become a super user, snap install Micro K8s, -- classic because it's using some older version of Snap, I guess. And that will download and install. Snap is just a command that you can run on Ubuntu, and it's just an easy way of installing stuff on your computer. Once it's running, then what you need to do is give yourself permission to interact with the cluster. So you create a group called Micro K8s, and then you change the ownership of the Kubernetes config file. And so if I look here in my home directory, I can go to my kube subdirectory, and in here I have a config file. And this config file actually contains all the security keys for my cluster. And so basically I'm making sure that I have ownership and access to it. And once I do, now I can type Micro K8s kubectl, which is the Kubernetes control tool, get nodes, for example. And it should show me that well, to start with, of course, it'll show that you have 1 node. But in my case, I've got several that I'm running. I actually have one offline right now because I'm doing some experiments with it. Now, if you want to, you can configure, and you do, you can configure, and the way that you do this with MicroK8s and with Rancher are slightly different, but they're both kind of have many of the same options. And so in my case, my cluster is running, has enabled DNS, Helm 3, an ingress so that I can talk to nodes in my cluster, a load balancer. I just started experimenting with a distributed file system, Prometheus, which gives me monitoring, RBAC, which gives you role-based authentication, which you really want, storage, which is simple storage, not this distributed file system. And I'm running traffic, which is another ingress controller. And again, I use this cluster to experiment with all sorts of stuff. So I have turned on and off some of these other options down here. Also, as time goes by, Canonical keeps adding more different service options to this list, right? So as you know, each version of MicroK8s has new options, new toys to play with. To add a node to your cluster, you repeat my process, right? So I build another Raspberry Pi, I install the operating system, I put it on a different network address. And then what you do on the control plane is you type MicroK8s add node, and it will give you this command line that you copy. See, it has an encryption key and so forth. Then you go to the worker node and you just copy, because I'm just using terminal. This is my control node. This is my worker node, right? So I can just copy from here, and go over here, and then I can paste the command line that I just copied, which was random text, but again, and you can do this on the Mac too, right? These terminals are nice this way. Paste this in, and probably a short time later, just a few seconds in many cases, you'll have a worker node running. So the last thing I really want to show you is a tool called Lens, which is a graph. This is free, as far as I know, it's free. You can download this thing, but it's a nice graphical tool, so I can see my cluster. You can see my control plane and then my worker nodes that I've got. I can click in on a worker node and I can see this one has 8 gigs of memory. This worker node has 4 gigs or 3 gigs of memory available. I can see what kind of workloads I have. So I've got a bunch of pods and stateful sets. I can even look at my pods and I can see, so these are all the pods that are running. So if I say, well, let's see, one of my distributed file system nodes is running on Pi 04. I can see how much CPU it's using, how much memory it's using on that particular worker node. Or I can go to the nodes and I can click on a node. And again, I can see how much CPU is being used, how much memory, how much of my disk, and I can scroll down and see what kind of things are running on this particular node. Now, you don't need all of those things, this graphical tool, because you can just use, oops, I don't know if it's accessible there, but you can just use the standard kubectl get nodes, get pods, all namespaces, right? So you can use all the standard tools. I'm just saying that this Lens tool I find to be pretty nice. So the last thing I want to tell you, I guess, and I think I'm out of time, is you do want to be able to access this cluster remotely. And so the steps to do this are pretty straightforward. If I look on my control node, again, inside of my .cube subdirectory from my home directory, I've got this config file. That config file has the keys to be an admin on my server. So you take that config file and you copy it from your server to your client. And so in my case, I've copied it onto my local Windows machine. And so if I go to .cube, here I've actually got I renamed it too. I renamed it config-pi because I have multiple clusters here, but this is literally the same file. And so now my computer, my desktop computer, has access to the cluster. I talked about Lens. And so with that, I hope that you've found this fun. Even if you don't want to go out and buy Raspberry Pis, if you've got one or more old laptops with at least 4 gigs of memory, that's all you need, 4 or more. You can do all of this stuff by repurposing an old laptop or two that are, maybe they've got a broken screen, maybe they're too slow, whatever. So it's a super cheap way to build a cluster and experiment with Kubernetes, both from an admin and from a developer perspective. And with that, I'd like to thank you all very much.
Thanks a lot, Rockford. That was a great session. As of now, there are no questions. We'll wait for a few minutes. If there are questions, we'll take it up, or else you can take it offline. If you get any questions, you can take it offline.
That sounds great. Can everyone see my slides still?
Yes, you can.
Because these are the resources that I mentioned. So these are different either blog posts or documentation that are online to discuss everything that I've talked about today.
Okay, there's one question, Rockford. I'm just going to pop it up. So it is, can we run Kubernetes on Android devices, or can we monitor using Android device? Can you see it?
I have no idea. That's an interesting question, and I don't know the answer. Someone would have had to have created a Kubernetes distribution that would run on Android, and I've never heard of such a thing. In terms of monitoring your cluster from an Android device, you could certainly write software to do that because Kubernetes has an API. And the other way I can think to do it is there's a tool out there called, I think it's AnyDesk, ANY Desk, that lets you essentially do a virtual desktop from your phone to your computer and be able to, I don't know, right? And then you could run Lens, I suppose, from your phone. I don't know.
Okay, hopefully that answers the question. So with that, I don't see more questions. Thanks for the session, Rockford. That was a great one.
Great. Thank you all very much.
Thank you. Okay, thanks everyone. With that, the day complete. We'd like to thank all our attendees and speakers who joined today. As part of this conference, we'd like to appreciate your attendance for the day one, and we hope to see you back tomorrow. Thank you.